theory that electromagnetism causes a 9.8 meter per second downward acceleration, then if you don't have a Faraday cage, you should get that result, 9.8 meters per second. Now, in a Faraday cage, even if it only blocks 50%, now that downward acceleration should be 4 point whatever. Or, I mean, it blocks 25. I mean, that number, 9.8, should change significantly inside a Faraday cage. It may not be 100%, but it should change significantly.
Yeah, but it'd be quite difficult due to the fact that obviously that Faraday cage is grounded because you're placing it on something that's connected to the ground. That's why I say I wouldn't do it on a building, because that building could be considered ground.
But the whole point of the Faraday cage is to eliminate within the Faraday cage. You've eliminated most of the outside electromagnetic interference. Maybe not all of it, maybe even not most of it, but enough of a significant amount that it should change the results of the experiment. If you drop a feather inside a vacuum, it accelerates at 9.8 meters per second squared.
Oh yeah, there's that feather. You aware that feather has a static charge, right?
Right. I was going to get to that.
Okay.
You drop it in a vacuum, 9.8 meters per second squared. You drop it in a vacuum inside a Faraday cage, it should change the downward acceleration to some measurable amount. Would you not agree with that statement?
Yeah. If it can be tested that majority of the electromagnetic field is being blocked, yeah. Yes, I would agree with that.
So that to me is, that doesn't seem like it's that hard of a thing to do.
It's cost efficient.
It would require some work, and you'd have to set up the whole Faraday cage and a little bit of a vacuum chamber, but still, that to me is easier. Well, I guess relatively speaking, but that to me would be easier to measure for sure than what you were describing earlier about the whole drone, 500 feet, going on top of a building, blah, blah, blah. This, what we just described, was easier than that.
It might be, actually. Maybe.
And I also think it would be more convincing. You could take as you were saying about the Gauss meter, if you take the Gauss meter, you have your vacuum, you put the Gauss meter inside the vacuum, it reads whatever it reads. Mm-hmm. Now you put this whole experiment inside the Faraday cage and you take the Gauss meter, you'll see a difference, pretty significant one I would imagine, on the Gauss meter. Now you reconduct the whole experiment inside the Faraday cage and you can see what the difference is.
I honestly think this would take more than just one person, though, because...
More than what?
One person.
It probably... it would take a while. This is not something you just put together over a weekend.
Sure.
A couple of people could probably do it over a month, maybe, or one person over a couple of months. But it's not a quick thing, and it'll cost some money. There's some stuff to it, but it's just easier in terms of the requirements and the way that the accuracy of the tools that you can buy off the shelf will be accurate enough. That whole thing that you were talking about going to a building or 500 feet, those kind of distances for measuring the mass, the weight difference, your scale, as I said, is going to have to be accurate to 5 or 6 decimal places. Those scales are, as somebody said, several thousand. Those are scientific instruments. Those are not something you just buy at Walmart. Those are expensive. So there you go. Now, in this whole hypothetical thing that we just described, what would you expect to see? We have a feather in a vacuum. It drops at 9.8 meters per second.
I expect it to.
See, this is the whole thing. If you have a model, and this is a prediction that your model should make. If your model is accurate, then your model should make a prediction that you can test and see if your prediction comes true or not. So if you have a feather, it drops at 9.8 meters per second in a vacuum. You now put this whole experiment inside a Faraday cage. Now what would you see? Okay. Are you there, Left Lane?
Yeah, man.
I was just gonna basically say that this is a much, I don't know if to say productive, but it's a better conversation than Gregory and Elijah were having, because a lot of what they're talking about is not even, it's philosophical in nature and not even scientific. I mean, it's a weird thing that they discuss.
Yeah.
And then they tend to kind of go off on tangents that don't even have anything to do with the conversation.
Yeah, it's sometimes difficult to stay on track. It goes sideways a lot.
Yeah, with them, I mean, Gregory and Elijah are difficult to talk to. I mean, they tried to sidetrack the whole thing when I was talking about Coriolis, and I'm like, I don't want to make it about Coriolis. It was just about whatever question you asked. So I didn't want to, but I mean, he wanted to do that, and I'm like, I don't want to do that.
God damn. Shit.
Testing.
2, 3, 4.
I was curious. Everything got quiet for.
Yeah,
like a
we
minute
can
or
hear
so.
you, Crit. If you could turn yourself down all the way, Crit, we would all appreciate it.
Squawk.
That's
a
fine.
squawk.
All right, so just real quick. So here's the thing. I would have. Okay, so volume times the density times is volume. I have to figure that out as well, though. Extremists, you're aware of that, right?
So
I'm not just saying electrostatics. It's relative density. I'm just trying to pinpoint the change of electrostatics. I'm trying to figure out the best way to measure, not density, not mass, not none of it, just the potential. Oh.
So let's recap for those that were not here. Our experiment, you have a vacuum with a feather that drops at 9.8 meters per second squared. Now, you take that same experiment, feather in a vacuum or whatever object, you now put it inside a Faraday cage, and you now drop this feather and see what it accelerates, the acceleration rate that it drops now, falls. Now, the question is, if it is electrostatic, then that acceleration rate should change in some way with versus without the Faraday cage.
Yeah,
Would you agree?
I would say ever so slightly because relative density does play a factor in it as well, but
Well, that was
also electrostatics. So if there is a change, that would kind of negate the electrostatics with the relative density. So I get that.
the whole point of it being in a vacuum is there is no relative density. In a vacuum, I mean, but in both cases, this experiment is in a vacuum. There's no relative density here,
Yes, the feather. It doesn't lose its mass.
but there's no change. Nothing changed. The
Yeah, the feather
medium that
doesn't
it's
change.
in is a vacuum. The feather is a feather in both cases. So the feather didn't change with and without the Faraday cage. The vacuum didn't change with and without the Faraday cage. So there's no relative. It's in both cases, it's the exact same thing.
I'm trying to get where you're getting. Are you telling me that relative density? What? You're talking about electrostatics?
No, I'm talking about relative density. In both
Okay,
of
so
these experiments, the relative density of if relative density changed, what changed to affect the relative density in this experiment?
the pressure, the
What
less
pressure? It was
density
a
air
vacuum.
around it.
It was a vacuum in both cases.
There's no resistance for air to. There's no nothing to
That
pull
didn't
back.
change. That's my point,
What do you
Don.
mean?
There's a vacuum with the Faraday cage. There's a vacuum without the Faraday cage. There is no medium that changed. So I don't understand why you say what changed is my question again. What changed? You have the same feather, you have the same vacuum, you have the same medium. What changed to affect the relative density?
All right. Well, as I said, I'm trying to isolate just the net charge, the charge. That's all. Not
I agree. And
That's
what
it.
we have set up here only affects the charge. Doesn't affect anything else, assuming that we control for temperature and humidity and whatever else you have. You have a Faraday cage with a vacuum. You have a vacuum without the Faraday cage. That's the only variable that you have changed in these two experiments. No relative density, no temperature, no humidity, assuming that all these other factors are the same between the two. The only thing that changed is the electrostatic forces inside the Faraday cage and outside.
Well, I've seen some Faraday fabric on Amazon.
Okay, that doesn't change what I said.
My bad. I was just looking at it. Trying to figure out if I can make it as big as possible. Because I want to get as high in the vertical as I can.
Well, your limiting factor is going to be the vacuum because you can only make a vacuum so airtight or whatever. I mean, it's just not going to be very big. I mean, your way that you're going to, I mean, you're not going to really necessarily measure the acceleration, I think, because that would be difficult to do. But to me, the best thing that you're going to measure is just the time that it takes when you release the feather at the top of the vacuum to the time that it takes at the bottom. I mean, you can calculate the acceleration, but if it takes 2 seconds to fall in the vacuum and then whatever time it takes to fall with the vacuum and the Faraday cage, on the globe model, because it's not electrostatics, that number should be the same. If it is electrostatics, that number should change.
It definitely would be mind blowing if it changed, right? That would blow.
That would. I will tell you this, Don. If it changes, that is a Nobel Prize right there. You have just
Don,
got a Nobel Prize.
If it changes, will you please invite me when you go meet the King of Sweden? I always wanted to meet a king.
Yes, I mean that is literally a history-making. I mean, not just. I mean, you're not talking about physics. You're talking about all of science, every branch.
You don't think
You
this
have
experiment
just changed scientific history around the world, if what you say is true. So, I mean, what did they give a Nobel Prize? $1 million, something like that? I mean,
I think it's two. I think it's
yeah,
two.
whatever it is, if you want to make $1 million, Don, based on your theory, go ahead and come up with this. There's $1 million incentive for this to be true.
So what's the thing here? What's the $1 million for?
Winning a Nobel Prize.
Yeah. But what's the what we got to prove? What's the? I missed it.
Gravity is actual electrostatic in nature.
Right.
The incoherent dielectric acceleration.
Right. Gotcha.
I think a feather would be probably one of the best materials to use due to the ability to hold a static charge. But then again, I would do different materials actually, not just once.
Well, you could also charge the chamber. Put a negative charge at the top and a positive at the bottom, and watch it speed up, and then reverse it. And of course, then the feather would have to fall up, right? Since gravity's electrostatics.
I'm just saying it's a factor in a downward vector. It's not everything. Just like your own model claims that gravity is not everything.
Gravity for attracting the feather is pretty much everything, actually.
Well, then how would you control for that static charge? Because that feather is going to have some static cling. If it's gravity, how can I can get a balloon, rub it on my head, and stick it on the wall. The wall's negative, the balloon's positive. How is that
does it stay there forever?
How is that overcoming gravity?
Does it stay there forever?
Not until the charge starts to dissipate.
Excellent. And then what happens?
What's that got to do with gravity?
Then what happens after the charges dissipate?
It'll either fall or float, depending on the helium and the air density inside.
Facts.
So did you guys concede there's no one-way speed of light testable ever done? Did the ballers concede to that, or how did that turn out?
At this point, it's undefined.
If you're referring to our earlier conversation, nobody on the globe side disputed that.
Okay, good stuff.
Now, what you had earlier on the chat was you had a couple of flat earthers, some that disputed whether the two-way speed of light was an actual thing or not.
I would say conventionally, as far as exploiting that knowledge, that it's pretty close because of the things that we do with it. That there are things that we have, instruments and whatnot, that exploit that knowledge, and it works. There's something to that.
We covered this before, Essie. Why is the speed of light the number it is? And also, why can the one-way speed of light not be measured? Why can you only measure the two-way speed of light?
You're asking me?
Yes.
Why? Well, according to what they say, is they can't synchronize the clocks on both ends. So they use the mirror and the reflection, so they get the two-way speed. But even Einstein thought, we'll just divide that by 2 and get the one-way speed. But it doesn't work that way, apparently.
Well, no, that seems that's actually true. So everything else, we can measure the one-way speed, whatever, from A to B. Why can we not measure the one-way speed of light in terms of why can we not sync the clock?
I don't pretend to be an expert on this.
I mean, that's a fair answer, but I mean, according to the globe model, there's a reason. Now, if we can't sync the clocks, you
Well,
know,
yeah, your model says relativity, right? That's the reason, right?
Yes,
Yeah.
I agree with that.
Yeah, but just saying a thing doesn't mean it's true, right?
No, that's actually kind of where I was going. Our model has an answer. Now, this is, I mean, we both agree that you cannot measure the one-way speed of light. According to the globe model, there's a reason for that. So if you don't accept that answer, then you have to come. I mean, you can't just. I mean, I guess you can say I don't know, but I mean that's not really a very good answer to me. If you don't know why that's true, then there's so many things that you wouldn't be able to engineer. So if you don't accept that answer as true, then you have to come up with an alternative answer. To me,
Not necessarily. No, you don't have to come up with an alternative because you're assuming this now. This is all assumption.
what's
right?
what's the assumption?
You're assuming that this knowledge gives us the technology, and if we didn't have this knowledge, we wouldn't have the technology, we wouldn't have the phones, the TVs. You're going down that route, right? That's the common route you guys go down.
If you our assumption that the speed of light is based on this principle is why we can engineer all of these things. That is my assumption.
Yes. I know that is your assumption, and that's what I'm trying to tell you. It is an assumption.
So?
I mean, what's wrong with that? Why is that not valid for an assumption? Why can I not make that assumption?
You can assume all you want, bro. You can assume all you want. I'm not knocking. It's entirely.
But
sorry, I'm cutting off.
You haven't answered so what yet?
No, what I'm saying, you're entitled to believe whatever you want. You're entitled to believe the reason why we can't measure the two-way speed of light is because of relativity. You're entitled to believe that.
No, it's true. The speed of light is as fast as information can travel. So you can't actually measure the one-way speed of light because the information going back to your measuring point is it travels at the speed of light.
I mean, he kind of answered it earlier when he said, if you're gonna, you have to sync the clocks, and when you move them apart, they become unsynced, which has to do with all relativity.
Because the movement through space time.
Your explanation is time dilation, and
I mean, to me,
the one brother ages faster than the other. We know that.
Yeah,
we know that story, bro.
It's not a
some
story.
of us don't believe it.
Well, I don't care if you. So what you mean?
Problem.
You're here on the computer network, the internet, not believing in that we know the speed of light when the speed of light is integrated into all the equipment that you're using to communicate right now.
It has nothing to do with what we're talking about. Technology.
Actually, it does.
Don't use that you're on a phone and you don't believe in science story with me, Pay. That's 2016 argument. Come on, you can do better than that. I don't give a shit about
2016 argument. It's still true. The fact that you are using technology that directly depends on the fact that we know the speed of light is kind of ironic. You have to admit it's ironic.
You can, like I said, you can believe to the relative.
It's not
all you want. That's evidence.
That doesn't bother me in the least bit.
Well, it should, if you actually would think about it.
I mean, that to me is evidence. If you can't measure the speed of light because the clocks desync, then to me that's evidence that idea is true. If they desync and that prevents you from measuring the one-way speed of light, then to me that's evidence that relativity is true. And time dilation.
Okay, good enough. That's good for you, and I hope you sleep good at night having this knowledge in your back pocket. But you must understand that there's some people like me that question these things.
My problem with I don't have a problem with questioning it. I don't even have a problem with, proposing an alternative theory. Don and I just spent 30 minutes doing that. But to me, just saying it's not true because you don't believe it, that to me is, I guess it's weird.
No, I gave you more than I just don't believe it.
What did you say?
I can tell you if you like why I don't believe it.
Okay, sure.
Okay, it's a fanciful story. I'll tell you why. you believe in time dilation. You think that if somebody travels at a certain speed, right, in order for your theory to be correct, that somebody ages slower than the other person, right?
Okay, so far,
You believe this, correct?
that is true. That's what relativity means. Yes.
Exactly. Now, I scoff at that. I laugh.
Well, it's proven.
And I tell you,
So,
show me this.
so your entire, when I
It's
say,
a fanciful story.
Proven.
Eh?
It's proven
hold on,
scientific
hold on,
fact.
Nat,
You-
hold on, 1 second.
You have bought into this fanciful story, and you expect me to believe it.
Hey,
So-
well, if you want to
Hold on,
disregard,
NASA, I got a point to make. Give me a second. When I said just saying I don't believe this to be true, that seems weird. Then you follow that up with your evidence that if you approach the speed of light, and you're supposed to age slower, I don't believe that's true. That's literally the same answer that's the same answer. I don't believe it's true.
No, incorrect. I proceeded to tell you why relativity is a joke, and I proceeded to tell you what you base your thing on, time dilation, and I specifically explained to you how it's ridiculous. And now the onus on you is to show us something aging slower, traveling at a faster speed. It's complete poppycock.
they've done this since the
But
70s.
see, you told us it was ridiculous, but you did not show us how it's ridiculous.
Yeah, I mean,
No,
I said,
I'm calling you out. I'm calling you out, and I'm telling you, show us this thing of which you claim is relativity.
They
Show
that
it to us.
wasn't my question to you, Montreal.
The
My
onus
question
is on
was-
you, my friends.
No. So my question was, or at least my statement was, that you don't believe that the clock's desyncing. Your evidence for that not being relativity is I don't believe it. And then you said that also, for example, the same thing applies relativity as you approach the speed of light, as you travel faster and faster, you age slower. And then literally you said, that is poppycock. I don't believe that either. I mean, you literally gave the
Exactly.
same
I
answer
am
to
laughing. Exactly. I am opening on YouTube openly, laughing at these ridiculous things that Einstein came up with called relativity,
And it's
which
been
you
proven.
guys, don't interrupt me, which you guys ought to believe.
Nope,
I am laughing at you, and I am telling you, prove it.
So
We
again,
have.
It's not
Since the
auto.
70s.
It's not an
Since the
auto
70s.
believe.
In the
There's
70s, in the 70s, they took a bunch of atomic clocks. They put them on an airplane for like 4 abreast. Took 2 of them, flew them separate directions, flew around the world. When they got back, the clocks in the airplane that had flown at normal jet speeds were slower than the ones that they left behind.
That's your
both
proof?
directions. That's proof.
That's your proof?
That's proof.
why is that
Tell
not
us
true?
how off the clocks were. Just tell the audience out there how much these clocks were off by.
Not very
No,
much
but-
because they weren't going very fast.
You
But they
tell
were
us
off.
the number. Do you know the
I
number?
don't know
Because
the
I
number
know
off
it.
the
I
top of
can
my
say it if you don't know it.
Fine, you say it. Who are they off?
Everybody get ready. The clocks which they claim prove relativity and all this nonsense, they were off by 1 billionth of a second.
No, it was more than that, I believe.
I
It was more
actually
than
was
that,
gonna
he
say-
believes.
I was
So
gonna
it's
say
even
7
worse
or 8
than that. Now, this is their proof, ladies and
That
gentlemen.
is proof. That,
Now, I laugh
that
at
is-
you and I
that is proof.
scoff at
Why
you
is that not proof? Why
for
is that not
believing
proof?
this.
Why is that not proof?
Look, if that's proof to you,
Why is
That's
that not proof? Tell
fine.
me why that's not proof.
because it's ridiculous.
No, it
That's
happened.
why.
Though.
It
The
is
clocks are
ridiculous.
Why?
1 billionth
The
of a
clocks are
second.
Why
Can you
is it
explain
Hold
what a
on a
billion?
second. I gotta go look up the experiment now.
So again, let's kind of back this up a little bit. So relativity
Yeah.
is not true because, first of all, clocks desync, so you can't measure the one-way speed of light, and also because as you get faster, you age slower. Now, speaking as your reasoning for this is, I don't believe it.
No,
For both
incorrect.
cases, I
Let me
literally
tell
don't
you
believe it.
once again, because you have wax in your ears, okay?
Oh, you're wrong
You
again.
have a theory that states that something traveling at a certain speed ages slower, called relativity. I call you out on that. I say bullshit. I tell you prove it. You tell me 4 clocks traveling on planes, and the times are off by 1 billionth of a second.
No, they were off by more than that. They're off by the eastbound clocks were off by 59 nanoseconds. The ones going westbound were off by 273 nanoseconds. So you're off by a factor of 59 and 273. But
right, so
measurable.
That's your proof of time dilation, correct?
Yep, it is definitely proof. That is considered proof. Actually,
let the audience be the judge of that.
Hold on a second. This is strong evidence that relativity is true.
Okay, so
only in your mind, sir.
No. For everybody else in science, for everybody else in science who understands that the clocks can measure time this precisely. The fact that you don't think clocks can measure time this precisely is in you, not on everybody else.
Dude, if they convinced you that somebody could age slower than the other one, the trick is on you, my friend.
59
not on me.
Hold on,
the trick is on you.
No.
I have a question about the planes. Did they both travel at the same altitude?
I want to make this point first.
Okay.
So, SC Montreal says that relativity for the clocks desyncing to measure the one way, and for you aging slower as you approach the speed of light, is bullshit. I want to see the evidence. We show them the evidence. These clocks are off by 200 and whatever billionths, whatever. And SC's Montreal responses to that, I don't believe it.
That's not I don't believe it, dude. You didn't show any proof. You just said a bunch of words, and you said and you said 4 clocks. That is not proof, sir.
They did an experiment.
That, sir, is not proof.
They took clocks and flew them around the world and noticed that they were different when they got back.
Okay.
And that proves what exactly again?
Time dilation.
What do you want as proof?
Yeah,
you can buy the snake oil off the salesman, dude.
I can't help it if you're
not me.
Well, that means
this does not pass your standard.
I'm the guy that tars and feathers.
Yeah, you're the guy. You're an idiot.
Come on, guys.
You're a guy too.
Let's settle it down a little.
What's the word I want? I have to be nice in this room. You're the guy with not enough mental capacity to understand that this is strong evidence.
When you paid Master Shield, the snake oil salesman comes to town. I expose you. I put you on the truck. I tar you, and I tar and feather you, and I run you around the town so people could see you.
Yeah, well,
okay. There was a gentleman had a question about the airplanes. Who was
that? That was Napalm.
Yes, sir.
Yeah, so the 2 airplanes, they flew in opposite directions, correct?
That's correct.
Okay. Were their flight paths the exact same, meaning that they maintained the exact same elevations, both planes, as they flew?
I don't know the answer to that question offhand.
Okay. Because it's my understanding, right, when we talk about something like GPS and the difference in the clocks. So when you increase in elevation, you increase in a mediums that we have here. The energy around us increases with elevation. Would you agree or disagree?
I don't know what you're talking about.
So there's something called a corona motor, right? So you can put something in the air and you can harness just the natural static energy in the air, right?
Oh, man.
The higher you go up, the
they
more,
accounted for that.
Yeah, the higher you go up, the more energy is there. So if we're talking about clocks that are run by the oscillation of a cesium atom, I would say that we need to further investigate how elevation may play a role in increasing the oscillation of the cesium atom.
Well,
and if there is a correlation between elevation and the increased energy and an increased oscillation or a decreased oscillation in the cesium atom, that may be a variable to where if these planes were flying at different altitudes or even had a variation in altitude that was enough to cause such a small variation in the clocks, that we just may need to rethink this or look into it and see if we're covering all the variables before jumping to a very large conclusion.
Actually, you could. Why don't you redo the experiment and account for that?
No, they didn't account for that. There's
Yes,
so
they
many
did.
variables. They didn't
No, they're
account for.
sorry.
Oh, please.
The system is pretty much isolated from itself. These things are very accurate.
So it's
Actually,
isolated from itself. What do you mean it's isolated from itself? How would I isolate myself from myself?
They're shielded from such effects. They're pretty damn stable things.
You're just assuming. You have no clue.
Oh, so do you, aren't you all? Since when are you an expert in anything other than?
There he goes with the ad-homs. He can't help it.
Not an ad-hom. Not an ad-hom. This is an
So you just assume that they took into effect a certain variable, and how about all the other variables?
Well, what about all the other variables? What about the fact that SC
only
Montreal
time
was
dilation? It's only time caused this. I mean, come on.
What else
it's the weakest argument I've ever heard.
It's not though. They've redone the experiment. They've redone the experiment. They redid it 25 years later and came up with even more precise. Do you see? There's a prediction on how much time they should gain, and they're very close to that predicted time.
Your claim is that these clocks were shielded for exactly what I was talking about. Do you have any citation that can say that they used some sort of shielding?
Why don't you read the paper yourself?
You see, that's all you're going to get from him.
Yep.
That's all.
You guys can come up and say,
has no clue
what
at all.
What about the rain in Spain? Is that going to affect this experiment? What about the fact that the ice in the Antarctic
There it is. There it is. That's predicted.
No. You just come up with bullshit things and say, well, maybe this, maybe that. What about this? What about that? What about this? No, sorry. Come up with reasonable things that will reasonably affect this experiment.
Oh, he came up with a concrete thing, altitude. And you're doing your usual thing.
They counted for the altitude.
Nothing to the conversation.
They counted for the altitude to figure out the predicted time dilation. They were very close to that prediction.
So altitude was the factor, is what you're telling me. So
altitude is a factor because
right. So is it possible?
No.
That altitude could be the cause?
No, because they've done it other altitudes and
alleged time dilation. Because the only alleged time dilation is that there was either an increase or a decrease in the oscillation of a cesium atom, not that something that we call time, which isn't really actually contracting.
How do you measure time?
You can measure time in various different ways, as long as you have something with
we measure time.
Excuse me?
How do we measure time? Do you know how you measure time? Do you know how a clock works? Is the question.
There's different kinds of clocks. I have a tag watch
and how does that work?
That operates differently from the Casio that's on my wrist right now.
I don't know. It's one
fundamentally they basically
one electric and one not.
Well, one is a quartz movement, right? So that's measuring basically a similar thing to the cesium atom.
Only a lot slower in the quartz thing, but okay.
Exactly. Right. So it's something that we can consistently have at a specific rate. And we use that, whether oscillation or the rate in which we can, I guess really the quartz kind of oscillates too when you think about it.
It's very similar to, it's similar, but okay. And the other one is what old mechanical watch.
So we're using these things to measure time because it's consistent, right? But what we're measuring is not a thing that can expand or contract. The only thing that can change is the measurement device, either speeding up or slowing down.
That is correct.
So if my quartz watch, which is usually off about 2 minutes every year, so right now it's 4 minutes off because I haven't changed the time back in 2 years. If the oscillation changed slightly, or there was a different size quartz piece of material, some sort of introduction of something else that caused the oscillation to either speed up or slow down.
What would cause that to speed up or slow down?
So, I mean,
within quartz, I think there's various different variables. They use different size and thicknesses of quartz to get different oscillation rates. If I remember correctly,
they both pretty much vibrate at the same speed.
So, slight interruption here. I posted an article about from 2010 about they were able to measure the time dilation down to 33 centimeters or 18 inches. They were using clocks that were accurate to 1 second per 3.7 billion years, which is about 18 decimal places of accuracy.
Holy smoke!
That's a cool claim, but how many of these clocks have been around for 1.7 billion years to substantiate that
Do you
claim?
understand how that works? I mean, do you think that when I say this car is going to last for 30 years, it has to last for 30 years? You measure it over a time frame and extend it.
Mm-hmm.
Yeah, how do you know your watch was off by
Extrapolate it
4
out.
seconds? How do you know your watch was off by 4 seconds?
How do I know that my watch is off by 4 minutes every 2 years?
Yeah, how do you know that?
Because that tends to be what happens. Is
But how do you know that?
every year it's off by about 2 minutes.
How do you know that?
Because I have to reset it every year
To what?
to another clock.
Exactly. Thank you.
So if you only have your
What do you mean by
watch,
that?
hold on, if you only have your watch for 6 months, how do you know it's off by 2 minutes per year if you don't have it for the full year?
I wouldn't know for sure, but I'd need to measure it. But either way,
Well, if it's off, if it's
so
off
let me
by
ask
1
you a
minute in 6 months, that would give you 2 minutes per year.
Yeah,
Right.
I mean 30 seconds per 3 months, blah blah blah.
So
if we
does
know it's
my-
off by a small amount, out
does
to
my
18
watch-
digits, then we can know it's off by 1 second in 3.7 billion years. That's my point.
Okay. So why don't we just say it's off by twice that with twice the time, and we could just go on ad infinitum forever, right?
Because if it's off by 18 digits, if it's accurate to 18 digits, then they can have,
So what is your point
18
of-
digits of accuracy. So that last digit may be slightly, there may be some question in that last digit, but the first 17 digits are correct, then you can be accurate to at least that number.
Okay, cool. So what does that have to do with anything, the alleged accuracy of this clock?
That is the accuracy of that clock. It's accurate to 18 digits.
Okay, is that just like
So let me
operation?
put this here, hold on. Let me say it a different way.
So what if that clock is moving 100 miles an hour for 20 years? How much would it be off by?
So this clock is off by 1.0000000000000000000000001 second. That's what the accuracy of that clock is.
What that is called is auto belief, model infliction, 100%.
What I'm trying to say is there's a possibility if you wanted to exclude elevation or height not being a factor within the accuracy of these clocks, that should probably be tested to see if that is a variable that needs to be accounted for when you're flying the clocks around on a plane. It could just be the elevation that's causing the difference, not even the speed at all. Did you ever think of that?
So these two clocks that I linked in this article, they are in separate rooms. The article says they're 75 meters apart by an optical cable, and one clock is 33 centimeters higher than the other clock. And they can tell the difference in the time dilation at 33 centimeters, at altitude difference, not 30,000 feet, 33 centimeters. They can tell the difference in the time dilation.
So can I just rephrase what you said and say that they can tell the difference in the oscillation of the cesium atoms at 33 centimeters
He
elevation.
doesn't realize what he just said.
Actually, I believe these clocks used aluminum.
So there is a known relationship between elevation, meaning distance from the surface of the earth, and a difference in the oscillation of the, what did you say, aluminum atoms?
Yes.
Oh, okay. So time's not speeding up or slowing down. The oscillation is either increasing or decreasing based on elevation for the various atoms that you are using to keep time.
Okay. So why does that happen? Why does the oscillation change?
I would say because there's a higher energetic increase when you increase with elevation. Makes sense to me.
But there's another thing that increases with elevation that could possibly be the correlation, right?
And actually,
Many things
is okay. I mean, it's faster as you go up, it's slower as you go down. So I guess that's, yeah, okay.
Right. So you have an increase in energy. This is just me, dummy me, thinking with my simple brain. We have an increase in energy when we go up in elevation. We can determine that through things like a corona motor that are harnessing at least the static energy that we have in the atmosphere around us. So we know that as we increase, voltage increases, the energy that's all around us increases as we increase with elevation. So it would lead me to believe if you're putting energetic things that are oscillating based on energy in a much higher energetic environment, that they would tend to oscillate quicker, meaning the energy would increase. Ergo, the oscillation would increase, the time would speed up, but time itself is not actually changing. The measurement tool you're using to measure it has just increased its rate of oscillation due to the increase in the energy.
just as good as any other theory. Yep. Well done. Prove him wrong.
That was kind of funny. I made up
that's what it
idea
is, bro.
proves it wrong. That's kind of funny. But anyway,
and to
You
really
have to admit
reverse
it's a
it, to really
possibility,
reverse it,
right?
if you, sorry,
You have
go
to
ahead.
admit it's a possibility, right?
Hey, Gio.
I mean, I was trying to think of other. I mean, the thing is, when you say things like that, it has other effects, and I was kind of trying to work through it, see if that there are other, and I haven't really thought about it the way you put it. So I mean, the first thing that came to my mind was that, so if you're going up, you're increasing your energy, and if you're going down, you're decreasing your energy, right?
Correct.
How
So it would
so?
obviously
How
tick.
so?
Well, I mean, to me, if you're going up, he said you're increasing energy. If you go back to where you started, you had to decrease your energy. I mean, it wouldn't be the same.
According to him, yeah, okay, yeah, got you, yeah.
Okay, so that makes sense. So I was thinking, I mean, as you go down, you're decreasing your energy. I mean, is there a minimum energy? I mean, I don't know. I mean, is there like a floor to it? I mean, is there, I guess you could say the same thing as you go up. Is there a
Extremis,
ceiling
you're
to this
losing the
energy?
point here, bro. He's giving you an alternative,
Right.
another thing that could have caused this.
Right. I'll answer his question. I mean, there's obviously less of this available static energy, whatever you want to call it, the closer you are to the surface, right? Whether there's a floor or not, I would say no, there's no such thing as absolute zero energy. If there was absolute zero energy, nothing would be in existence. It's a requirement, right?
So by that logic, I mean, if there's no floor, then it has this energy that you keep decreasing has to stop decreasing at some point. So where would you determine? How would you? I mean, I guess I would say, how would you know that? What would that lowest energy level be? You know, is
I
there
don't
an
know because
elevation that it stops?
I don't know for sure because it seems to me everything that we measure, the smallest we can drill down, right? When we get down to the atomic structure of things, we're talking about charge within those structures, right? So we have energy present there. And as we continue to go down and down, we just have only things that we're measuring in the form of energy. When you want to talk about quarks and gluons and things like that, they're still measuring what these things are claimed to be by their energy. So if we weren't measuring any energy at all whatsoever, you would be in an environment that would be void of energy, and energy is a necessity for the manifestation of things within 3D space. Everything that we see, touch, feel, everything we experience is all energetically based. So I don't know how you could have anything existing in a zero energy state.
So to kind of continue that idea, at sea level, like all of these clocks that we always talk about, they're sort of, I guess, standardized to, you know, standard temperature and pressure, basically sea level. And that number is whatever cycles per second. So as we go down, that number goes up. Hold on, let me think about it. It would tick, as you go down, it would tick slower. So it would actually, that number, whatever those cycles are, would actually be a smaller number.
It's a possibility. I don't know if energy necessarily decreases as you go further down in the, like if you were trying to drop these things down some type of like shaft, mine shaft or something like that.
Well, that's kind of where I was going is, I mean, you know, as you change an elevator, if it goes up, we're at 30,000 feet, which is 5 miles, and it changes in whatever number that is. Now, if you, I mean, it may not necessarily be a linear, like it may not change by the exact same number, but it should change by some number as you go 30,000 feet, 5 miles down below the Earth's surface. Now, again, at a certain point, you know, that number, I guess there would be a, I mean, you can't, that number of cycles, to me, it can't go to zero. I mean, as you said, there's not an energy level where that could be a zero.
Correct.
You know, it has to have some number. So I guess the question would be, what would be the minimum number? In what environment would be the minimum number?
I don't know if there is one. I mean,
is this relevant? Is this really
not.
relevant?
I do know that we have like we have things like the Schumann resonance, right? So that could be some sort of, if you could tie that in with some sort of baseline in some way, shape, or form, maybe. But like you said, energy needs to be present. And
right. And to say that this is relevant, basically I'm saying, if this is true, if what he's saying, and I'm not, again, I didn't dismiss it. I didn't just say, no, that's not true. Basically, what I'm working through is, what are the consequences of that statement? In other words, what would we expect to see, you know, if it has to do with energy as we go up and down, which, I mean, in the 5 or 10 minutes that I've been thinking about, it's kind of the same thing in terms of the time dilation changes as you go up and down. But
Hold on. That's a fair question, and I like your scrutiny, but I could easily turn that to you around and tell you, instead of what he said, I can put you in the same scrutiny with time. What would you expect to see in time, and how would you use time? Like, at least here, altitude, we can use it and try it, but how would you use time? How would you put that in the equation?
No, I mean,
I put you in the same scrutiny which you put him under right now. What would you say?
I absolutely agree. And that is, I mean, the thing is, the globe model does do that. I mean, you've seen all of the different, you know, statements and then whatever sources that say GPS has to account as you go to whatever 200, whatever miles up the GPS satellites are, 20,000 miles or whatever they are, then they have to correct for time dilation Otherwise, your GPS is going to be off. I mean, you're going to be off by, I don't know but every day you're going to be off by 10 feet or 100 feet. And then after, if you don't ever calculate, if you don't ever compensate for it, then after 10 days, you're going to be off by like 2 miles on your GPS or whatever. You're going to be off a
But
lot.
that's just an assumption that it's time dilation. It's not time dilation. It's the difference between the time it takes for the signal to reach the receiver to the supposed satellite. It has nothing to do with time dilating. You have to understand that it's just a term that they throw out there, an unproven, unsubstantiated term.
Well, Essie, there is a difference. There is an alleged difference. I would agree that there is as well with these clocks at varying elevations. But I wouldn't.
So what?
Right, exactly, and that's what I'm saying is the elevation, the energetic increase when you go up there just increases the oscillation of the cesium atom within the clocks. It has nothing to do
with the pressure, could be the temperature.
Right, it has nothing
to do with the radiation.
Alleged thing that we call time speeding up or slowing down in some sort of warping Star Trek.
No, the only thing that you can say is what you said before. You had it correct. The only correct statement that you can say is at different altitudes, the cesium, which is actually the quartz, I believe, that vibrates, but we'll go with the cesium atoms, vibrate at a different rate. That's the only statement you can make. You cannot subscribe it to time, pixie dust, fairy tales, nothing else. Not scientifically, anyway.
I like to take the rare opportunity to no, I shouldn't say that. I like to take the opportunity to agree with you. And the time dilation, guys, I just want to put my opinion out there. With every opportunity, it don't create no paradoxes. That's the summary. Thank you.
What we're trying to figure out, though, is why does that vibration change occur?
I'm with you 100% there. I'll spend all night with you, exploring the subject. As long as you don't tell me it's time dilation.
Well, no. And what I'm going to say is this is what the globe model says. Okay, I'm not going to say this is correct, but this is what the globe model says.
Okay, fine. Yeah.
Okay.
No arguments there with me.
If that's what I mean, and what you were talking about, the GPS correction, there's a difference between you're not necessarily just measuring the signal. You have to correct for the difference in the I don't know, I guess the time of the signal. In other words, if the signal vibrated at ground level at 10 million times, and the signal vibrates at the satellite at 10 million and 50, then you have to sync those two vibrations, basically. You just can't say there was a 30 millisecond lag. You have to sync you have to count for not only the difference in the time that the signal transmitted, but also the difference in what the clocks are off, because that's kind of the difference. The clocks are off.
Yeah,
and that's kind of what you're correcting for, is the difference in the clocks. Now, why are those clocks off? Again, the globe model says it's time dilation. He is proposing that it could be because they're way up in the air, 200 miles up, there's more energy up there. So therefore, they vibrate faster 200 miles up.
Yeah, could be that.
Okay.
The trick is to find the mechanism. Always look for the mechanism of the cause. That's the trick. If you can isolate that, you got a winner. And so far, nobody has done that. Sorry, man.
That's kind of what I was trying to. I mean, in that theory, what ramifications does that have? Okay, and then, like I said, in the last 5 minutes, it's very similar. There's not much difference, but the question that I have is, where does this energy? You're getting more energy as you go up in altitude. Where does this energy come from? I mean, it can't. I mean, it can't just come out of nowhere.
Energy
So why
cannot
is
be created. nor
Why is there more
destroy.
energy at 200 miles up than there is at sea level?
Well, they're going to try to give you the one answer of the gravity difference, but we also know there's other correlations that it could also be, right?
Well, the problem with that answer is if you're going with that answer, there's more energy as you go down and not up. So that can't be it. It can't be gravity, according to this idea.
It's a restraint, man. As you go down, they say the gravity going to restrain that.
But there's more gravity the lower you go. So there's more energy the lower you go.
Why do you say gravity equals energy? See, I'm an idiot, and I have a problem with you saying that.
Well, that's according to I guess that's okay. Forget that. I mean, that may or may not be true. But again, back to my original question, why is there more energy at 200 miles than at sea level? Where did that energy come from?
Good question. Where did energy come from?
I mean, it's not my idea, so I was waiting for an answer from you.
No, that's just the way that the energetic field in which we live in is organized, right? We can measure it. We've measured it. We measured that the voltage increases as we increase with elevation. Why is that taking place? Where did it come from? Why is it there? I don't know.
I don't think that's true.
Philosophical question.
This voltage thing that you talk about, I mean, I don't think it's true beyond the Earth's atmosphere. So I don't think it's true above, say, 30 miles. I mean, maybe I'm wrong. I don't know. I don't really know that much about it. But there's a limit to this voltage thing that you're talking about, that it's essentially limited to 30 miles, whatever. But yet we see these frequency changes. They change, keep going. I mean, this voltage change that you're describing has an atmospheric ceiling, but as you go further and further away from the atmosphere, you see more and more change in the cesium atom, but you don't see a change in the voltage.
No, but I'm sorry I'm hijacking this, but doesn't the voltage potential mean less resistance? So it's actually not more of something, it's less of something. And then
I mean, to me, if you're saying there's less resistance, then that means less ability for something to keep it from being maximum. Therefore, it would increase. If there's, if you have more voltage, less resistance, it's kind of the same thing.
Yeah, but you got to have an it there. That's the thing. And then the second, I just want to pick on. It'd be interesting to look at how far the atmosphere extends versus this gradient of potential, right?
Well, again, these are his ideas, so I don't know the answer to it. But by the way, quick thing about the whole gravity thing. When you said gravity and energy, when I was going down that path, I was thinking that as you get closer to the gravitational source, your acceleration increases, which is kind of what I was saying about there's a relationship between the more the gravity, the faster you accelerate. So there's more energy in that regard. That's kind of all I was equating. But
that's
anyway,
energy again. Yeah.
So anyway, back to this whole thing about there's more energy at 200 miles versus, sea level. And again, there's a certain, I mean, that was kind of what I was saying earlier is where's the ceiling? I mean, there is, the atmosphere is the ceiling of this voltage potential that you talk about. So where does this extra energy get? If that's 50 miles, these satellites are at 200 miles. Where does the extra energy come from the next 150 miles?
See, to me, again, you could look at it inversely, and I don't know if I'm inconsistent with your personal term. It's very likely I'm inconsistent with standard physics terms or whatever. But when you say energy, right, the energy can be in a system, energy can restrict an operation or add to the operation, right?
Hey, I mean, this is his idea, so I'm just
right. But I'm saying, so when you're looking at it from one direction, like there's more of a thing, so there should be more of this other thing. But if you're saying there's more of one thing, gravity, that could be a restrictive force on the other thing. So you're going to see less of the other thing. I think that's just where me to you, buddy. That's where maybe, you know what I mean? Like maybe you could look at it from that direction and it might solve it personally. I'm not saying I know like there's some big answer to solving some physics thing or something.
You wouldn't happen to have any experimental evidence that shows this force of yours.
Extremistes is like, Extremistes, you're more educated than me. So right here, what you're saying, I don't know. I've never heard you hung up on a standard model type of thing ever.
Hey, before you answer that, Extremistes, I appreciate you having a cordial conversation and being genuine. Thank you.
Yeah, buddy. I don't know, man. I don't know why. Can you feel me, Extremistes? Like, can't gravity be working in the other direction?
I don't know what do you mean? To me, if gravity's working in the other direction, then there would be a acceleration in the other direction. But we don't have that.
Okay. Would you do this for me? And I apologize. I'm in a rare form, okay? So let me just triple confirm that I hear the complaint or whatever. Would you just summarize concisely, like what's the issue that you have with the idea being put forth?
So basically, I may have joined the conversation late. The whole thing started with atomic clocks and their accuracy, and we were discussing time dilation.
Right.
And how these atomic clocks, they're the cesium atoms or aluminum or whatever of the clock vibrates at different rates. So there's a number, 4 billion, whatever that number is, cycles per second at sea level. Now that number changes as you go up or down in altitude.
Yes, sir.
And so according to the globe model, that the reason for that is as you get closer to or further away from the gravitational well of the Earth,
yes, sir.
then that number of vibrations changes.
Yes.
Okay. Now, his idea, I think Napalm said this, was that as you go up or down in altitude, you just basically gain or lose energy. And in a kind of sense, that's sort of true with the Earth model, except that it's kind of backwards.
Okay, so yeah, real quick. Well, let's clarify as we go along. So when Napalm claimed you go up or down and you gain or lose, which direction is gain and which direction is lose?
So as you go up, there is more cycles because time has sped up. You're further away from the well of the Earth, so you have more cycles because time is quicker.
So the material, the claim is here, Napalm. Extremistes claiming you say, as you go up, a piece of material automatically itself has more energy in it?
So my claim was that when we talk about time dilation, all we're talking about is variances in the oscillations of the atoms we're using to measure the time, right? I think a lot of people equate this time with something kind of tangible, but the increase that we see in the oscillations of the cesium atoms as they go up in elevation, I'm proposing, or at least I'm postulating, thinking about the fact that we can use something like a corona motor, and the higher up in elevation you go, the more voltage you can pull down, meaning there's a voltage increase as you increase in elevation. There's a higher energetic potential up there. So I'm just saying, is it possible that the reason that the time increases, which is just an increase in the oscillation of that cesium atom, has to deal with the fact that it's now in an environment that has more energy present?
Okay.
Meaning increasing the oscillation of the cesium atom.
Right. So I think, though, we could address the claim on its face saying that there's more energy present in the environment, right? So it seems like you're continuing that to say, well, the thing in that environment gets more energy just because it's in that environment. Why is that happening?
What do you mean? Why is that happening? There's an increase of the base energy that this small atomic thing is existing in.
Mm-hmm.
So there's a increase.
What is the base? And I'm really sorry if I'm challenging. I'm really sorry. Like, it's coming from all angles here, man. Understanding, support, criticism, whatever.
Gotcha. Yeah, you're good.
But you say base energy. What form?
What do you mean, what form?
I mean, I'm not intelligent. I'm not privy enough to understand what the base energy is.
Yeah, well, I don't know. I only have what I have as an understanding. I tend to always ask people how they would define energy, right? Because to me, it's just various ways that we can measure what we call energy. But I don't know if I've gotten a really good definition from somebody of what energy is, because it's this thing that is existent within everything.
Everything.
Right?
Exactly. Everything.
And it can't be removed, and it cannot be created nor destroyed. It can only be transferred, right?
What if it could be like hindered or harnessed or something? And what if it has its own energy? Yeah. It has its own energy, and as stuff gets closer to other stuff, they impede each other. You know what I'm saying? And so that is like, that's what I've always understood from this model. As you get away from the earth, you have less resistance from the earth. So more of its own energy is showing, or you know what I mean? It's like dancing more. Like, you know what I mean? You could, in a bigger room, you could dance more or whatever.
Yeah, it's kind of like you'd be hindered dancing in a pool. It would be much more difficult. But then if you get out of the pool, it's much easier for you to dance, right?
Yeah. So, you know, like, I don't know. You're saying it's giving. So anyway, I don't know if this helps. It seems like everybody still should be agreeing on, you know, the data phenomenon, right? But if you're challenging the gold model, I think they kind of got their shit in order, right? The atoms vibrate different because it's away from the earth, you know?
Yeah, I just have a
but there ain't no paradox. There's no fucking paradox.
Right. I just have the contention with, you know, something like this being used to say that a very simplex term of time dilation or time dilating, meaning that something other than the measuring device is somehow expanding and contracting.
Okay.
You know what I'm saying? Because to me, there's no such thing as time increasing or decreasing.
Right.
Just your measurement tool just is either speeding up or slowing down. It's not consistent.
Right. You're saying there's no like portions of this realm where, like, you know, you got multiple like somebody's got part of it on fast forward and shit. You know what I'm saying? Like,
right. No, time is just, it's a human construct that we use to just kind of demarcate events in like linear progression. Basically, it's not a thing in and of itself. You can't give it properties or attributes.
Right. But say you could give a consciousness, or you could understand that a character in a movie is aware or something, right? Or in a video, any digital thing, something we created. Hypothetically, if it was aware of its existence, you know, but it didn't understand what we could do to its realm from the outside. Like we could like play him on normal speed or fast forward or rewind or pause or turn him off and put him on the shelf and then replay him again later. Right.
Yeah.
You know, like it's possible that there's shit like that going on for us, but you know, we would never see it. Basically, everything would move relative, right? If there was consistent from the outside, everything would move relative. But we literally could be on a shelf right now, you know, or not, or whatever, you know. Like we just know this loop that we play, but we could be watched from outside at different. I don't know, man.
Yeah, I mean,
I got
when you think
step
about it,
out. I just gonna say I've got to step out for a minute, but I just want to say it's a great combo. I appreciate it, guys.
yeah, likewise, man. Yeah, it's kind of like time dilates for me every time I go to sleep because I feel like I get in bed and then boom, like that, I wake up in the morning. Time has dilated for me. There we go.
Yeah, absolutely. Yeah, I've never even heard a hypothetical like they try to do these squish the ladder in the barn or all this other fucking nonsense. Like I've never heard a practical experiment that could ever show a fucking paradox with any time dilation. It's like you could call it whatever. You could categorize shit doing what it does however you want to me. You know what I'm saying? You ain't gonna. There's not gonna be a paradox in me. It's not gonna happen. This stuff is gonna do what it does. You know.
Yeah, and that's kind of what we were talking about with the clocks. Like, what's taking place is taking place. The explanation or description that's being put forth for why it's taking place or what is the overarching thing that we can gain from this change is where I have the problem, not the changing in the oscillation rate of the cesium atom when it increases with elevation.
Right.
But
they do. Were you
equate that
challenging
to
gravity?
something called time dilation and, you know, try to wrap it into a whole bunch of other stuff is, I think more needs to be done to solidify what's taking place with the speeding up or slowing down of the oscillations of the cesium atom before we just jump to conclusions.
Were
You know what I find intriguing? How some people are easily they'll easily buy the story, and then there's other people that question it and say, "Are you kidding me? How do these people's brain work? Like, how can you convince somebody that time is actually dilating? How is that possible?"
It actually has to do. It has to be true if you accept that the speed of light is a finite speed, and also if you accept that the speed of light is the same in all reference frames. If you accept those two postulates, then the speed of the time and space must bend in order to preserve causality. Now, if you reject those two things, then you can do whatever you want.
Wow. So it's got to be one or the other in your brain, right?
Okay, but
Can't be a
wait.
third option.
But wait, though. He really wasn't disagreeing with you, SC Montreal. Okay? You know, that's the weird thing. All right?
Yeah, but how can you not just see that it's nonsense? I don't get that.
It's not nonsense. It's not nonsense,
bro. Come on.
Until they try to give us non-practical, never going to happen paradoxes based off of, you know, saying there can't be an outside observer flow. I mean, that's when it gets nonsense, SE. Right at this point, it's not nonsense.
Okay, SE, do you think that the speed of light is the absolute, there's nothing, you cannot go faster than the speed of light. It's a set speed. Nothing can travel faster than it. Do you accept that?
No, I don't.
Okay, so that's fine. Do you accept that the speed of light?
Up until today, I also believed as you did. But tomorrow, I'm going to bring something out, and I'm going to show you why I don't believe that anymore. But we'll leave that for tomorrow, for another day.
So the second question is, do you believe that the speed of light is the same in all reference frames?
The speed of light, we know changes in depending on what medium it's in.
No, that was not my question. My question was, if I am moving and I measure the two-way speed of light, and if I am standing still and I measure the two-way speed of light, regardless of the medium, as long as the medium is the same in both, do I measure the same speed in both cases?
I know what you're getting at. Personally, I haven't done it. I have no clue, but I know your relativity story. So
you got to.
Regardless, you can say anything you want, dude. It's just conclusions. You're just making assumptions.
Again,
you not understand
that. Essie, just say no again. You said no to something.
You are just making assumptions. That's
I
all
wasn't
you're doing.
asking whether it's true
You're
or false.
saying if this does that, then this means that. But you're not testing it. There's no way for you to confirm it. It's just a story that you've been sold, man. Don't you understand that?
Hold on. My question
and you're asking questions within, like, you're telling me now, don't you believe that Rudolph's nose glows? Do you not believe that the reindeer fly? And I'm telling you, dude, there's no reindeer. What's wrong with you? Reindeers don't fly.
Hold on. Stop talking for a minute. So my first question was, do you accept that the speed of light is the maximum? You said no.
I don't accept anything.
Let me finish.
No,
please.
negative. I don't accept.
Let me finish. I'm going to recap, okay? So my first question was, do you accept the speed of light is the final speed? You said no.
No, I don't accept it. No.
That's fine. I didn't challenge you. I didn't say you're wrong. I said, okay, that's fine. You have that. The globe model says it is. You say it's not. That's fine. Not going to challenge you. So my next question was, do you accept that the speed of light is the same in all reference frames? Now it's a yes or no.
I don't accept that either. No, I don't accept any of your bull. No.
I'm
Negative.
not saying if you're right or wrong. My question is, what do you believe? I'm not saying the globe model says anything. I'm not saying I say anything. I'm asking what you think is true.
What I think is true is I have no clue what light is.
Fine.
I have no clue how fast light goes. And I'm sure, this is what I'm sure of. I'm sure 100% that time dilation is bullcrap.
Okay, that's fine.
That I'm sure of.
Based on what you have just told me in the last 2 minutes, I accept that answer. Okay, that's fine.
And look, I don't doubt, you can believe whatever you want. It's just don't try to sell it to me. That's it.
I have no problem with your answer.
They have a lot of practical examples, but in my personal opinion, for both sides and any middle ground route, it's the margin of error is so slight that maybe they really don't know yet. They might not have had a big enough data set, right? We're on this small area. You have this fast speed. That's, the gray area in my opinion.
So the globe model says that time dilation is a thing because both of those other postulates are true. That's why it must be true that time dilation and also length contraction, by the way, are both true because the speed of light is the same in all reference frames, and because whatever the other one was I said, that the speed of light is the maximum.
Why don't you explain to the audience what length contraction means, please?
As you go faster, you actually strengthen. You get smaller, basically. You get smaller in length, but your mass actually gets greater.
You guys hear that? I didn't say that now, right? That's what the model dictates. That's what they have to believe in.
Where does it? If energy can't be created or destroyed, where does the mass come from?
Because it takes. I mean, I don't know if
Is it
it's a weird way to
overflow
say
from
it,
the cap of the
but
speed?
what it does is it winds up and takes more and more energy to accelerate you faster and faster as you approach the speed of light. So, I mean, that is kind of the thing is, if your mass didn't change, if it stayed the same, then it wouldn't take more energy to accelerate you.
Say
You
it
can
correctly.
still-
Your mass gets infinitely larger
Well, as you get
according to the
the
model.
speed of light, yes.
Infinite. Yeah.
At the speed of light, you're correct, yes.
Yeah, it's sheer delusion. It's sheer poppycock, man. How could you not see this, bro? How could you not see the nonsense that you've been sold, man? How?
Again, it's not that I don't believe. I don't necessarily the time dilation, the thing, all that. That's not what makes it or breaks it for me. Okay, what I accept is that the speed of light is finite. It is a large number. We know that number, and also I also accept that the speed of light is the same in all reference frames. Those are the two things that I think is true. I don't
Bro,
necessarily,
because you sound like a good guy. I almost feel like if you ever see the movie when they grab the guy, grab him and shake him and slap him a few times, like throw a bucket of water on him. That's what I feel like doing to you, man. Like telling you, like, wake up, man. Seriously.
I mean, the thing is, we have no reason to doubt either one of those two postulates.
Oh man, I give up. If you believe that, I mean, there's no talking sense into you, bro. It's like you bought the Star Trek story, man.
Okay, what is your evidence for something being faster than the speed of light? Information, not talking about that whole where they, the quantum mechanic thing where the spin changes and something else matches. That's a little bit different. But actual information.
We have
being
spooky
faster than
action at a distance, right?
Yeah, that's different. So actual information traveling faster than the speed of light.
Well, that's it. Spooky action at a distance. That's even Einstein. That's the EPR paradox. Are you aware of that?
But the problem is that's not information traveling. You cannot communicate anything with that whole idea. There's no information traveling between the two.
Well, that's the bull crap story they came up to hide the fact that there is actual information, because how would one know what the other one did? Right?
I mean,
since they're both in superposition, how would one know what the other one did? There's a paradox there. At least Einstein and what was the other guy? Something and Rosen. I forgot the other guy. P something.
Right. So that gets into quantum mechanics, and I don't really know enough about quantum mechanics to say anything on the subject.
Yeah, well, you should have a look at it. You should have a serious look at that, because that's a problem.
Okay, the second part of that question.
I'm telling you, your model is full of holes, bro. It's not my fault. I mean, I find the holes, but that's a big problem.
So the second part of the question was, what is the globe model says that the speed of light is the same in all reference frames, not the same in all mediums. We both agree that that's not true. The same in all reference frames. Do you have evidence that that is not true?
I have no evidence either way.
Okay.
I mean, no evidence either way. There's no way for me to know that.
I mean, I guess if you don't know, why do you believe it's not true? What?
Because it's nonsense, bro. I mean how many times do I have to say it, bro?
So we're specifically talking about light. I'm not talking about anything else right now. Light is the same. Light is the same if you measure the speed of light, and I'm going 100 miles an hour, or if I'm standing still on a sidewalk, I measure the light to be exactly the same down to the decimal place. Now, you just said, I don't know if it's true or not. But you also said, I don't believe it's true. So I don't understand. You know what? Let me rephrase that. You said, I don't, basically you said, I don't know, or I have evidence or can't test it.
Dude,
but I don't believe
you're
it's true.
questioning me as if you're some sort of authority on light. As if
No.
know how light travels, what the speed of it. Dude, I understand your model. You have to understand that. I'm questioning your model. So by you asking me these questions, you're going to get nowhere, man. Don't you understand that? I know what you believe. I know what you believe. I know the fantasy that you believe in. It doesn't matter what I or no, I don't believe.
I'm not asking you. I know what I believe. You know what I believe. I don't know what you believe.
It doesn't matter what I believe. It doesn't matter. You know why? Because I don't know either way. Whatever I tell you is meaningless. Because I don't know the speed of light. I don't know if the speed of light is constant. I don't know if in a reference frame. I never done this myself. Do you understand that? I have to give you an honest opinion and say, I don't know.
I have no problem with that answer.
Now, what you're going to do is, you're going to open a book and you're going to read whatever somebody said on the subject. You're going to auto-believe it, and you're going to question me based on that belief. That's what you do.
That's not where I was going. My next question was going to be, if you don't know, why do you not believe it? You said, I've never done that experiment before. Now, it's pretty hard to measure. I mean, if you actually do a Google search, by the way, you can actually measure the speed of light in your microwave.
Okay, let me ask you now. Let me ask you. If you ask me 100 questions,
by the way.
Why do you believe in time dilation?
I'm not gonna because I've kind of broken that up a little bit here. I haven't actually said time dilation. I've said the two postulates that lead to it. So by asking me that question, you're asking me, why do I believe that the speed of light is the fastest speed? And also, why do I believe it's the same in all reference frames?
No, I didn't ask you that. No, negative. I asked you, why do you believe in time dilation? In other words, why do you believe that if we have two twins, a brother here and a brother in a space capsule, and we send one out, one is going to age faster, slower than the other?
Okay, I'll answer that.
Why do you believe in that?
Because I actually just answered it. Because I believe that the postulates that the light is the fastest possible speed at which information can travel, very important thing there, and also that light is the same in all reference frames. Because those things I believe are true, time dilation must be true.
So because light acts different in certain circumstances, a person ages slower. This is your rational thought as an adult human being.
Wait, no, that's actually the opposite of what I said. I said because light is the fastest possible speed. Okay, not anything about it doesn't behave normal. Light is the fastest possible speed. Okay, that's one thing that I believe is true. The other thing that I believe is true is that the speed of light is the same in all reference frames. Again, don't confuse reference frame with medium. The same speed of light is the same. I measure the speed of light to be 290 whatever number if I'm traveling at 500 miles an hour aboard a plane, or if I'm standing still on the ground. I measure the speed of light to be the same. Because I believe both of those are true, the speed of light, the time dilation must be true.
So because of the speed of light, somebody ages slower. This is what you, an adult, is believing and trying to convince me and trying to make me look dumb that I don't believe it. Correct, sir?
No. It's both of those together. It's not one or the other.
Okay, both of those together.
Both of those are true.
Right,
if
and you think I'm crazy.
True, then the time dilation must be true.
Right.
Time dilation is proven. I've told you already, but you disregard that.
No one's talking to you, Pedro. We're not interested in you. So you think because
we have evidence.
the time.
Yeah, Pedro. Nobody talked to you, Pedro.
We have evidence, but okay, just ignore it.
So because you think of these two things, these two properties of light, you think that a human body ages slower, correct? And you expect me to believe that.
But hold up.
Oh.
Before y'all attack him, hold on. Let me on my side, SE. We talked about the stuff vibrating at different, and we kind of agreed, right? So if it vibrates different, maybe the age different. What's wrong with that?
Everything.
Come on, SE.
Time passes slower.
There's no paradox yet.
vibrates
They
slower.
haven't gotten to any of their crazy fucking. They haven't even asked you about the consistent. This has nothing to do with the consistent speed of light yet.
Don, if you're in a generous mood, that's fine with me, bro. I mean, it's up to you. If you want to give that to them, that's on you.
So
I'm just saying, like you gave it to him too, kind of. We said that maybe the stuff is vibrating differently.
So,
yeah, but we're talking about aging now. We're talking about an actual human being aging slower, bro. You got to understand that.
You're not going to wrinkle more, or if you have like 1,000 cycles in you before you die, and the cycles go faster, you're going to die faster, right?
Yeah, but it's going slower. It's the other way. It's the person that's traveling away from
whatever
the
direction
earth in their fantasy, travel ages slower. It's the other way around, bro.
He ages at the same rate, but time passes slower.
He decays his material.
You know what? You deal with them, Don. Go ahead. You have a go with them. Good luck.
Essie,
you got anything? A little bit semantical, but whatever.
Don't do the semantics, Paid, please.
Essie, you got anything other than
direct all questions to Don, please, from here on in.
Essie, you got anything other than your personal incredulity?
Look,
yeah, Paid, we know what you're gonna do, Paid. We know what you're all
Essie,
about.
You got anything other than your personal incredulity? Other than I don't believe it.
Not interested in what you have to say.
I'll back him up on I don't fucking believe. I'll back him up on I don't believe it shit.
So you got any other evidence other than I don't believe it?
We're not
Do you have any other evidence other than
Well, we're gonna go deeper than that. We're gonna go deeper. We're gonna scrutinize the evidence. We're gonna scrutinize it.
Yes, we do. We have evidence.
Okay, let's scrutinize that evidence.
Okay. The clocks. They flew the clocks around the Earth both ways.
All right. How we do that?
You take an atomic
Here's
clock.
what it was. Light is the same. The information passes the same in all reference frames, meaning like you can't run away from the information, basically. Extremesis. Correct me if I'm wrong. Is that not kind of a fair? Am I wrong?
I don't know. I was just saying, you're usually wrong, Don, so I was saying it ahead of time to save time.
That's cute. That's cute. I appreciate it. I'm trying to support you. No, but when we say it happens in all reference frames, I mean, you cannot. No, but I need you to verify. Like when you were wanting our side, and when you were like, "Hey, light it has a limit." That was question 1. Question 2 was it's the same in all reference frames, right? Like I know I'm following you. So to summarize, it's the same in all reference frames. That kind of means like if you're still and there's something a mile away, it's going to get to you in X. But if there's if there's something a mile away, but you're moving, at a speed away from it, it's still going to reach you in X. Is that not like what the claim? Like even if you're moving, the speed is the same.
Yes.
No, that's not what that correlates to.
Right.
What it correlates to, this object that's moving towards you, if you're moving away from it, it's obviously not going to catch up. But the point is that the speed of light, if you measure a light beam and you're stationary, then if you're moving at 1,000 miles an hour or 500 miles an hour on board a plane, your measurement of the speed of light in both situations will be 299 whatever kilometers per second.
Let's just say X. But the thing, right? But the thing is, let's go ahead. Walk. Okay, hold on. Okay. Walk through a couple of practical examples of what you just described.
So I've actually got this written down, but if you're on board a train, you're sitting on the platform of a train, and you
would humor me with the stationary scenario first.
That's what I'm doing. So you're sitting on the platform. There's a train going by, but you throw a baseball. It moves 50 miles an hour. If you measure that speed, you measure it sitting on the platform, not on the train, 50 miles an hour. This train is stationary. Somebody on that train throws a baseball. You're both stationary. You both see the baseball move at 50 miles an hour. Okay? Stationary.
Okay, so we're throwing forward in the direction that the train would be going to, basically.
Doesn't matter particularly. In this case, both are stationary, so it doesn't really matter.
Sure, but okay, for future. Okay.
So now somebody on this. So now the train is moving at 50 miles an hour.
Forward.
Okay, it's moving forward. Somebody throws a baseball forward 50 miles an hour. The person on the train sees the baseball moving at 50 miles an hour.
Right.
The person on the platform sees the baseball moving at 100 miles an hour.
Yes, X plus 50.
Right. So it's an additive relationship, 50 plus 50.
Now we're going to claim that light. Right. Now we're going to claim light doesn't behave that way, and it always remains at X.
Right. So if you're measuring the speed of light on the platform, it measures X.
Okay. So just for our personal relationship, can you make a mark of like, dude, Don is with you. He's not usually wrong. Right. And I know where you're going.
Okay. So Don's followed me so far. So that's a plus in your favor, Don. Good job.
Okay.
Like petting a dog on the head, but whatever. That's fine.
Hey, man. Hey. Thanks, buddy. I appreciate it.
Sorry about that. I had to fill that in. Anyway, so you measure the baseball, it adds up. Okay. But if you measure the speed of light, it does not add up. Okay. So if you're on the platform, it measures X. And if you're on the train, the speed of light is also X. There's no X plus whatever. There's only X for that speed.
Supposedly, and now we do have overwhelming laboratory evidence of this, correct? I'm pretty sure I've seen it.
I mean, I believe it's true. So yes, I would say yes. Right. I mean, depends on who you talk to apparently, but yes.
So right here, this is one of the questions you're asking SC Montreal. SC, do you have anything to challenge this? Because they have laboratory evidence for this. Maybe I'm on the gray area of maybe the scale isn't broad enough. Maybe the margin of error is so fractionally minute. Maybe we haven't discovered it yet. But still, as it stands, they have this.
So here's another, I'm kind of going a little further with this. So now you got a guy ahead of the train, and the train is now moving at half the speed of light. Okay? He turns on a flashlight. Now, the guy that's on the train sees the flashlight at the speed of light. The guy that is ahead of the train also sees the flashlight, the speed of light. Both of those cases, the speed of light. The thing is, if it were additive and the train is moving at half the speed of light, and then you would add the speed of light to that, if it is additive, like the baseball, then the speed of light would now outrace that beam of light from the flashlight would actually go faster than the speed of light. It would reach the guy that's on the ahead of the train before the actual switching of the flashlight on. In other words, he would see the beam of light before he saw the guy flip the switch to turn it on.
Now let's walk through that. That's fine, but that doesn't seem to really. Okay. Everything that is seen when the flashlight is switched on, right? There's propagation of the photons in that direction.
Yes.
Okay. So everything in that system is propagating photons towards the guy with or without the bonus movement from the train momentum.
Right.
The
But
flashlight-
the small thing is that the flashlight button, there's a little bit of difference in that distance. So the beam of the light is going faster than pressing the button. Or I should say, it's going the
you
same
got me.
speed.
You got me.
It's ahead
Then
of
you
it.
got me. You got me.
It's
then.
ahead of it. So you would see the beam before you would see the pressing of the button, because there's that 1 foot difference basically of pressing the button to the beam being emitted. So there's a difference in the distance. So if they're going the same speed and you add it, it's now both the pressing of the button and the beam itself are going faster than the speed of light, and you would see both before they actually happen. You would see the beam of light before you see the guy press the button.
Right. I don't know the last statement of both before they happen. I don't know if I'm swallowing that yet, but yeah, the beam is ahead of. That's
So
interesting. Yeah.
the beam of light is ahead of the pressing of the button, basically.
That is that we
That
see
makes
that.
sense. So you would see that beam before you see him press the button.
Are
Does that
there
make sense?
any? Yeah. Now,
If you believe
what
that,
you-
I got a bridge for you. I got a
No,
nice,
that's my point. Is
slightly used just for
that's
you.
my point, Montreal, is this cannot be true. This cannot be true because everybody may not agree on the speed. I mean, speed is relative, so people don't necessarily agree on speed and the interval between events. But everybody viewing things must agree on the order of events. So the guy on the train must see the button press and then the light come on. And the guy out front must also see the button press and then the light came on.
Wait, okay, I call shenanigans. I call shenanigans right here. This is where I'm going to say this is a fairy tale fucking paradox. You don't have to must agree. If you learn that in physics, there's a scenario where because of information travel, the thing in the front reaches you before the thing in the back, you don't have to agree on the fucking order of events. That's ridiculous. I don't agree with that premise at all.
Right. So I wanted to throw a little bit of a wrench into this, or at least get you to think about something. When you're viewing the person who's going to flip on the light, you're only viewing them because of light that is coming to you to begin with.
I agree.
Napalm, I kind of did address that. I think I did, but either way, extremists in the other direction, without seeing practical example of this, like seeing everything kind of simultaneous, this is what makes me be thinking, okay, well, this is just like fairy tale, an extreme theoretical situation. Like it doesn't even happen. All the information is like instant, all information.
I mean, the whole point, you're not going to be on a train traveling at half the speed of light. I mean, obviously that.
Exactly.
My whole point of this entire thing was that objects at slow speed are additive, but objects at the speed of light are not. And because of that, that's not a linear relationship.
But that's not the claim. Extremists, the claim is that photon, it's not about objects at this speed and other objects. Correct me if I'm sorry if I'm interrupting your point, but as you go, then maybe clarify this for me. I think it's just that certain material, the photons, do it, and that mass doesn't do it.
You're starting to see the lunacy now, Don? Starting to get it?
No, dude, I trust me. I champion this. SC, I've been a skeptic of these Einsteinian principles. Look, extremists.
Can I ask a question, Don?
Yeah, real quick. Let me spit something out while I'm thinking it.
Yeah.
Okay. It's like extremists. The point I just wanted to know was this phenomenon we're talking about. They'll claim that it has this special characteristic in direction of propagation, right? Like you can't push the light forward, blah, blah, blah. This phenomenon we just described. But then they'll say it conserves lateral momentum. You can push it sideways though, which is another fucking lunacy inconsistency to me. Okay, I'm open to the question, whatever.
Okay, so I don't know how to resolve this, but it's just sort of like the weird scenario that I have sort of as a way to like approach, some sort of understanding. And so you got like a flashlight moving just a little under the speed of light, practically the speed of light, right? And like it's just a flashlight. It's got the bulb, and then it's got like a sort of a cone around it, right? So if this flashlight's traveling near the speed of light, turns on, the photons can't go faster than a certain speed, and if the flashlight's keeping up with that for the most part, then it's gonna take a while for the photon to travel even 1 inch in front of the turned on flashlight. However, because the whole relativity thing, if you had someone moving parallel to that flashlight, it would seem to him as if the flashlight is stationary in front of him, right? Because they're traveling side by side. And from his perspective, him being still and the flashlight being still due to whatever relativity, right? Then the photon would be emitted out of that flashlight and, travel, 200 million whatever meters in 1 second. And so which scenario is right? It's like, oh, well, it depends on your perspective. But if we're talking about it in terms of photons, then, either that photon is barely outpacing the flashlight, or to the other guy, that same photon is now millions of miles away because they're both can view each other as stationary to each other. So
light is the key.
The difference in your explanation is that if the flashlight is moving at 1 million, whatever the number is, 1 million miles an hour, and you turn it on, and now this light emits, and it only goes a little bit of distance, 5 inches. The light beam is still 1 million plus that 5 inches. So if you have an observer that's moving at the same rate, then he sees the light moving at 1 million miles an hour, but he is also moving at the same speed as the flashlight, which is almost the speed of light. So the distance that the light being covered from an absolute perspective is still the same, because it's still the same from a standing still reference frame. I don't know if I said that right. I don't know.
Yeah, this topic, man, this is a topic that like all sides can come and really see a lot of mystery in the universe, I guess, can really work on the mystery of the universe together. You know what I mean?
The whole point of that discussion about the flashlight and the train and all that was not something that could happen. My entire reasoning about that was, this is a paradox. It's not possible. So therefore, the time, in order to preserve the causality of events, in order to preserve that the first person seeing the pressing the light and then also seeing the beam of light, in order to preserve the order of events, time and space must change.
Okay, look, fine, or the rules of understanding. I did give a response to that, right? And I guess I'll repeat it unless you want to interrupt me because you heard it already and you want to elaborate. But to me, that's not a paradox. It's like you're going to see the flash first and then the flick, and you the same way we see mirages in the distance. We understand there's weird rules going on. So is a mirage a paradox, Extremistas?
How can you see something happen? How can you see the
because
effect?
of the
Hold on.
because
How can you see the effect before you see the cause?
because of the rules of the universe that we just pointed out that we understand.
That's my point. Is
but dude, it's my point.
That is one of the universe's rules. is that you
Extremism.
cannot see.
There's an answer, though. The fact is, there's an answer. If there's an answer, there's not a paradox. That's the point.
And my point is, the answer there, the rules of the universe dictate that you cannot see the effect before the cause.
No, you just pulled that out your ass. You just pulled that out of your ass.
That is a rule. That is a accepted rule of the universe. You
No, it isn't. I disagree. I've agreed to everything sensible that you've said. I'm a sensible person, and now I'm disagreeing with you. Why do you say there's a rule of the universe that you might blah blah blah?
You can see the cause of something before you see the effect. You can see the baseball flying through the air before the batsman hits it.
Because of the rules of the photon, the rules of which the photons propagate. Yes, we just discovered why. You just have answered why.
No,
Don, let me answer that. Hold on. If it is true that you can see the effect before the cause, if I can see the light of the flashlight before I see him press the button, then I can send a note back to him. I can tell that guy, don't turn the flashlight on before he actually turns it on.
You damn Skippy, you can. But guess what? It's never going to work because he actually already turned his shit on.
No, he didn't.
Oh, nasty. Guys. You guys are grown. Listen, guys. Y'all are grown. You need to slow down. This is not that hard to conceptualize. Listen, hey man, shut up, bro. I want you guys to trust me as a brother intellectual. This is easy to conceptualize. Very easy.
So now you're talking time travel.
Don. You're just wrong.
You're talking time travel.
I'm telling you.
You're wrong on this one.
Dude, you've presented no paradox. You have given the answer. We have described the phenomenon, the rules of physics as of why the information has been where it's been. You've answered the question. There's no paradox.
Sorry, I just came in. What's the idea with the flashlight? You see the light before someone flicks it on.
You're giving a hypothetical in which they'd have a fucking mental paradox, but not a physics paradox.
Basically, I was describing.
What is the idea?
I was describing how the light is the same in all reference frames, and also because it's the maximum speed. Because of those two postulates, then time and space must bend in order to preserve causality. Because if time and space does not bend, then the speed of light can go faster than the speed of light, basically, and you can see an effect before you see the cause, and you cannot do that. That violates physics.
You just keep going. You cannot do that. You don't have any backup as to why it's violating anything. You're actually explaining the rules on why it's not violating anything, and then not giving any other rule on why it's violating. You really need to go here, bro. I appreciate your time. I know the audience hears me loud and clear.
Because, Don, if you can see an event before it actually happens, you can prevent it from happening.
No, you can't.
You never got the light.
You can't prevent it.
Why not? You can send a message
You're
back
talking
in time.
out of your ass.
You're talking time travel here.
Just because you can see it doesn't mean there's still a time in between the information travel.
You can see the cause before the effect. You can stop the effect before
You're not seeing it before it happens. You're seeing it before you see it happen.
How can you see it before you see it happen?
You see it before you see it.
We described how you can see it before you see it happen because of the information. Look, if there's a fire, hold on.
I'm going to tell you why.
No. I need to answer. I'm going to get off this mic. I want to make one quick point to Mole Man. One quick point.
Got a point. Yeah,
Mole
got a
Man.
point.
Yes, I got one. Mole Man. If you're, looking down a forest in a straight line and some fires happen in that forest all at the same fucking time, right? Some of them's a mile away, some of them's 10 miles away, some of them's 100 miles away. They all start at the same time. Okay?
Sure.
But we say that information doesn't come to you instantly. It has a time at which it travels to you, right?
Sure. Yes.
Well, you're going to see the first fire first, the 10-mile away fire second, and the 100-mile away fire third.
Yeah, but I never see the 10-mile fire start and then someone light the forest on fire. I always see the guy light the forest on fire first and then the fire, because the cause comes before the effect.
Listen to me. Listen. In this hypothetical, no, here's the deal. We can approach it on that. I can approach it on that. If you see, let's just go with the 1 mile away fire. The guy lighting the fire is 1.1 miles away. So you see him after the fucking fire. It's a stupid ass point. This point is so stupid.
Okay, so you're saying that the fire spreads faster than the speed of light, and in the flashlight analogy, how long is the flashlight? Like
light
fucking
speed
300 million light year?
Light speed is irrelevant to this fucking. This is fucking retarded. If you can't get the point of that analogy, you guys are retarded.
No, it is relevant because if you saw the effect before the cause, then the guy should be fucking. It can't be 100 meters away.
Arrest him before he does it.
You're talking like an idiot right now. You see the fire first. He's standing behind it. You see the fire first. As simple as that.
Okay, hold on. Why do you see the fire first?
Because it's closer.
Yeah. So then the fire has to spread faster than the speed of light in order for me to see the guy first before the fire.
That's irrelevant, dude. It's totally irrelevant.
So Don,
Extremistus, I do appreciate your time. Just think about it, man.
So back to this flashlight analogy. If the light is traveling faster and I can see the light before I see him press the button, then I can receive the light. I know he turns the flashlight on. I don't want him to turn the flashlight on. So I can actually send a signal back with another flashlight telling him to turn the flashlight off.
What, he already?
No,
but he already turned it on, brother.
Hold on. The light is the only way for this to happen is the light travels faster than the speed of light. Okay? And so I can send the signal back to him faster than the speed of light. And now he's got the signal to not turn the flashlight on before he actually turns it on. Now he can not turn the flashlight on, and now the light never got emitted, and I never saw the flashlight turn on.
You know what, dude? You know what? Hey, buddy. 5 p.m. Hey, I challenge you this. 5 p.m. tomorrow, you write me a timeline of this stuff, and I challenge you. You write down a timeline on a paper, and then you draw this shit out. You're going to realize that you're wrong, buddy. God bless you. 5 o'clock tomorrow, I'll be back. I'm listening.
Wow. This is like if I have a friend who's 100 kilometers away and he has a car that travels 100 kilometers an hour and he starts driving. It's like I see him leave before he arrives at my position.
Yes. I mean, he doesn't understand that causality is a principal, a foundational aspect of physics. Causality, you can never witness an effect before the cause in any type of, you can't see it, you can't measure it, you can't detect it through any kind of electromagnetic detection method, gravitational waves. I mean, you can't see a star blow up before the star blows up.
Hey, Extremists, I want to describe something to you.
I'm not challenging that. Don't say I don't understand it.
Right,
I'm saying you're not. You need to write your timeline. You realize you're not. No paradox. I'm done.
So I just want to say something and get your opinion on if it sounds accurate or not. But it does involve one impossibility by your standards of an object going faster than the speed of light. So if you have like a pitcher, baseball pitcher, some Superman baseball pitcher, right? 1 AU distance away. So what do we say? It takes the light 7 minutes or whatever, 8 minutes to reach you. And you have a pitcher, and I know this is an issue, but just humor me. You have a pitcher who can throw that baseball faster than the speed of light. I know that's wrong or whatever, in your opinion, But if he throws that baseball at your face faster than the speed of light, you would, and let's just say you're super tough, so when the baseball hits you, it smacks you in the face, and then it just bounces off and you don't get flung back or injured or whatever. So he throws it at you, it hits you, and then you're still looking in the same direction where it was coming from. You're going to get physically touched by that thing. It's going to hit you in the face and bounce off. And then if you continue staring at the direction, you're going to see the image of a baseball coming at you afterwards. Right?
I mean, I agree with that. What's the point of the statement? I think that's true, yes.
Right. So that's at least one thing we can settle in a hypothetical realm. And I think the photon can kind of be switched out with the baseball if we're saying that a photon can go faster than the speed we call the speed of light, which in Don's scenario results in seeing the effect before seeing the cause. Not that the effect happened before the cause, but that the effect can be witnessed before witnessing the cause. Not that they didn't happen in an order, but that's an additive. That's an additive, speed of light.
The thing is, the cause and effect, the causality has to be the same in all reference frames. So you have to see the person turning the light on or throwing the baseball before you actually see the baseball or the flashlight or whatever reach its destination. In every reference frame, the order of events must be true. Now, what changes is the time between the events. So,
will you do a timeline?
Oh, I think I know what Don meant now. Let's say you have a flashlight that is 1 light year long, and the switch is on the other end, and light is at your end. So if the guy switches the light on, I mean, it already takes the speed of light to flick it on, but let's say that it's instant. So the light will arrive faster than before you see the guy flick it on, because it's further away. But then again, the information that he flicked the switch and the light turning on takes more than the speed of light. So actually you don't see it because it travels on the same speed. Did you mean that, Don?
Guys, this is easy. If you're not willing to write it on a little timeline piece of paper, you're not doing yourself justice. I promise you. This is.
But that's
easy.
a question. Did you mean that?
I think it sounded like a good kind of summary, which up until the very last line, yeah. Like sometimes I don't know if like the inference of the conclude, but like, yeah, the chain of events, yes. The conclusion on that last line that you said, I don't know, but yeah.
Yeah, because when you flick the switch, the light or the electricity takes the same. It actually takes longer because it's not totally straight path to the bulb or the light bulb. So it'll still take more than the speed of light for the information to travel from the switch to the bulb.
Right. Dude, I just know this, dude. I'm a pattern breaker, dude. There's not a pattern break here. There's no break in the pattern. There's no logical problem at all with any of this physics stuff. The paradox is that this fucking bullshit. There's no paradox. Nothing.
So what, time doesn't pass faster as we go?
You can call it whatever you want, dude. The material does what the material does. There's no paradox.
So, but the clocks going in the airplane slowed down as they went faster. There's a time difference between the clocks in the airplane and the clocks on the ground that didn't move. That's not a paradox?
Not to me, no.
Okay, well then fine. Do you accept the results that they noticed? Do you accept that the twin so-called paradox, where one twin gets in the rocket ship, goes to the speed of light, comes back, and he's younger than his twin that stayed on Earth?
It's not a paradox to me. I don't see
fine.
why.
If you accept it as a non-paradox, then that's fine.
I accept that could be a practical phenomenon. To call it a logical paradox, I don't see that conclusion.
It's not a paradox. That's the point. That is what we're saying is what he just described is true. It's not a paradox.
Well, extremists, that's been my point this whole time, is it's not a paradox. So
not whole.
I'm sitting there saying, remember when we were arguing? Sorry, Paige. But extremists, remember we were arguing? I was telling extremists, Paige, I was telling him that because we have the reasoning for it, it is not a paradox. And that applies to the twin situation, to the train switching flashlight situation, all of that. Once we can explain the physical phenomenon that's happening, it's not a paradox.
Okay, fine. You're ahead of us then. I have problems with this one. It doesn't sound like it should work, but it does.
Well, I still think the light thing is. I don't see how the light can arrive before the effect arrive before the cause.
You're just seeing the order. The cause and stuff already happened, buddy. There's a delay before you see it.
Sure, obviously, because light doesn't travel instantly.
I think one way to put it, what Don might be saying, I could be wrong, but what he's saying is he's not arguing that no matter what speed anything's traveling at, that the cause will ever come after the effect. Like he's not saying that the cause ever comes after the effect. The cause comes first, but that doesn't mean it has to be witnessed that way. The cause will always happen before the effect, but you might be able to witness the effect before you witness the cause.
Exactly. Just like a mirage. Shit doesn't float in the air, but you might be able to see it float in the air. That doesn't mean it's a fucking paradox.
But it's not it can't happen because the information from the light switch to the light bulb takes more than the speed of light. So the light will always travel or come before someone flicks the switch.
Yeah, that's
always
the whole point is that everybody must see everything in the same order. They don't see the same amount of time between events, but they must agree on the order of events. Everybody in the universe must see the guy press the button and then see the beam of light. Everybody has to see that order. They don't have to see some people, depending on their speed, may see, I press the button and now it takes 5 minutes for me to see the beam of light. I see the press of the button and it may take 10 seconds for me to see the beam of light. But everybody has to agree that I see the button first and then I see the light.
No, we don't have to. He is conjuring this. I need a rally. We need to cure extremists from this demon he is conjuring.
No, there is no demon. Like it's like saying that you can never hear a lightning before you see it, or you can never hear a gun before you see it actually fire a bullet.
That is not analogous.
Why not?
Okay. We are presenting a photon phenomenon, only a photon phenomenon. You're analyzing photons to sound waves. That's why.
Yeah, I mean, it sounds crazy, but why couldn't you have some sort of setup? I don't know what kind of technology would have to be involved, but hear something before you see it. Like, I know that's usually the way it goes.
I wanted to challenge that too. We'll just give it to him before we say maybe in a fucking extreme case. But yeah, I feel you. I feel fundamental on that too. I'm sure there's maybe a setup where we can figure out how to hear it before we see it. But just giving that to you, it's still not analogous, Mo Man. Or who am I on?
Here's one of my. I mean, literally, I'm reading this right here. Causality is one of the most fundamental and essential notions of physics.
No one's arguing the cause.
That's exactly what you're arguing.
No. He's saying he's not arguing that causality can be messed up. Like I said, Don thinks that the cause happens before the effect. Always. The cause precedes the effect. But that doesn't mean that in every situation you have to witness the cause before the effect.
Right. You don't have to see it. Now, I got another rational individual extremist here, understanding and reiterating my point to you. I know you're intellectual enough to get it as well.
Basically, John, it's the flat earthers versus the globe earthers. The globe people
Don't
all
do
agree
that.
that causality is true.
Don't.
And also, again, to reiterate, we all, on the globe side, we all agree that everybody must see the same order of events.
We're not. Hey,
Nobody
hold
can
up!
see
You
things
changed
happen
it.
out of
Hold up! Everybody's seeing it. Everybody's seeing it is not the same as one person seeing one thing before another thing. You're fucking changing it, extremists.
Let me
Still
say it
can't
again.
see it.
No, that's some bullshit.
Everybody-
That's some fucking bullshit. And don't you fucking flat earthers versus globe earthers this shit, bro.
Everybody that witnesses something must agree on the order of events. Everybody must see the cause before they see the effect.
No,
That
that's
is true.
not true.
Everybody must agree on the order
We
of events.
all will agree. We all will agree. We see the light first, then we see the switch. Everybody would agree on that.
No.
No,
Which means we are both right, extremists. We are both right. You just aren't seeing my side of it. I've agreed to your side. Fundamental also sees my side. It is a simple, logical scenario. Simple.
Hold on. So, if there's one person that sees the light before he sees the switch, this is what I said earlier, then he can tell the guy to don't turn the switch on, and then the guy doesn't flip the switch, and then the switch never got turned on, and the light never got transmitted.
Bro, I feel that you want to create
I
this
know what
scenario
you're
in your
saying.
head.
You're saying that in one frame of reference, the switch was pressed and the light beam transmitted, but in another frame of reference, the other person saw the light and then the switch. That's basically what you're saying. You're seeing in one frame of reference, a person saw these two things out of order. And you're saying that can happen.
It's not a big deal. If you're telling me that we have understanding of physics phenomenon, this is a fake ass paradox used to prop up fucking nonsense, bro. You got to realize maybe we should start making the case that information is instant, man.
I have an analogy for you. Let's say I'm in a field and I have a sound system that is 100 meters away from me. So it is 100 meters closer to you than I am. And it's voice activated. I have to shout in order for music to come out of the sound system. Is there any way that you can hear my sound before the sound from the sound system?
I guess this is the same as the light scenario, but you're talking about the local all, right? And then passing information back and forth. So yeah, it depends on like where you're orientated, right? From the origin, right?
Sure.
So that's it. I mean, it's the same. If you're going sound to sound, that's analogous to light to light. I appreciate you modifying.
Yep. But still, when I'm further away than the sound system and it's voice activated, you can never hear my sound before you hear the sound from the sound system.
Here's what's irking me. It should not be a paradox that we understand one thing is in front of another thing. That is basically what you're trying to claim is a paradox. One thing is in front of another thing. Ooh. It's like, what? It's not a fucking paradox at all. It's nothing. It's nothing.
Because you always see the effect before the cause before the effect.
No, but think about it. We just talked about orientation again a moment, and then it's like, oh, but the people are going to auto order the people on the left and the right and the front and the back, and it's like, It's not a paradox. It's just it's fucking orientation. What's the problem? It's like shit gets tricky. That doesn't mean it can't happen. Shit can get tricky. What are you talking about? It doesn't mean you're going to be able to send something back and fucking go back and talk to them before it happened. What? It's fucking ridiculous.
Yeah, but I don't still. You'd still see the guy switching the light on before you see the light.
It's not that relevant. That's not that relevant. It gets weird where they want you to grant them that as if it's some magic, so then they can go, look, you can go back and tell them before they switch it. No, motherfucker, like, nah, bro, you ain't fucking go.
No, but are there any like not hypotheticals about this? Can you show this happening somewhere?
You draw me the timeline, man, and then we'll work on it. You draw me one timeline you want to recreate. We'll see if we ever can show that. You're fucking right.
I mean, the timeline would be me observing the cause and then the effect.
Here's another one. So this idea that I had earlier, instead of a flashlight, I have a light, like a light bulb. So this light bulb emits light in all directions. Okay, left and right. So I have a guy on the light bulb. There's a switch on the wall to the left of the light bulb, and then there's a guy, a light year to the left of that, and then there's a small 100 meters between the switch and the light bulb, and then there's another guy to the right of the light bulb, 1 light year away. So if the guy flips the switch,
I'm lost.
So there's a guy so start left to right. There's a guy there's a guy here at point A. There's a guy to switch to the light bulb at point B. 1 light year separates them. 100 meters to the right of that guy, the switch, is the light bulb. And then another light year to the right of that is another guy. So there's 3 guys, there's 4 points. One guy A, the switch is B, the light bulb is C, the far right guy is D. Okay, is that better? So if the guy at point B flips the switch, who sees the beam of light first from the light bulb? The guy at the far left or the guy at the far right? I don't know if I explained that very well. Maybe I didn't. Maybe that's a bad example.
Fantasy door number 1 or fantasy door number 2?
In my head, it made a lot more sense because the whole point of that was I was trying to kind of explain, or instead of having a flashlight that just kind of shines light in one direction ahead of you, I was kind of trying to show that the people behind you and the people, to both sides see the same order of events. The people behind you and the people out in front. So there's an order to events that all 3 people agree on. The guy far to the left sees the guy press the switch and the light come on, and he sees that order of events. The guy that presses the switch and then sees the light come on, he sees that order of events, and the far guy on the right sees the guy press the switch and then the light come on.
I think I have to say no.
On the order
I don't agree. I think I have to say no here, and I'm sorry. You're talking about a central. Are you talking about a central point and then out in the distance from the central point, from the origin, north, south, east, west, left, right, front, back, or whatever? That's what you're talking about?
Yeah, I mean, again, there's 3 guys,
right?
And there's a light that's 100 meters away. They're all in a line, and there's a light that's some distance.
Okay, 3 in front. 3 in front in a line.
There's a guy over at point A. 1 light year to point B is another guy at a switch. Then the light bulb is 100 meters away, or whatever, 500. It doesn't matter the distance, some X distance. and then to the right of that, or beyond that, next in line is another guy 1 light year away. They're all in a line. So if the guy presses the switch and then sees the light, all 3 of the people agree that the button was pressed or the switch was flipped, and then the light bulb came on. They all agree on the order.
Wait, the switcher. Wait, what's in between the viewers? Is it viewers, and then in the middle is the light bulb, and then the switcher is on the opposite side, or is the switcher in the middle?
The switcher, so there's a guy on the far left and a guy on the far right, and there's a light bulb and a guy and a switch in the middle.
Okay.
And the switch and the guy in the middle are separated by some distance. Okay? So the guy presses the switch, and the guy at the switch sees, I press the switch, I see the light come on.
Instantly.
Okay, pretty much. The guy on the far left sees the guy press the switch and then sees the light come on.
No.
That's the guy on the far left.
No.
Okay, well, the guy on the far left.
May I explain to you? May I explain?
Let me finish before we say whether it's right or wrong. So the guy on the far left sees the switch pressed and then the light come on. The guy on the far right sees the switch pressed and then the light come on. Everybody agrees that the switch was pressed and then the light came on. They all agree on the sequence or the order of events.
Okay, my bad.
But what they don't agree on is the time between events. So one of them will see the press of the switch and then see the light a little bit later and say, I saw the button pressed and then I saw the light 5 seconds later or whatever. And another guy will see, I saw the button pressed and then I saw the light come and I saw that happen 1 second apart. Okay? And then the guy in the middle will say, I saw the button press and I saw the light immediately, basically. But so they don't agree on the timing between events, but they all agree that the button was pressed and then the light came on and I saw the light.
First of all, buddy, I go back. Yeah, I can agree with if there's the left and the right and the middle and they all see. I don't think you have that last thing you said about this. No, because again, to see the guy flip the switch, that's photons, the same as the photon that's going to come out of the light. So the order is going to be the same. But bruh, I don't care if you got a guy seeing an order differently, right? This has nothing to do with a paradox. Okay, if you have the orientation like you're saying, a left and right, if you have one guy in front where the light bulb is in the middle and he's behind it, you have another guy in the back where the switcher is in the middle, you know that you're going to have a witness of the ordering, right? So why do you have a problem with that? Like, you keep going on and on. It's like, I want to entertain these hypotheticals you keep pointing out, extremists, but there doesn't seem to be a problem. You're just saying, hey, there's a simple ordering, okay? But we know because of orientation, right? Stuff is going to appear based on that perspective of the orientation. Why is that a paradox when we understand the orientation is the answer to the quote unquote paradox?
Don, quick thing. Are there any mods here to unmute Ryan?
I don't know.
Yeah, if there's any that hears me.
I got look, my boy's almost done, bro. I'm about to get off here after this. But extremists, is orientation not the answer to the perspective issue? You know what I'm saying? Like, hey, this guy has that perspective, this guy has that perspective. Isn't it as simple as that?
No, because again, and I think this is part of the problem, is the speed of light. So in my example, the speed of light is the same in all reference frames. So
hey, can I try and describe Don's point
for everybody?
Got it, but let him. Okay.
Let me try and back Don up because they're thinking of the two-way speed. I think.
We're gonna cue you up. He's in the middle of it. You next, Brian.
Yeah, all right,
When you're done, extremist, when you're done, and then pass to Brian.
So, I mean, I don't know how to answer your question except to say, to reiterate my point, it's not about perspective. Nobody in this entire example of these three people in line, none of them are going to see the light before they see the press of the switch. They are all going to agree that the switch was pressed and then the light bulb came on. They all agree on that, all three of them. None of them will see the light bulb come on and then the switch get pressed. None of them will see that.
That point doesn't.
Let me do it in the form of a question, okay? So you're thinking all y'all's. I think I'm backing Don up here by saying this. I think y'all are thinking in terms of two-way speed. So let's say this. Let's say we're standing, and the fire is 1 mile away, right? And the switch and the guy pushing it are 2 miles away, right? But we're standing in the dark, so we can't see nothing. But we're looking in the direction of the fire. So quit thinking in two-way terms. And so if the guy hits the switch, and then the signal travels at the speed of light to set the fire, okay. And then the fire starts. You're gonna see the fire first, right?
Oh,
because it was dark. It was dark before that.
Are you gonna see them at the same time?
Wait, what do you mean the same time? If the light's closer, if the fire is 1 mile away, you're gonna see it first, right?
No, because the information travels at the speed of light also. And the light from the guy flicking the switch will travel at the speed of light.
No, it was dark though. It was pitch dark.
It doesn't matter. We're talking about that. Oh god, we're not talking about him.
Let me give you another example. Okay, all right. The guy is 1,000 miles away, and the fire is 1 mile away. The guy, and you're standing in pitch dark. And so is the guy.
No, that's not the case. That's not the case in this. We're not talking about that. We're not saying that you can't see the guy because it's dark.
Well, I'm trying to boil this down because this is what y'all are basically disputing.
Point. No, it isn't.
No, well, what happens? Answer my question on this because I'm very curious as to y'all's answer. So if the guy,
you wouldn't see the guy. You wouldn't see the guy. But when you saw the guy, you wouldn't see him flick the switch because he already did it. You wouldn't.
Okay.
You'd never see him flick the switch.
Okay, I got to clarify that. Look, some of the verbiage extremists that we've been saying when he flips it, I realize me and you may have been a little inconsistent there, but the orientation is the important thing, right? You got to think about the direction of propagation. When you quote unquote flip the switch, the light being in front of that guy, that orientation, right? All that information of his action, right, is propagating in the same direction as the light will propagate to somebody orientated in front of that. The sideways people and the backwards people, it's going to be different. You're not going to call those different reference frames, I don't think, because they're not moving, right?
But in my analogy, with the field and the sound system, you will always hear the guy first before the sound system. Doesn't matter the orientation. The difference between the time that you hear the guy and the sound system depends on the orientation, but you would always hear the guy first.
Because of the light delay?
Huh?
Because of whatever delay from the equipment delay, from the whether it be percussion delay or actual radio delay. Yeah, okay.
Oh, it doesn't matter. The speed of sound in this case would be constant. So when the guy, let's say that the sound system is between you and the guy. The guy says,
agree. I do agree.
Yeah. So you always hear the cause before the effect.
Wait a second. I gotta refine my idea, man, because I might put a kink in this. Okay, so the guy is 1,000 miles away, right? And the fire, or the guy's 2 miles away. The fire is 1 mile away. Okay, the guy hits the switch. Okay, and then no. I'm sorry. The guy is 1 mile behind the fire, and you are 1,000 miles away from the fire. Okay, so the guy hits the switch, and the signal travels at the speed of light to light the fire, right? So the fire lights the guy up before the light from the fire. Hold on. The fire lights the guy up before the light from the fire reaches you. You see what I'm saying? Because you're 1,000 miles away. So if the light,
no one's saying that would not happen. No one is saying that would not happen.
Ain't nobody shit. Look, if you want to fucking present a paradox, look, motherfuckers is claiming paradox. You need to show me.
I got a question though.
I can see this. I can see this shit in frame by frame, clickety fucking click video from any fucking orientation expansion. Unless you're gonna show me frame by frame timeline where there's a fucking paradox, you ain't talking shit. Ain't no one saying shit. That's it. Done.
You haven't shown the timeline of using the effect before the cause.
I didn't even get to ask my question though. So if that scenario that I just said happens, well, let me ask a question. You'll have no problem answering it. If that guy does that and you're 1,000 miles away, so the fire reaches him before the fire reaches you, okay, do you see the fire first and then him?
No, you never see him flick the switch if he's in the dark. So it's a moot point.
But in your scenario where you see the fire first and then him standing behind it after?
No, we're not talking about that. We're talking about seeing the cause and the effect. We're not talking about seeing the guy.
Yeah, okay.
Yeah, you're talking about something totally different.
Yeah, but you still should be able to answer that question.
Sure, you would see the fire before, but you'd never see the guy flick the switch because he would be in the darkness. So you'd never see the effect.
See the fire, but you would see the fire before you've seen him, though. That's what you're saying.
Yeah, but seeing
in a
him
one-way,
isn't seeing the cause. No, but seeing him isn't seeing the cause.
Got you.
Because you never see him flick the switch, because when he flicked the switch, he was in darkness. Because this happens every time when you flick a switch. Like if I have a flashlight on a dark room and you flick the switch, you would never see the guy flick the switch because he's in darkness before he flicks the switch. It happens every time.
It seems to be a difficult concept to understand.
I'm trying to figure out what the hell y'all are talking about.
No, I was trying to back Don up a little bit, but because I was tried to write it down, but I think what he's leaving out is the fact that it takes time for the signal to reach the. I think he might have left that part out in his mind, maybe, or maybe I'm missing something. I'm trying, because I try and describe shit. Sometimes it takes me 10 times before people understand it. So I'm trying to get understand exactly what he's saying, because in my mind it would take the time for the signal itself to light the fire from the button would have to also travel to the light. So I don't know.
Can you see people in the dark, Brian?
Don't back this conversation up. I'm hoping Don explains his point a little, refines it a little bit.
You see people in the dark, Brian? Right, you can't. So you wouldn't see him flip the switch.
Yeah, that was my point, that if we're talking about seeing the guy or not seeing the guy, then you'd never see him flick the switch because he'd be in darkness.
And then if he flips the switch and the electricity travels to light the fire ignites, and then the light travels from the fire to visualize him. Well, that light has to bounce off of him and travel to you. So it has to go further to for you to see him than for you to see the light.
But Don's point is that you somehow, if there's a light switch and then a light, that you would somehow see the light before someone flicks the switch, even when you see the guy flicking the switch all the time. So it's nothing to do with someone being in the dark.
I think I should apologize for being the one that brought up this whole thing about causality and whatever. I'm sorry to everybody for making it such a good show.
I like the dark.
Fun to think about. So we can never see the cause before the effect. But
No.
I can't get away. I can't find a way around that. Even hypothetically, I can't find a way around that either.
It's the other way around.
So time travel will never happen, basically.
You always see the cause. Sorry, you always see the effect after the cause. You see the cause first, and then you see the effect. The order is always.
You got it right the last time you said it.
No, he's always said that it's the cause before the effect.
Right. We always see the cause.
Everybody in the universe, no matter where you are or what reference frame you're in, you must agree that you see the cause first and then the effect.
Time travel or information travel will never happen, no matter what. Because
what you see the changes is the time between the cause and the effect. So that not everybody will agree on, depending on reference frame, but everybody agrees on the order of events.
No, they don't. Not at relativistic speeds.
Wait, what?
Yeah.
At relativistic speeds, order of events can be relative to the observer.
No, you're right in terms of the time between events, but the sequence is always the same. Everybody sees the same order of events. They always see the cause and then the effect, even at relativistic speeds. The difference is at relativistic speeds, the time between the events is different.
I'm uncertain about that. I would need to.
That's one of the tenets of physics is causality must be preserved.
So, in other words, the guy's getting old. So the guy's getting older, the twins getting older simultaneously. So in other words, when he comes back, they're still going to be on the same damn time. He just aged faster, basically. So you're not breaking causality.
You can't grow younger. You're always growing older.
Right, and so the times are still aligned. When he gets back to Earth or whatever, or circular or whatever the scenario, the clocks are going to read the same for both of them. The one's just older.
No, the clocks ain't gonna look the same because he's younger. Yeah.
Right. So he's going to get back, and so he aged. So everybody agree with that? He aged, but they're still, shaking hands 60 or 10 years later, or a year later, whatever. They're shaking hands, looking at the same clock on Greenwich time, UTC or whatever, GHT, but one of them's 60 years older or some shit. Something don't seem right with that.
Why?
Because you're seeing the effect before the cause in that scenario.
What's the cause and what's
you didn't see him aging or any of that shit. You just seen the effect of him being an old man all of a sudden. So just the statement itself kind of breaks causality.
No, what's the cause and what's the effect in that case?
The cause is he was hauling ass for so long, and he's old. Is he older or younger? I know how to word this. The guy who was hauling ass. Okay, the guy hauling ass is younger. So him hauling ass. Okay, so the point is that the effect is when he gets back to Earth. The effect is he sees his brother old as shit, but he didn't. Did he see the cause too? Did he see?
And I don't like what the cause is. The speed. So do you observe the speed? You see him go away and then come back. Sure. And I don't kind of get the question.
Well, I'm just the effect is Well, the effect I'm trying to describe, I'll try and find a better way to do it, is the difference in aging.
Let's say
The
he's
age
traveling
difference of the
around the
twins.
Earth. Let's say he's orbiting the Earth at 99% speed of light, and that would be the cause for him aging slower. So you would see him travel around the Earth and then come back. So you would see the cause before you see him young. Just still see the cause.
Wait, no.
Of him.
It would have to be the guy doing the orbiting who sees the cause. If he's the one that's younger. If he's the one that's younger, it'd have to be him seeing the cause, right? Because hold on, if it's the guy, who's older, if the guy who's older, you're saying he's seeing back in time, then. So yeah, we can go with that.
No, he's not seeing back in time. And if you're saying that the guy traveling has to see the cause, then yeah, if he's traveling, then he sees himself traveling.
No, you said the guy's watching the dude travel. So if the old man is watching the young man travel, then he's basically watching him go back in time, is what you're saying.
No, time's just slower for him. It's not going back in time.
No, it would be faster. If you're saying, you started off by saying if you're watching the guy orbit, okay? The guy orbiting near the speed of light is the young one, right?
Yeah.
So your scenario of if you're watching him orbit,
hold on.
You're
What is
getting
the case?
old just from watching him orbit. That'd be the cause and effect, basically. You see what I'm saying?
Sure, but you see him orbit, so that's the cause.
So you grew old from watching him orbit.
No, that's not the cause why we. It doesn't. It's not that because because now no one's orbiting at the speed of light, we still get older. That's not the cause for me getting old. Obviously
I'm about to say I'm not watching. I'm not looking up anymore, man. If that shit's that's what's making me get old, man. I'm keep my head down.
Yeah, stop it. Just look down and you get younger.
Obviously, you can't travel at the speed of light, so it's a nonsense conversation.
Yeah. But if you travel at the speed of light, then the time wouldn't pass.
I think they say that the guy has to leave Earth anyway. I don't think he can. I think I've heard that before, where they're saying that if he just stays around Earth, then nothing really changes. I think he has to. I'm not 100% sure, but I feel like I've heard somebody say that, where they have to go away from you, and then come back or some shit.
It doesn't have to go away. You just travel at the speed. You can just go round and round and round.
So basically, you know what? I'm mind fucking my own self here. Give me a minute.
Make it simple for yourself, Brian. Just say to yourself, this is a crock of bull. You don't have to entertain it.
Yeah, but it's still, Montreal, it's food for thought, though, because there's consequences if you wait. If I understand this correctly, I'm not sure if I do, but if I do, there's a consequence to light not having a speed. Whether it be the same, whether it be different, whether it varies and shit. I think there's a consequence to that. I think there's a consequence to light having a speed limit, and I think there's a consequence to light not having a speed limit. So really, we should start from the beginning if we're going to talk about this. And what are the consequences from a relativistic standpoint if light didn't have a speed?
Let me put this to bed for you, Brian, so you can put this out of your brain. Okay, let me tell you one of the things that they claim. Okay, and you'll see how ridiculous this is.
I bet this isn't the thing.
You have two brothers, right? One leaves in a spaceship, travels at the speed of light, ages slower. So that means that the brother on Earth, right? That means that the Earth had the speed that travel around the sun faster than the other brother. You understand what I'm saying? In other words,
yeah,
you have to. It doesn't work. It's like ridiculous. It's like just think of that.
I'm not completely. I'm not on board. I'm not really on board with that, man. But what are the consequences if light doesn't have a speed?
It's not our claim,
It's
so
nonsense.
why would you be on board? No one said it. No one said it that the Earth would travel different speed
Well,
around the sun.
how would the brother on Earth age faster then? If
No, it
time
doesn't
is the
age
revolution of your Earth around the sun, 1 year,
It doesn't
in order
age
for him to get,
faster.
let me finish. In order for him to get older, that would mean that the Earth would have to travel faster around the sun, correct? In your model?
Nope. Because he's
What
not.
do you mean, no? No.
Because I'm trying to answer. Keep interrupting me. Because the guy isn't aging faster. The one guy is aging slower.
And how is that happening? How is he aging slower then?
Because he's traveling fast.
So what if they're watching each other?
so
What
what?
if they're
So
watching each
what?
other the whole time? So if he's
No,
in orbit,
it doesn't matter. SE is right. It doesn't matter whether it's the speed of light or the speed of sound or what speed it is. Time is going to be the same for both parties. When the other dude gets back after a year away, they're both going to be only 1 year older.
Yeah, that's
Exactly. Exactly. And he ain't going in no spaceship and no vacuum either. It's all fantasy. All of it.
No, but you brought it up as a fantasy, so no one's done it.
well, my
I didn't
question
bring it
is,
up as a fantasy. I'm exposing the fantasy.
does relativity claim that? Is that a fact that?
Even though there's no no evidence that it can't happen. That's what would happen if relativity
But
is true.
Mo-Man, let me ask you a question, Mo-Man. Is that a consequence of relativity that that if one of the twins goes the speed of light or in orbit and for a year and he comes back and he's younger than the guy who didn't, is that a consequence of relativity?
Sure, I think so. Yeah.
What if they're watching each other the whole time? What if the guy who's younger is watching the guy on the ground, and what if he's doing like a halo over the ball Earth, and the guy watching the baby, or let's just say he doesn't leave until he's 10. They're both 10 years old, and they're watching each other through a telescope the whole time.
Sure.
What's going on with them? What?
Well, I don't. You'd see the other guy traveling at the speed of light, close to speed of light. I don't know if you have to move in order for you to see him. You have to move at the same rate. So
would the 10-year-old see the guys on Earth, his brother's beard growing and shit? Like,
no, that's why. That's
would
why
also
the bending
travel
of
at the same speed. That's the problem.
the
You see
bending of
his hair
space
turning white, his beard growing. Sheer nonsense. Good one, Brian.
Still travel at the same speed as that
Only
guy.
in your brain.
The bending of space time is redundant.
this came from Brian's
such a load of crock. There's no such thing as the bending of space time.
Yeah, Brian. You would also travel at the same speed, so it's gonna.
It doesn't matter if you're going light speed. You could go up the road in your Chevy and do a 360 around Chicago and come back. Does that mean that the other person aged slower?
I mean, if you're talking about relativity, then sure, but it's so minuscule that it doesn't bother. Like if you put clocks on airplanes, you will see that, but it's just a minuscule.
It doesn't matter what speed you're doing. It's not going to affect aging for the other person.
It will, though.
Yeah, wait. You say you put a clock on an airplane. That's a big jump to say time itself. So look, just because you put a clock on an airplane and flew it in a certain direction, then the cesium atoms are freaking oscillating faster. But everything else is happening, at regular rate, and the cesium atom gets back. I mean, you could equally say that by traveling fast with the cesium atom, by sending them a certain direction, that they live twice as long, that they last twice as long, or by oscillating them fast, they last twice as long. That's equally credible as the saying that time itself is speeding up. That's crazy.
The clocks run slower.
Yeah, that's backwards there.
Yeah, but you could just be doubling the half-life, by going fast. You could just be doubling the time, the half life of it.
No, basically,
Yeah, but that would
your
also double
clock
the
is just
half-life of you. Why would it not affect you too? If it affects cesium atoms, why doesn't it affect the atoms in your body?
Yeah.
It might.
every atom is a clock, Brian.
Yeah.
Yeah, no, there's an oscillation.
You'd age. No, yeah, but the oscillation is the same in the cesium atoms that it is in your body. So you'd age slower too, just like the atom.
I'm good with that. I'm good with that as in terms
Okay,
of
well, then
in your
you're a
model.
different age. Then you're a different age. Yeah.
No, I'm good with all that as far as within your model. My question is you're not. He made a point. Excuse me. He made a point earlier that if you don't calculate the time, basically, Peyton S. Show was asking how do you know that it lasts 4 minutes, but if you only watch it for 1 minute, you just measure the time that it changed in 1 minute and multiply that times 4. But the whole point is this: is that if it's you're not watching it for 1 billion years, okay? So to say that it's 1 billionth of a second is just a calculation. You could be expanding the light. You could be doubling the life of it instead of cutting the time in half. You could just be doubling the life of the atom. Is what I'm saying.
But if you double the life of the atom, then you just double the life of the human. So he would just live, instead of 80 years, he would live 460 years.
Yeah.
No. You're talking about 7 billionths of a second, right? If you're talking about 1 billionth of a second.
Yes, because we're not talking about someone traveling at the speed of light. We're talking about an airplane traveling around the Earth.
Right, 1 billionth. Okay, but
sure.
But
so you agree?
I mean,
so you agree that there's a difference in time, whether you travel or not?
Wait. No. I'm agreeing with you. But my point is this: is if you say that it only changes 7 seconds in 1 billion years, without watching it for 1 billion years, you couldn't know that.
Brian,
you can say what it changed in them few hours and do the calculation, but you can't say that the clocks are synced to 7 seconds in 1 billion years, right?
And if you go faster, this clocks slow down more and more and more.
Dan, what do you mean with you can't say that it's 7 seconds in 1 billion years? Are you saying that it's not a constant?
Well, if you don't, my point is if you don't measure it for 1 billion years, you can only measure it for the few hours and calculate it over the 1 billion years. You see what I'm saying?
Okay. So if I drive my car 100 kilometers an hour for 10 minutes, I can't say that I was traveling 100 kilometers per hour because I wasn't traveling for an hour. That's your claim now.
No, you can't say that you traveled 100 kilometers if you only traveled 10. Correct.
You didn't say you traveled 100 kilometers.
I said I traveled at 100 kilometers per hour. You're saying that it's impossible if I didn't travel for 1 hour.
No, I'm saying that it's impossible to say you're going to travel. No, what I'm saying is if everything goes smoothly, you'll travel 100 miles. But there's a million things that can change, different variables.
No.
At that rate, Hold on, let me agree with you first. Let me agree with you. As far as calculating it out, it'll calculate out to you traveling 100 miles. If you go 10 miles in say 1 minute, then in 10 minutes you will go 100 miles. But you can't prove that you're going to go 100 miles until you actually go the 100 miles.
What are you talking about?
The claim isn't me going for 100 miles. It's just the speed or the rate of travel. I can see I'm traveling. Yeah, it's weird.
Just doesn't seem to be getting it.
You agree? Yeah. You agree with me, though, right?
No.
No one agrees with you. I can say that I'm driving at 100 kilometers per hour. I can say that after being driving that speed for 10 minutes. Correct?
Sure.
Okay, so then I can say that the clocks are changing at the rate of 7 seconds per billion years, even though I haven't seen it happen.
Yeah, at that rate. Got you. Yeah. Sure.
So it just tells
that's
you
what I was saying is it calculates out to 1 billion years.
No, you just said that we have to observe it over 1 billion years.
Is
Yeah, I
that
must
why?
have misunderstood.
Is this the reason why pilots all have grey hair and they all get really old really fast because they're traveling faster than any other human?
No.
Because it's stressful.
Yeah, it's painful almost. Funny.
It's just ridiculous. I mean, just the thought of even entertaining that you could travel the speed of light. That's just a nonsense argument.
No one here has ever said that you can travel at the speed of light. So.
Let me ask Mo-Man a question. Mo-Man, what are the consequences if light is instantaneous? What are the consequences? I'm not trying to set you up, man. I'm being honest. Like, I'm trying to think this through completely.
Sure. You would see everything at once, and you couldn't do any experiments with light. You couldn't do the double. The fiber optic gyros wouldn't work because they use the phase change. You wouldn't even have the phases of light or anything. It just would be instant. Nothing would work. Computers won't work.
No. Okay, so yeah, I see what you're saying. Does everybody agree with that?
No, I think you have to be more specific. I just got here, so maybe you guys are like speaking in a different context.
Well, you came at a perfect time, bro. Because I'm trying to back the whole thing up.
Let's say
you're talking about the round trip time being the same, but then just one way would be instantaneous, and the other way would be like 3.0 times 10 to the negative times 10 to the 8, or whatever it is. Then, I think that's possible. I don't see why anything physically would have to be different if one trip was instantaneous.
Then you can't have.
That's a good point.
You couldn't have double slit experiment because you have photons traveling through slits.
Sorry?
Yeah, the light does travel.
Why would that change anything?
Because it'll go through a slit, and you measure it going through it.
You still do know what the fuck is going on with the double slit and with light.
Well, you can't measure light if it doesn't travel through a slit.
Yeah, I don't know about that.
If the speed of light was infinite, you couldn't measure anything because it takes time to measure things.
Because even with the double slit, you have the detector, and it's going and hitting it's not even like you're not even seeing the light. You're seeing like the residue, like the burn of this light that's supposedly going 3 times 10 to the 8 meters per second squared or whatever. You're not actually seeing the light itself.
So what are they measuring?
Yeah, so they have energy that they're measuring on a detector.
Then, yes.
That doesn't mean that it's going at a specific speed.
Well, it has to travel in order for you to detect it.
Yeah, and maybe it's traveling instantly.
Oh, no, that's not a thing. You can't travel instantly. It wouldn't travel.
Hey, hold on. You gotta have a Mo-Man.
It's not possible.
Mo-Man, you gotta have a better cause though, Mo-Man. If all you can say is the double slit or something like that, can you think of a better, like a down to earth paradox? If like you're saying, we witness it maybe at a certain speed, and the reflection happens at a certain speed, but the light itself, that's an interesting point that Percentage just brought up. So the one way is instantaneous, but we're witnessing it at our own rates.
But it's simple in the double slit. You see the photon, there's a photon detector that detects the photons hitting a wall, so it has to travel. It just does travel.
Is the phone in double slit? Are they detecting the two-way speed of light or the one-way speed of light?
No speed of light. They're detecting light hitting an object.
Yeah, but is it one-way or two-way?
They're not testing the two-way speed of light. They're not testing the speed of light.
Yeah, how can you
know
hit
that? But is it one-way or two-way?
What do you mean with that?
You cut out.
What do you mean with that? I said that they don't measure the speed of light. They just detect collisions, and if light passes through a slit or not, has nothing to do with the speed.
Just my point is they're detecting energy, right? Is this energy from the round trip of the light, or is it just from the one-way trip of the light?
They detect photons. It's photon detectors.
It's detecting energy. Photon is a packet of energy.
Yes, light is energy. Yes, we know this.
Yeah, so then you detect traveling like the collisions, which means that it has to travel of photons, energy.
Yeah, so my question is, this energy that it's detecting, is it energy from the round trip of light or from a one-way trip of light?
What in the fuck does that even mean? How can you hit something two
Well,
ways?
you
I
have
don't
to
know how
understand
many times
that
I have to
Brent is really
repeat it.
stupid, and he just doesn't understand this stuff.
Brenda, shut up, man.
Brenda, watch it.
Brenda, you say the dumbest shit sometimes. Just stay out of it for a minute. Let them discuss it.
Is it a one-way collision or a two-way collision? That's what you're asking now.
Yeah, no, my point is that this light is coming out of the beam splitter, right? And it's being detected, and it's being observed. Now, for the light to be observed, light has to reflect to the observer. So, yes.
No.
How else would we observe it?
The detector detects it. You don't observe. You don't have to observe it. It can happen on a lab where there's no one in there. I mean, you don't need to.
So all you're saying, well, man, then all you're saying is we detect it instantly, and it propagates at a speed. You're just saying opposite of what he's saying.
Oh, what do you mean? What do you mean detect it instantly? Never said anything about the time that we detect it.
You're maintaining that this light from the beam splitter is the one-way trip of light, and because it's going a specific speed, we know that the one-way trip of a light is that speed. That's taking time to be detected, right?
I've never said anything about speed. I'm saying that if light hits an object, then it has to travel, because you can't hit something without travel.
Yeah. So because it's taking time to hit the thing and be detected, light therefore is traveling and is not instant, is what you're saying, right?
No. It hits something. You can't hit something by not traveling. You have to travel. You have to carry momentum.
If it travels instantly, that's the whole point. It's instantaneous travel. That's the whole point.
No, light does not travel. Light takes time to travel, Brian. Light takes time.
I'm good with listen.
Yes,
I'm not
round trip
denying
it
that,
does,
Brenda.
but
I'm
it
just
might
stating
be
his
one
point.
trip instant. You don't know still. And
Yeah,
just because, and it could be that the one trip that you're detecting that's taking time is the trip that is the one that takes that has a speed of 3.0 whatever, and the other trip that you're not detecting is the instantaneous one.
That's just illogical to me.
It's called. Hey, we'll call it space
call it
light.
illogical, but it's
space
possible.
light bending.
No, it's not
so what it
possible.
is, we'll call it space light bending, and we'll say that it's traveling the distance instantaneous, and it takes us a little bit of time to observe it, whatever's observing it. So what happens is the energy bends space light.
Yeah, that's
Brian,
just nonsense.
define travel for me.
Right. So the light.
Let me define travel. It's instantaneous.
Travel is to go from one destination to another.
Fucking retards.
Shut up, Brenda. I'm fucking joking, man.
Easy with the name going.
You can't travel instantaneously. That's not a thing. It wouldn't be
You don't
traveling.
know that.
No, but that wouldn't be traveling then.
From one area to the next. It could go instantly. Yeah. It's traveling instantly.
Oh. Then if I have a stick.
If you have an issue with the word travel, that you think it has to take time, then that's your own definition that you've kind of subjected onto us that I disagree with in terms of this context.
Oh. But whether you can have instantaneous travel, it doesn't matter. Light still travels. It just moves. It's not instantaneous.
Maybe it is on one trip of it.
Yeah, like if you put a DVD in the player, okay, that light's already traveled. In the movie, like a guy watching the sunrise, that light's already traveled, 100 times or however many times somebody's watched it. But it's happening instantaneously. Pretty much, it's already happened. It's instantaneous.
What in the fuck?
I'm just throwing out some scenarios, man. I'm not trying to make claims. I'm just throwing out scenarios to get everybody thinking.
I hope so. But yeah, let's take a fiber optic gyro. You have different phases of light, so it can't be instant.
Yeah, but you still have to have movement, okay? You're moving in the fiber optic gyro. You're moving the mirrors, okay? So that's still but no. Listen, I'm not saying that you're wrong, but what I'm telling you is that it's not. That doesn't prove that light's traveling because something's got to be moving, and the mirror in a fiber optic gyro, the mirrors are moving.
Why are the mirrors moving? What do you mean with that?
Well, listen, if they just stood still like the what you call it, like the first Michelson-Morley experiment, then there's no interference. It shows no movement, and that's where all the time dilation started to begin with, because they said we know we're moving, so we know something's going on. If we go to the root cause or the root of the explanation, it came from no mirror movement and no light movement. Basically, there was no interference whatsoever, just from it sitting on the ground. So, the fiber optic gyro, the mirrors are moving. So that's what's causing the interference. The light can still be happening instantaneously, but since the mirrors are moving, it's causing the interference, right?
No, how would the?
I mean,
how would the
just as a
mirror-
possibility. That's all. It's a possibility.
No, because there's no mechanism in the fiber optic gyro to just move the mirror. That's
I'll
another thing.
I'll be good. I promise I'll be good.
Good.
Do you
No
think that
reason
this-
to.
Do you think this is true, Brian? That you just are being contrarian? You and Percent are just being contrarian?
I'm just trying to think. I'm just trying to think and throw out possibilities. You don't got to get so upset with me, Brenda, and call me retarded.
I'm not upset. I'm asking, do you think that you're just being contrarian?
I've just brought up a fair point. You want to talk about the point or me?
What's the point?
The point is, okay, with no movement, okay, he brought up the fiber optic gyro in the oscillations, and I told him that if the mirrors are stationary, there is no oscillation. There's no interference. Okay, the Michelson-Morley, the first one, proved that. Now, so I say that light could still be instantaneous. I'm not saying it is, but it still could be. The fact that the mirrors are oscillating is what's causing the interference. That's my point.
What are you talking
Possible.
about, Brian?
It's possible. It doesn't necessarily have to be true.
You lost me,
There's a difference in the structure between Michelson-Morley and the fiber optic gyro.
No shit. That's my point.
Yeah. So then you don't have to have moving mirrors in your fiber optic gyro to get a phase difference.
Brian,
Because,
the reason the fiber optic gyroscope works is because it takes longer for light to travel down one path than it does the other path if it's rotating. That's how it works.
Right. Exactly. The mirrors are rotating.
No, the mirrors are not. The mirror is not rotating. The whole assembly is. The whole thing is.
The whole thing. How do you hold it, Brenda?
The mirrors
whole
are
thing is
stationary.
rotating.
Mirrors are stationary. It's not spinning, Brian. It's.
And you just said the whole thing's rotating. Would you please elaborate on that?
Because if the fiber optic gyroscope is attached to something that is rotating, like the Earth, right, then it takes longer for the light to take one path than the other path. But the assembly itself is stationary. It doesn't have any moving parts at all.
You're wrong. Okay, the Michelson-Morley experiment had no moving parts, and they detected no movement, Brenda.
It's not the Michelson-Morley experiment. It's completely different.
I'm telling you what happened. What's the consequence of stationary, of nothing moving, no interference? That's the consequence.
Oh, they took into consideration the rotation of the Earth, so they tried to measure the ether wind in relation to the rotation of the Earth, and they couldn't find it.
She said nothing's moving. Okay, so if nothing's moving, like in the Michelson-Morley, nothing. There was no interference detected. So if you say nothing at all is moving, then why didn't we detect it in the Michelson-Morley?
What she said.
Yeah, well, she's made a few claims. I'm just spitballing. I'm just trying to think and consider possibilities.
You're
She doesn't
spitballing
really
it,
like that.
but you're spitballing it with not knowing how a optical gyroscope is constructed and how it operates.
Okay, well, you've made contradictory claims. So, is
No, I
something
have
moving
not.
in them? Hold on. Is something moving in the device, or is nothing moving?
In an optical gyroscope, none of the apparatus is moving, just the light.
So something's moving, right?
The light is nothing is moving. I just told you nothing is moving.
Okay, and you're sure that the
mirrors
mirror
are fixed. The mirrors don't move.
Okay, and the light's moving, right?
And it
Yeah,
takes
because it's
longer.
level.
Yeah, it takes longer to go one path than it does the other path.
Okay, and you're sure that the mirrors aren't moving, like in the
mirrors are
example.
fixed.
When they, hold on, let me finish. When they show the table spinning, they show the table spinning. They
That's
show the
for
light.
Michelson Morley. That's not what
No,
we're
it's not.
talking about.
No, it's not, Brenda. Michelson Morley is with the
Think
table
about it.
stationary.
Brian, if the mirrors were moving, the laser wouldn't go back to where it began. It
I
wouldn't hit the
understand that, but
detector.
hold on. Okay, but still, listen to me, man. She's making this into an argument. The Michelson Morley had no moving parts. Okay, do we all agree on that?
Yeah, there was no moving
Okay.
parts within the thing.
Now, and the Michelson Gale did have moving parts. That was the difference, right? Do we agree on that so far?
Could well be. I haven't looked in Michelson Gale.
What about Brenda? Okay, so the Michelson Morley had stationary parts. Okay, the setup was stationary, and in the Michelson Gale, the setup was not stationary. Do you agree with that?
They changed its orientation, right? They shifted it 90 degrees, right?
I'm just asking if you agree with that, so I know where to look into.
Right. So they changed the arms of the interferometer 90 degrees, right? Since you're bringing this up, you obviously know what you're talking about, right?
I've studied it pretty extensively. I'm just seeing what you know.
Then you would know. Then you would know that they simply changed the orientation of the interferometer's arms, right?
Okay, so you're saying by changing the orientation, we get movement, but so if we face it in one direction, we don't get movement. So, like if we're trying to detect our movement around the sun, but if we turn that same light sideways, we do get motion. That's what you're saying. But my question was this, Brenda.
Is that what they found, though, Brian? Did they find movement and no movement? Is that what they found?
Please settle down. Please settle down. My question is this: do you agree that the Michelson? Well, we've all agreed Michelson Morley had no moving parts. Okay. Do you agree that the Michelson Gale did have moving parts, whatever it may be? Light,
As I understand it, the only movement was to change its orientation 90 degrees. That's my understanding.
So no movement in the Michelson Gale. Just making this clear.
I don't know for sure. I don't know for a certainty.
Okay.
But what does that have to do with an optical gyroscope?
I've just always liked thinking out the consequences. So, according to you, if we turn the gyro a certain direction, we do get movement, but if we turn it another direction, we don't.
No,
that's the consequence.
That's not it.
You're saying.
And you don't
There it is.
move it. You don't move it. You just let it sit there.
Well, you said by moving it into another orientation, they detected movement.
No, you leave it sitting there and you let it make its measurements, right? And then you get how much movement is, how much the Earth is rotating, and that's what they found.
Okay, so what's the difference?
When Bob Nodell and Nathan Thompson were in that video talking, they had the optical gyroscope just sitting there on the table, and as they were sitting there talking, and it was on the table, it was registering movement. That movement was the rotation of the Earth.
All right, how can you can't prove that though? But my question is this:
what it was.
They got rotation, yeah, but
the gyroscope itself proved.
Hold on, man. Y'all don't start ganging up, man. Let me ask her a question. Okay. So explain your difference between the Sagnac and the Michelson Morley, because at this point, all I've heard you say is they changed the orientation and then let it sit still and run.
Because they're completely different experiments. One is looking for the the ether, which was proposed to be the medium for light, and the other is a gyroscope using the Sagnac effect. It's totally different.
I mean, in the setup, I'm just trying to.
I just read about the Pauly, the Michelson-Gale Pearson experiment, and there's no moving parts. It's just a huge triangle, and it detected the Earth's rotation.
Okay. Why didn't it detect Earth's rotation facing straight forward, please? If there's no movement, no movement.
It. It's stationary in relation to the Earth. No one is turning it. It's the perimeter of this fucking thing is 1.9 kilometers, so no one is flipping it.
I'm sorry to break it to you guys, but the Earth is not spinning.
It is actually.
How did you prove that, Percent?
It is actually, and Bob Nodell proved it.
It's a negative statement.
Thanks,
We
Bob.
feel it's stationary. Bob Nodell didn't prove jack
Yes,
shit.
he did. Actually did.
No, that's
He
affirming
proved
the
that 15
consequent
degrees per
fallacy.
strip.
And you
No,
guys
it's
need
not.
to try
Moron.
harder.
It's called hypothesis and proof.
Among Us.
No,
Right.
it's
So what
affirming
Bob
the consequent. You're
did,
saying
since
because
Bob's
if
not
Earth
here,
was
I
spinning,
guess.
hold up,
Let me
you're saying
stand up
if-
for Bob real quick, percentage, since
Alright,
Bob
go
ain't here to defend himself, man. So what Bob did is he made a hypothesis that he'd get a different result on the same latitude if he went up in elevation. So,
No, his
that was his way of seeing. Excuse
his
me.
hypothesis was.
Let me
Sure,
finish,
done.
please, and then
Get
you can
done.
rebuke me. Okay, now so that was his hypothesis. So what he did is he took a test from the same latitude, and he went up a couple miles and checked his instrument again, and he got over 1 degree faster rotation up in elevation. So he proved that it wasn't the Earth turn.
That's not.
It's incorrect because he gave all the data, and people analyzed the data and found out it was within the error of the instrument.
Oh,
And
we've
his-
seen it. We've seen the data, and we've seen that he was telling the truth.
No, he was actually, well, maybe on his one reading he was, but in the meantime, it was within the error of the instrument, and his weighted average was 14.98 degrees per.
Yep.
By the way, his original hypothesis was that the Earth is stationary and still, and he got one of these gyroscopes to prove it. And guess what? He turned it on and got the 15 degrees per hour drift. Thanks, Bob.
That's an old experiment, man. That's an old
I
experiment.
don't give a shit what's an old experiment.
It's been named. It's been named the Stanyek effect.
I don't give a shit if it's an old experiment. He
Calm
proved
down,
the
dude.
Earth's rotation.
Calm down, please.
He proved the
Calm
Earth's
down.
rotation. He proved the
Okay.
Earth was rotating. Thank you.
Affirming
Thanks,
the
Bob.
consequent fallacy.
And it's not affirming the consequent.
Yes,
It's a
it is,
hypothesis. His hypothesis was the Earth is not moving. He said that
Well,
this
listen.
gyroscope would get no motion. He put it on his desk and got 15 degrees per hour,
Well, then,
which is
No, he
what
did
is
not.
listed on
He
the
did
globe.
not say
Thank you
that.
very much.
That was his hypothesis.
That's a
It was
lie.
wrong.
Bob
That
did
was
not
his
say there'd be no
hypothesis.
rotation.
He said it. He said it
Because
on the
it could
film.
register a difference. It could register a reading even without motion.
No,
Because
if it's
the
not
thing is
moving,
not a
if it's
perfect
not
device.
moving, if it's not moving,
It doesn't matter if it's not. It's
if
not
it's
a
not.
perfect
Hold on a second.
device. It's not
Hold on,
calibrated
one
to
second. Yes, it is.
perfection. You're gonna have
One
a,
thing. It's
even
not
in
gonna
the
get-
instruction
y'all
manual,
are-
bro.
yeah,
Oh, you're saying that it just happens to have a 15 degrees per hour eastward drift
It wasn't
as an
15
error.
degrees per hour. If it
It
was
was
the
too.
rotation of the Earth, it would be a constant 15 degrees per hour. It wouldn't average. You wouldn't have to take an average. It would be constant. It would be 7.5
what?
degrees in 30 minutes. It'd be 2.5 degrees
Yeah,
every
that's
10
what
minutes.
happened.
That's
That's
not
what
what we
happened.
observed.
That's
we
exactly what
observed it changing with altitude,
No, you
changing
did.
with temperature.
No.
The thing is
You-
not what you
because-
think it is.
because
it's affirming
the
the consequent.
instrument-
Just because you think.
No, it's not affirming
Hold
the
on, I'm almost
consequent.
done,
He
I'm
did
almost
it
done.
himself.
Just
Hey,
because you
let him
think
talk,
if
Dave,
the Earth
fuck.
is moving, it would register a reading. I agree with you, but you can't just say because there's a reading, or therefore Earth is moving. That's
Yes,
affirming the
no.
consequent.
No, that's
Get
not.
wrecked.
No,
That's
it's not.
exactly. He said that his original hypothesis was the Earth is stationary and still.
No,
I
it's
have
not.
a 20.
Bob's well aware of the Stanyek effect. Quit lying.
What's the Sagnac effect? Only works if it's moving, moron.
The Earth
Okay.
is stationary and still. That doesn't mean it will have always have a zero reading on this device.
Well, it won't
'cause
be
the
15
device
degrees
is not
per hour.
calibrated perfectly. There is a margin of error. It says
It's
this
not
in the
that margin
instruction
of error.
manual, man.
That margin of error is what? Is it 15 degrees per hour eastward?
The margin of error is what it is, bro.
It's not the 15 degrees per
You
hour.
haven't bridged the gap in saying that this reading that fluctuates and
Yeah, we
sometimes
have.
12
Did
degrees,
it-
sometimes 21
Yeah.
degrees. That it
It
is the
didn't
rotation
read
of the Earth.
zero, did it? It didn't read zero, did it?
No, it did not read zero, and we never expected it to read zero.
It didn't. Did
Yes,
it?
it
Was
did.
it within? Was it within its error margin to be 15? Was 15 degrees per hour eastward within its error margin?
Who knows?
No. The answer is
we
no.
do.
Because we can pull up the specifications for this. Trust me, it is not 15 degrees per hour eastward.
It doesn't matter. You're assuming that this reading is rotation of the Earth. You
It
haven't
is.
shown
What
it.
else is it?
You haven't
What
used that. It's
else is
non-sequitur.
it, sir? What else is it? Tell me what
Just
else it
because
is.
we don't know what it is doesn't mean it's
Oh,
automatically
you know what it is,
rotation.
though. You don't understand. It's the Earth's rotation. It's 15 degrees
Then
per
why
hour.
is it changing from 12 degrees to 21 degrees?
It does. Well, because the instrument isn't perfect.
Is the Earth speeding up and
misused it.
slowing down?
Because he misused the instrument.
They were moving at those numbers, and you can manipulate it by
Those
moving.
were outliers. We have the data. He downloaded the data for us, thinking we couldn't do it, but people analyzed it within hours and found out that he's averaging what 14.95 degrees per hour weighted
he told
average.
you how to do it.
No, you
Don't-
didn't.
Don't
No,
like,
you
poison the well like that and slander
He
someone.
downloaded the data because Jeremy basically badgered him into it, and within hours we analyzed.
He literally told us what
analyzed the
program,
data.
what proprietary program
No, he
to
didn't.
download. So we
How
could
to
read the
download
data.
the data. He didn't know
So-
what to do with the data once he had it, though.
What?
It's probably
You
just
just keep on
common
talking
delimited.
shit, man.
It's
So
Don't
what
talk
you're
shit
saying
about people that aren't here.
So hold on a second. Let me see if I can get your so the 15 degrees per hour eastward drift that Bob noticed in it is just error in the instrument. Is that what you're saying?
There is no 15 degrees per hour.
Yes,
there was
there
a fluctuating 12 to 21 or whatever
Which
the
weighted
range
average was 14.95.
You don't take average for the rotation
Yes,
of the Earth.
you do.
The Earth isn't slowing down,
That is
speeding
how-
up, having
no,
an average.
But that's how you
You
do.
got it
You-
twisted,
if
man.
you've never-
Your data is
if
showing
you-
something else. You don't know what
if
it is.
you've
You're affirming
ever-
consequent.
No, if you've ever done science in your life, you know that you
I
take
have.
multiple then you take multiple readings and average them. You throw out the ones that are more than two.
Not for the
standard
rotation
Ds
of
away
the
from
Earth,
mean.
which is supposed to be constant.
Yes, whenever you measured the temperature, you measured 3 times an average. You take all his you weighted the average and it's coming out to 14.95 or something like that. For
No,
fuck's
that does
sake.
not match your hypothesis of a rotating Earth
it
of a
does.
constant speed.
Yes,
what are you
it
talking
does.
about?
Percent
Yes,
are,
it does.
Percent, are scientific instruments perfect?
No, they're not.
Right.
Correct.
So you have to take an average, don't you?
What do you mean you have to take an average? You don't take an average
Yes,
from
you
a
do.
rotating
you take
Earth.
You
You
take
do.
multiple readings. You take multiple readings and average them because your instrument isn't perfect. It has
This instrument
tolerances.
isn't taking multiple readings over set times,
It absolutely
sporadic
does.
times.
It
It's
generates- it
constantly
generates a
giving
lot
you
table.
the motion.
Hold on. What Bob's experiment proved, because he did it at 3 different spots, is the higher he went, the faster the motion. You can try to
no,
explain
that's
away
false.
the
That's false,
data.
too.
He proved
That's
that
false,
beyond the
too.
shadow of a doubt.
No, he didn't. That's
Hold
false,
on,
too,
hold
by
on,
the
hold on,
way.
hold on, hold on, hold on. When he got the higher numbers, he was moving it and the lower numbers. That's when he was moving the apparatus. That's why he got the fucked up number.
No, he wasn't. No, he
Yes,
wasn't.
yeah,
He
he
had-
was.
Not true either.
No,
It's
he
all
said he moved
recorded.
it one time.
We've got the
We've seen the
data.
data
You guys-
for the whole entire
And
experiment.
you've seen the data, so have we. And guess what?
Yeah, go
So
back.
that when-
The higher he went, listen, you could say, you could try and explain it away, but the higher he went, the faster rotation
wrong.
it showed. Yes.
Wrong.
Yes.
There's some
It was
outliers.
over 15
You're looking
degrees.
at outliers.
bro.
You're looking at outliers more.
No.
You're looking
Like
at
I said, you
outliers.
can explain it away all you want.
You're
What
looking
it
at
showed,
outliers.
what the
They're more
device
than
showed,
You know what
outliers,
outliers
was
are?
a faster elevation the higher
No,
he
it did
went.
not. The average at altitude was the same as the average lower.
You
That's
can
not
repeat
true.
this
That is not
experiment.
true.
It's not
I-
just Bob
but-
who did it. Okay, the higher you
I don't
go,
have to have-
faster
you would still
rotation
deny
the
the
speed
result.
you
I don't
get.
have a 20. See, this is the funny because Bob is supposedly a flat earther, and he got the data that shows that his whole hypothesis is incorrect, and then he has to come up with some
Y'all
sort
are
of
trying to
bullshit.
explain it away, but it's obvious. He posted the results. The higher he went, the
Yeah,
faster the
and guess
rotational
what?
speed.
No,
you
he
can try and
didn't.
give a different
No.
cause to it, but the
No,
results are there.
It's not that way. You're looking at outliers, sir. There were a couple outliers when he was at
They're
altitude.
all outliers then.
No, they're not. You can't tell they're all outliers when it averages to 14.95 degrees per
No, tell me
hour.
why it averaged almost 16 and a half degrees at its highest point, please.
It didn't.
Tell me
You
the
don't take
outlier.
an average from something that's
Yes,
constantly monitoring.
You do.
No,
Yes,
you don't.
Yes, you do. If you've
No,
ever
you don't,
done,
bro.
If you've ever done science, you know that you take multiple readings and average them together.
You're saying the Earth is constantly that speed. There's no reason why at
Your instrument-
like
no,
at
the
one
Earth-
point
hold on,
it's going
one
to be a
second,
different
stop.
speed, and this and another
That's
point
correct.
it's going to be a different speed.
That's
the,
correct, because
the
your
device itself isn't
instrument-
changing.
The instrument,
Well,
the instrument is
there's-
giving
well,
you errors. The instrument is not
well,
perfect. The instrument, when you got 18% and we got 12%, the instrument was the problem, not the rotating.
So
of
the
the Earth.
instrument is constantly changing on its own.
When you
No,
move
they're
it,
just-
when you hit
there's
it,
technique. technique errors.
And you've already admitted that instruments are not perfect.
Of course they're not, but that doesn't mean that they're fluctuating like on their own, they have a mind of their own, like Spawn's cape. That's not how it works.
It's constantly showing an average, a weighted average of 14.95 or something like that.
Wait, so is it the
Fuck's sake,
sky?
what
Isn't
more do you
everything in the
need?
sky rotating at that speed? Don't we see everything
No, the Earth
around
itself
us?
is rotating. The Earth itself is rotating. That's why everything was rotating around the gyroscope would show zero movement, and it didn't.
Okay, then how come
the gyroscope is changing on its own?
How come that same device doesn't show us moving around the sun, and how come it shows us? How come it shows it rotating faster the higher we get? Once again, you still haven't given me an explanation.
It doesn't show
you
you
still
fast
haven't
higher you
given me an
get.
explanation of why we got almost 16.5 degrees at its highest altitude.
Because there was 1 or 2 readings that were errors to the high side at altitude. If you
just reasons, people.
No, that's how you take how you take numbers. They were moving. Yeah, you were moving
Listen,
it.
if the gyroscope is changing on its own, where like
if you move
to have results that are 100% different than they were.
They're not 100% different than they are. You moron.
You went from like 12% to like almost 100%.
No, the average is 14.
Like
it went from 12 to 18. Those are the
at some point it was in the 20s.
Those are the
I think
two
it was
outliers.
23 with some of them. But
if you're moving the gyro, it's going to read that.
Let me finish my point. If it's that unreliable,
no, it's
why
not
are you
unreliable.
hinging your entire belief that
it's not.
The
it's just
Earth
one
is
of the
rotating
proofs.
on it?
Hey, quit interrupting, man. Let's have a conversation.
Like an 89% difference in the reading of this data, and you're saying that it's good evidence. Come on, man.
It's good evidence.
What?
An 89% margin of error is good evidence?
It's not.
It's not 89%.
No. 14.98 is like 200ths of a degree off.
Oh, you don't take the average.
I got to go,
guys.
guys.
15 degrees
I'm getting my
rotation
final
all
warning.
the time on the Earth.
If they correct me, I'll be off for another 8 days. So I got to go. You guys deal with the percentage because he's just frustrating the hell out of me.
Yeah. Well,
anyway, the people who made the devices never even determined that it was the Earth spinning for sure. It could be, okay, but the fact that y'all are saying for sure it's this is because you're stuck in a model. Like I said, the people who invented the experiments never claimed that they proved the Earth was in motion. They did prove that we get it. They did prove we measure rotation, but they didn't prove what's rotating. It's the age-old debate.
Well, what's the framework that would allow us to quote unquote prove that the Earth is moving? First, you need to be moving relative to some sort of background substance. And that substance was accepted as the ether up until they saw ether drift speeds, but they didn't see ether drift speeds that were consistent with heliocentrism.
There's no ether.
So,
there's no ether, Lemon. You're not allowed to bring. You're not allowed to bring ether up into this because it has nothing to do with what we're talking about.
Brenda, the point is you don't have a framework by which to prove that the Earth is moving unless you have a substance to move through. So now, because you committed yourself to getting rid of the ether, you now no longer have a framework to prove that the Earth is moving at all.
That's false. That's false.
That's false.
So how do you prove that the Earth is moving without a substance to move through?
With an optical gyroscope, Lemon.
Yeah, why do you need a substance?
He just makes shit up. He just makes shit up.
Brenda was about to answer. With a gyroscope? How do you interpret what the gyroscope is doing unless ether is flowing through it?
No, Lemon.
What?
No, Lemon. The things are sealed.
Lemon, you dropped in here not knowing what it's about, and you immediately set in talking about stuff that you don't know what we're talking about. So take some time and figure out what the discussion is about first.
Pretty sure Lemon's aware that we're talking about the rotation of the Earth.
I don't know. He seems to think we're talking about the ether.
We're talking about what framework allows you to prove that the Earth is moving. And the ether is secondary to that because at the very least, the ether offers a substance to move through that offers the ability to prove that the Earth is moving.
You don't need a substance.
You don't need a substance. Yeah. Sorry, Mole Man.
For the record,
so if the Earth is moving through nothing, how do you know that it's moving at all?
By way of the Sagnac effect, which is used in a fiber optic gyroscope.
No, it's not.
That's what the thing is made for.
No, it's not.
No, it's not. What?
No, Paid was right on that. I would stand corrected. The fiber optic gyro has no moving parts, and the Sagnac effect is based on the moving mirrors. But I got my information crisscrossed, but my point is still valid. Yeah, he was right. I looked it up.
No, post the evidence that it's moving mirrors in the.
Just look up it. Does a fiber optic gyro have moving parts? I mean, I don't, you know, sometimes we were wrong. I was wrong. It doesn't. It doesn't have moving parts. The Sagnac effect is based on the rotating mirrors. It's a different kind of gyro.
Oh, that's not true.
The intuitive understanding of what, if anything, was happening in these interferometers in the first place was that light was being slowed down by some treacly, fudgy substance of space, making the light come back out of phase when the light was split and recombined in the interferometer. That includes the Sagnac or any sort of interferometer that splits light and sees it come back, you know, recombined at the end of the paths or whatever. So the intuitive understanding was that the light was being slowed down by the substance of space being a thick treacle like ether fudge or something like that.
No, that is not how they work, Lemon. You have totally
Lemon, why do we need a substance to determine the angular velocity of an object?
We need a substance for us to move through so we can have a wind, just like moving
because
through the
velocity,
river. If you're moving down the course of the river versus with it, you get a different speed.
There is no
in the equation for velocity, there's mass. So you got to have a substance that have mass.
Lemon, I'm not talking about its movement relative to an ether. I'm talking about the angular velocity of the object.
There's you got to have a substance because you got to have mass.
The angular velocity of the object will be determined by whether you're going cross to the river of the ether or with the ether's flow or against it.
No, but
based off of the resistance of the medium.
All I'm doing all I'm doing is determining the angular velocity of the object that I'm on. Why do I need to invoke a medium?
Because if you move against the ether or the substance that you're moving through, be it the river, the wind, or the ether, it offers a difference going cross to the wind versus going with or against the wind. That makes determining movement extremely easy and intuitive.
Yeah, but we're not doing that. We're not doing that. I just want to know why I need an ether to know the angular velocity of the object that I'm on.
It doesn't matter. In your model, the atmosphere moves with the Earth. So why would we detect rotation if everything's moving together, Brenda?
The logic is we need to determine if space is a substance that is moving and or if the Earth is moving. The angular velocity that you're noting, Brenda, could be the velocity of the ether turning and or the Earth rotating. You know, it could be both and or neither. But the framework appears to be either the ether is spinning, giving an angular velocity, and or the Earth is spinning, giving an angular velocity.
No, that's a false dichotomy, Lemon.
I'm not looking.
That is a true dichotomy. There's nothing else that's worth investigating.
The ether's not spinning. It's possible that there's a stationary ether. What do you mean there's nothing else worth investigating?
Okay, well then that leaves the Earth being the thing that's moving. Like I said, the dichotomy is either the Earth is spinning and or the ether is spinning. That appears to be the truest dichotomy we have.
It's neither are spinning, and that light, when it propagates, is just this activation of this energy, like this propagation of this wave.
Hold on, though, percentage. In the Michelson-Morley, they fucking threw in there that they were trying to measure stationary ether. And the whole point is if it is space or in energy, whatever you want to call it, ether, energy field, stars rotating, then it would be in motion. So the fact that they measured it against a stationary ether was fallacious to begin with. It was a cop out and an explanation.
We're not measuring the ether. We're measuring the angular velocity of the object that we are on. And so I have no need to invoke an ether.
Yeah, then why did they
never once measured the angular velocity of Earth? You've never once measured that.
I'm asking why I need to invoke an ether in order to measure.
That's what I'm asking. In the Michelson-Morley, they got a null result. In the Michelson-Morley, they got a null result. They invoked an ether and said that the stationary ether didn't exist. Why did they have to invoke an ether?
Brenda, as we already said, if you're talking about the angular velocity of the Earth, you need to determine if it's the angular velocity of the spinning ether and or the angular velocity of the spinning Earth.
They were looking for Michelson-Morley were looking for ether. They didn't find it. It doesn't exist, Lemon.
And the
time
quickest
we
they were looking for was
They
the
weren't
30
looking for
kilometer
ether.
per second ether wind drift that they expected based off of the Earth moving through it. They
That's
were
correct.
lucky
It's
if they
not
got
error.
7 to 8. So either the
That
Earth
was
is
their
moving
error,
much
their
more
instrument.
slowly, and or the Earth is motionless and at rest, and the ether is gently swirling over it like a
No.
gentle wind.
No,
No,
Lemon,
that
that was
second
the
option,
error.
they debunked it.
That was their error in their instrument, Lemon.
They looked for
Anytime
the
people
moving
have repeated this experiment better and better now, they're now down to like 7 millimeters per second, and there's no
Yeah, but you still don't get motion if you try and measure our movement around the sun.
Sure we do.
Okay,
Sure we do.
you get
You do get motion.
you get
We do get motion.
you get a null
I'm still not
result.
getting.
No, you get motion.
So I'm getting over talked a lot and shouted down, but I've still not heard a response to my question, which is why do I need to invoke an ether in order to measure the angular velocity of the object that I'm standing?
You don't. You don't.
Because for the third time, Brenda, process this answer, please. We need to determine if it is the angular velocity of the spinning ether or the spinning Earth in reference to the angular velocity of what the hell is spinning.
It's the Earth.
Lemon,
That's the way-
I'm not measuring the ether. I'm measuring the angular velocity of the Earth.
You never did that.
So the question, because of relativity, Brenda, is it could be the spinning of the ether and or the spinning of the Earth and give you the same angular velocity,
exactly what he
the
did, son.
same one, because of relativity.
Y'all are, Lemon, you and Percentage are talking right over the top of each other. I'm not sure.
Yeah, not getting a single thing they're saying. They're all over talking. They're triggered as fuck.
But the thing is, Brenda, because of relativity, it could be the spinning of space over the Earth and or the Earth itself.
No,
You're the only
No,
one triggered, Brenda.
it
You're the only one
There's
triggered.
no way. There's no way that Aether will affect a gyroscope sitting on a desk. Sorry, Lemon. That's sealed.
The ether would
There's no
float
way
through
that
and around
Earth
the
turns will
gyroscope.
cause
No, it wouldn't.
cause a gyroscope
Sorry.
to rotate
There is
faster
no
at
Aether.
higher elevation.
You use Aether. Use your Lemoniferous Aether to explain anything that you can't explain otherwise. You just invoke
No,
it. Wave
just
your
take a
hands.
gyro up
Amen.
a mountain, pal, and you'll get a faster
We've done it.
rotation. That
No,
disproves
no.
Earth.
I gotta
that
agree with
disproves
you
Earth
against
spin.
you,
You're
Lemon.
incorrect. Stop. You're incorrect.
Yeah,
You got-
so we're
I
incorrect
gotta
because of
agree
reasons,
with
according
them
to
No,
Ignatius.
you got
Lemon, your
incorrect
idea
We're
that
incorrect
there's
because of
movement.
reasons.
because your data analysis is faulty.
No, okay. It gives us the rotational speed. It
Your-
averaged
your
out at
data
almost
analysis
16 and a half
is
degrees per hour. Okay,
Because
so
he
you can
had
explain
one
it
or
away.
two readings that were too high because he moved the
No,
gyro.
no, he had an average rotational rate of over 1 degree per hour at
because
elevation.
he had one or two readings that were significantly higher.
So there it is, because of reasons, people. That's his
because he
explanation.
moved
Because of reasons.
the gyro.
You can do this yourself, and you
Because
get
he
it every
moved
time.
the
You can do
gyro.
it yourself. You can move the gyro and get widely different different numbers. No
This
one's
is why the
saying that.
people who made the device didn't claim it proved Earth curve, because Earth spin, because they know it didn't.
Actually, it does.
Wasn't Einstein around? Wasn't Einstein around with all these experiments? And then he never said that we proven Earth rotation. You know, so y'all are smarter than Einstein in your own
Einstein
model.
knew the Earth was rotating. Get off
He
it.
said they can't prove it. Okay,
No, that's
several
not what he
times in
said.
several different manners.
Not what he said.
You have no framework that offers any proof because you have no substance to move through.
I gave you that's false.
You don't need a substance to move through, Lemon.
Einstein made it crystal clear. There's no way to prove. Okay.
No,
he stated it in a few different manners.
Once
But
again,
every
you're
time I go to
misquoting
talk-
him.
Every time I go to the talk page, you start interrupting, man.
Because you're
Why do you do
misquoting
that,
stuff,
bro?
man. Because you're
No,
misquoting
I just
stuff.
said that Einstein clearly stated that we can't prove what's spinning. Okay, whether it is the Earth, maybe it is the Earth. We can't prove it. There's no
Citation.
test, bro.
Wasn't there something about
Citation.
optical or something in that? Yeah.
Yeah, I think it was.
But he's got multiple statements. Okay, if it would have been, well, you know what, we can't prove it optically, but we do have other ways to prove it. No, that ain't what he says. He makes it crystal
Einstein-
clear that we can't prove what it is, and he also said that the difference between the difference between the whether it's the Earth turning or the heavens turning is just a different set of coordinates in a different reference frame in a different model. Basically, not quote unquote, but in them terms.
Brian, how would the sky moving affect a laser interferometer in a enclosed container?
Well, let's see this. If you're measuring against, if you're saying it's the Earth spinning, it's measuring against that same whatever it is rotating. Then
No,
what
it's
do you think? It's
measuring
just
the
going to show
rotation.
stationary? You can't
It's-
just say we're rotating relative to nothing.
Yes, we can actually.
Brenda,
So
the way that
relative
it
to
would
nothing at
affect it
all.
is if space passes through the solid object and still tugs on the space within the object. I think they say something similar with the Machian principle. They had an enclosed hollow ball that would spin, and because of inertial effects, the stuff inside of the ball was spinning even though it was enclosed and closed off from the outside. So there appears to be inertial effects even in enclosed spaces, implying that space has a pull and a tug even when it is, enclosed or something like that. So if space is spinning, then it would pull and tug on the inside of the ball too, or the space.
It's not how it works, Lemon. Sorry, you're invoking material and then saying that your
So
ether.
is the Earth
Why doesn't
rotating
it
in
blow my
reference
hair
to the
back?
atmosphere? Is the Earth rotating in reference to the atmosphere?
The Earth is rotating, and Bob Nodell proved it. I'm sorry for you guys, but he
He
proved
proved
it.
the rotation of the ether.
Yes, he did. His optical gyroscope proved it.
No,
He proved it
yeah,
live
and
on,
then he
on
did a
film.
thorough test. But
Yeah,
all
and he
Bob says
misidentified it.
is the gyro detected a 15-degree-hour rotation. He didn't
Right,
say
which
the
just
Earth's
happened.
rotating, did he? Wait,
Just
let's be honest
happened.
here. Did he
That
say
just
that?
happened. That
Hold on. Hey,
no,
please
listen to
quit
me for a
interrupting
second.
me, bro.
Listen to me
Please
for
quit
10
interrupting
seconds.
me, man.
10 seconds. Stop talking for 10 seconds.
No, dude, you're interrupting me, bro.
I'm not
I'm not going to
interrupting you.
stop when you're interrupting my question.
Oh, for fuck's
It's a
sake.
simple question. Did Bob say that it was the Earth rotating at 15 degrees an hour, Paige? Let's be honest.
Yes, he did.
He said that the gyro showed the Earth rotating at 15 an hour. That's
Yes,
not honest.
he did.
He said
Yes,
that it detected a 15-degree-an-hour rotation. He didn't say it was the Earth turning.
Which just happens to be the rotation of the Earth. Oh man, that's just a coincidence, isn't it? It
The
wasn't
rotation of the ether.
Here's what Bob
No.
said. The gyro picked up motion, and the gyro was on its surface.
That's not
Yeah, that's
how.
the thing.
So
That's the
did he
thing
say it was
about
the
it.
Earth's
This
motion?
gyro.
Did he say
Yes.
that it was the
This-
Earth's motion it
Yes, he did.
detected? No, he didn't.
Well, he should have because he
Yeah,
did.
Yeah, the gyro is a mechanism designed to detect motion, and I don't understand how the sky could have any effect on this apparatus.
Well, we see motion,
The
don't we,
sky
Howard?
has a gentle pull and tug on matter, very gentle.
There's a way to prove
is
this,
not
y'all.
matter.
All we gotta do is to prove whether it's the heavens rotating, the energy, whatever's making the fucking heavens move, the energy that we claim it is. There's a way. You don't even got to call it ether. There's a way to detect it.
Does
Because so
ether
what
have
we
an
do is
effect
we
on?
take the. Shut up, Paige. Fuck.
Well,
dude.
you go on for like 5 fucking
No,
minutes.
I'm making a point, dude. What we do is to figure out which one it is we take it up higher. We did that, and it rotated faster. So it's not the Earth rotating. Drop it.
False,
No,
Brian.
it didn't.
That's false. You're
You are
lying.
misanalyzing the data.
No, you're lying, saying Bob said it was Earth turn. You are lying through those teeth, bro.
He did.
Brian, can you show
somebody
us?
wants?
He did. He did it on film, on the film, on the documentary. He actually
That's
said
a
that the
slight
15 degrees,
misinterpretation. He said they got a 15-degree rotation. That
Which
is
just
all. He
happens
did
to
not
be-
extend the interpretation to say that we detected the
he
movement
knew.
of the
He
Earth.
knew exactly what he did. Don't give me. I've seen the film. He knew exactly what the 15 degrees per hour, which just happens to be 360 degrees per day, which just happens to be one rotation per day, which just happens to be the rotation of the Earth. Oh, what a coincidence!
Rotation of the ether once a day.
Which happens to be the rotation of the shit up above us.
Hold on a second.
No, but-
How does the shit up above us influence the light inside of a gyro?
I don't know. How does going higher cause a
like
faster
the
drift?
pull and tug of the ocean. The ocean of the
The ocean
ether
is matter.
swirling around us like a drain, and it has subtle effects on matter. That's it.
Effect on matter, but
gyro has
hold
to
on,
have a
hold on a
reference
second. Stop.
frame, though.
Let me talk to Lemon. Lemon, you said it affects matter. The light inside the gyroscope is not matter.
The light in the gyroscope is nothing but a wave undulation of the
not
underlying ether
matter.
medium.
It's not
It's
matter.
just a wave undulation of the underlying ether medium when you're talking about light in the first place.
No, that's not what light
Let me
is.
ask you the question real quick, Lemon. Hey, Paige, if I'm on a merry-go-round and I have that gyro in the middle of it, okay, and I spin it at the exact rate as the Earth is turning, what will the gyro show, Paige?
I don't know. I'd have to do the experiment.
No, just think about it. Think
I
about
don't
it.
know. I'd have to do the
there's
experiment.
consequences to your claims, Paige, so I want to talk about it at least. And it's an obvious result. If I spin the merry-go-round, hold on. If I do spin the merry-go-round at the exact speed that the Earth is turning, if you say it's the Earth turning and not heavens, then it should show a 0 reading. Okay,
it would be possible for you to count, but then also the other thing,
point of rotation.
Yeah, the other thing is that he also.
Whoa!
Hold on a second.
That's
Stop.
my whole point, Howard.
Listen for a moment. He also detected lateral movements on the gyro. He detected lateral movement sideways and down, which just happened.
Thought you said that was error.
No, sideways and down.
Oh yeah, so for the Michelson-Morley, it's error, but for your bullshit, it's fucking.
Sideways. He detected sideways and down on this gyroscope. So how do you explain that on your freaking?
No, because they detected the same thing in the Michelson-Morley and said it was error.
It's just the flow of the underlying ether medium.
No, it's not, Lemon. Your ether.
But hold on. So let me get this right, though.
Your ether. I don't know. I can't speak to the Michelson-Morley experiment. I haven't looked at it for a while.
Well, let's just say if it's the gyro.
I don't know.
If it's the gyro that's spinning, okay, and it's on the Earth that's spinning. So the gyro is just sitting there, but since it's on a spinning Earth, it's detecting a 15 degree per hour rotation. So if we take that same gyro and put it on a roundabout, and we spin it at the same motion as the Earth. So we point it up in the sky, and we keep it pointed at that same spot in the sky. So we just spin the gyro right along with the supposed Earth turn. What's the gyro going to read? What must it read?
Its axis of rotation is off. You would have to line it up with Earth's rotation.
That's correct.
Somehow or
it
another.
At the North Pole. That would work at the North Pole. Only
very good.
At the South Pole.
Very good.
That would also be pretty much keeping it stationary, wouldn't it?
Yeah.
Yep.
Yeah. So in reference, so it's all depending on. It's got to have something to reference, right? So if it's on
what do you mean? You just cancel out the turn. You just cancel out the turn.
It's
basically what you're doing is you're proving.
In other words, if the roundabout is spinning relative
the turn. You're proving
the roundabout is spinning relative with the Earth, then it's going to show 0. So the gyro is showing relative motion. So you can't say. Here's my point.
Come on, guys.
The gyroscope reads 0. You just said the gyroscope reads 0.
Hey, let him say his thing, man. Come on.
Yes, man. God, you got to overtalk. Look, so if the gyro's reading 0 because the roundabout's moving with the Earth, then in other words, if there's no reference frame, if it's just stationary because of the reference frame, then that's my whole point, is that there's got to be something moving to show a rotation. So whether it's the heavens moving or the Earth, it's got to be relative to something.
How do you get that conclusion from the roundabout at the North Pole?
If the roundabout, if the gyro is reading 0 because the roundabout is turning, so relative to Earth, the gyro is not moving.
You can't.
Right?
That's correct. Correct.
That would be a confirmation.
I was going to say, you're actually proving that the Earth is turning at this point.
But then if I take it off, right? So no, this is my whole point: is you got to have something to refer it to. It ain't
actually.
If everything is spinning, my point is, if everything is spinning, it's not going to show shit.
The Earth is spinning and the stars are steady, and you're just proved.
Good. That's what I'm saying. So, if the Earth and the merry-go-round are spinning, it ain't gonna show shit, is it?
That's correct. You cancel out the rotation. Very good. Thank you for proving that the Earth is rotating.
Okay, so the point is it's got to be in reference to show a motion. It's got to be in reference to something. So whether it is that something moving or it's the device itself is what's in question. It's got to be in reference to something, bro. That's your own model.
No, sorry, it doesn't actually. You're going a long ways. Your merry-go-round at the North Pole proves Earth's rotation. Thank you very much.
I was kind of saying that for Howard, though, because he was saying what's making it turn. And my point is it's in reference to something.
But it would only work at 2 places on Earth: the North Pole and the South Pole.
So we all agreed now the Earth is spinning. Bob Nodell proved it.
Oh no, Bob proved that it's not the Earth spinning.
Actually, he proved the Earth is spinning. Exactly.
No, he proved that it wasn't spinning. Until you give me a proper explanation of why it spins faster at higher altitudes, then I'll
Actually,
hold
because
that.
it
I'll
was an
hold that
error.
explanation.
That's a
Yeah,
lie,
because
Brian.
because it was an error in the.
That's not a lie. He posted the
Yes.
results.
He posted the
Yes,
results,
So
and you can't analyze.
they're on
You're,
Ranty's.
you're
They're on
expert on.
Brandon's Flat Earth. If anybody
know,
wants to
I
go
have
see
it.
the results,
Brian.
he posted
And
them,
you've
and it showed the higher
misinterpreted
he
the data.
got, the faster it rotated.
Actually, it doesn't show that at all. Thank you.
It's a lie because you've been informed that it's incorrect and you keep
No, because
repeating it.
I've
It's a
seen it
lie.
with my own 2 eyes, Brenda, and I averaged it out, and it was over a degree off at the highest
Yes,
elevation.
because there were a couple very high in error readings. There,
What?
Outliers.
Tell me, please, because he listed all the variables: the
They were
temperature, the
outliers.
pressure, all that shit.
They're out. No, he didn't actually. There were outliers, by the
Oh
way.
yes, he did. It was in the data, bro. So you ain't even seen the data.
I've seen the data.
Yeah, I've got the chart somewhere. I've got.
I didn't analyze it.
Howard, do you agree that the temperature and the pressure is listed?
Which has no effect on the gyroscope.
Well, you just said it wasn't paid.
Well, I don't know. It's been a long time since I saw the data. For fuck's
Okay,
sake.
so just say anything and claim you just don't remember when I prove you wrong.
Well, so the pressure. So what? What's the pressure and the temperature?
Well, if I'm debating your memory, then
Actually,
the
temperature.
this ain't even a debate if it's me against your memory.
Well, I'm sorry. I don't have Bob Nodell's data right in front of me. They analyze the data. It comes out to a
Who's
weighted
they?
average.
Who's they? You can
I'll
analyze it yourself, bro. It's posted. It's clear. Clear as a bell.
Yeah, so what? In the meantime, you don't know data analysis because it doesn't show that it goes faster when it gets higher. There are a couple outliers.
I know how to average numbers paid.
Yeah, but
and
you
I
don't know
that it
about
averaged
outliers, do you?
faster than it was more than a degree off.
You don't know about outliers, do you?
I think we should move on.
I think I need a demonstration that Brian knows how to average numbers. I
don't think he knows
Just add the numbers and divide by however many numbers you freaking added together.
What's the weighted average? What's the weighted average? What's the weighted average?
This ain't a math quiz for Brian just because y'all don't remember the data. Okay, the data showed.
By the way, so
the data showed. Brenda's calling me a liar when anybody can go add up the elevation. Anybody can go add up the rotation, and it averages over a full degree. Over a full degree off.
So 1 second now. Is 16 degrees closer to 15 or is it closer to 0?
Well, the higher you go, it did it 2 places. So the higher he went, the faster it rotated.
He did 2 places. He did 2
If
places.
it's the Earth rotating, that wouldn't happen now, would it?
Well, hold on a second. Is it closer to 15 or is it closer to 0?
There's motion, bro. We see everything moving, don't we?
So
do
correct.
we see everything moving, or do we see ourselves moving?
Welcome to Globe Earth, because the Earth is moving. That's what the gyroscope proved. The gyroscope.
No, you. I've heard you say it yourself. The sun moves across the sky. Okay, so welcome to flat Earth.
From our perspective. In the meantime, though, because it's
a
lot easier.
Whatever. So
we also talk about sunrise and sunset as opposed to the Earth rotates so that the sun moves to this. Yeah, it's a lot easier to say sunrise and sunset because it's what it. In the meantime, though, Bob Nodell and people like him.
Welcome to flat Earth, bro.
Well, it's not though, because you've just proved yourself, and the data from Bob's gyroscope proved that the Earth is rotating. And
what rotational rate would you get?
You're interrupting me now.
If you went up in altitude, on a ball Earth.
So hold on 1 second. 1 second. Is 16 degrees closer to 15 degrees, or is it closer to 0?
It's closer to 15, bro. But it doesn't matter because. Okay, is it?
So
is you going to rotate? Hold on, Paige. Let me respond, bro. Let me respond. Are you going to rotate faster by going higher on your globe, Paige?
No. But so he had an error.
That's what happens when you go higher.
He had a 1 degree error. Okay, I'll take 1 degree. In the meantime, is 16 closer to 15 or closer to 0? So I mean,
I just said it's closer to 15.
Thank you. So welcome to spinning ball Earth.
Moman's trying to get him.
Because otherwise, if the Earth wasn't if the Earth wasn't rotating, hold on 1 second. If the Earth wasn't rotating, you would expect 0. Instead, you get 16.
Something's rotating, Paige. Something's rotating, right?
That's
the Earth is rotating. Thank you.
So, Brian, you said that the gyro picks up the rotation of the sky.
Hold on. According to Paige, it's the Earth or nothing, guys. So it's either the Earth rotating or nothing's rotating. That's what they do. Okay?
No,
that's what they do. That's what they did in the Michelson-Morley experiment.
There are two hypotheses on the table. There are 2 hypotheses on the table. One is the Earth is flat, stationary, and non-moving. The other one is the Earth is a rotating sphere in space. that would rotate at 15 degrees per hour. We have a gyroscopic measurement that is pretty close to 15 degrees per hour.
Hey, we measure 15 degrees an hour.
Pretty
we measure
close.
shit moving above us,
because
bro.
the error. You know,
Wait
pretty
a
close.
second.
Not
Pretty
zero.
close is close enough. It's not. Hold on. Is 16 degrees closer to 15 degrees or closer to 0?
Does it matter?
Listen, if I'm gonna be honest, bro, if I'm gonna be honest,
No, wait a
we
minute, hold
haven't
on.
proven it either way. That's the honest stance.
No,
we
see,
haven't proven
this
it
is your
either way.
problem.
Something,
This is your
something
problem.
is-
You have a
something's
bad
making
data
that
point.
device rotate.
This is a problem that you're therefore.
It's your
okay,
problem,
let's say
sir.
you're saying, well, it's spin, therefore is a ball.
Yeah.
How hard spin actually comes to conclusive with a bring the ball?
What?
What's spinning?
The Earth is spinning.
The ball.
Where do you get the ball from?
It's the globe.
The ball from the globe.
But you're baking one thing with the other.
No, I'm
though.
not baking the thing. Hold on a second.
Yes, you are.
No, I'm. We're
It's spinning,
right now-
therefore
Hold on a
ball.
second. Stop. Right now we're talking about rotation only. We're not talking
Yeah,
about.
but then
shapes.
you're saying
We're not
that
talking about shapes, sir.
Don't
We're
interrupt
talking,
him, But you Paige. just Let him said
we're
that.
talking about rotation.
Hold on,
We're
you
talking
just
about
said that.
rotation.
Stop. You just said that.
Okay, you
you
wanna be-
just said
fine.
no.
You
Stop.
want- you
You
want-
just
you want to
said
be-
no.
you want to be
Stop.
pedantic.
You're
If
gonna
you
let
want
me
to be
no,
ped-
not being
you want to be
pedantic.
Come on now.
pedantic,
I'm actually
if
being
you want to
exact.
be
You're
pedantic-
using
if
words.
you
You're
want to
using
be
words, and I'm
pedantic-
telling you what you just said.
Okay, hold on a
right?
second. Hold on a second. Stop.
No, you hold on. You
No,
just said
stop.
it's spinning,
Stop.
therefore the
Listen to me
ball
for
is
10
spinning.
seconds. 10 seconds. 10 seconds.
You've been speaking for like an hour,
10,
bro.
Give me 10 seconds and I'll talk to you and then I'll shut up for a while. Do I have 10 seconds, please? Thank you.
You won't shut up even after that, bro.
Brian, please give me 10 seconds. With this experiment, what we are talking about here is rotation.
Experiment?
Yes. Bob Nodell had
Okay,
a
well,
gyroscope.
what's your?
God.
But no, you said experiment.
Thank you, Mr. QE. Now we're gonna get into
No,
bunch
not
of
in QE. I actually was fucking scientific method.
Thank-
This, so
thank
let's
you.
go for the scientific method.
Oh fuck. Okay, fine.
What's not
You want to
scientific-
play? You want to play pedantics? We have Mr. Pedantic here. We have an observation with a gyroscope.
Okay,
The
because you have an
measured
observation on the gyroscope.
15 degrees per hour. drift.
Is it 15 degrees per hour?
Uh-huh.
Is that what it measures?
Uh-huh.
Exactly 15 degrees per hour.
Well, 14.98 on the weighted average, I believe. That's pretty close to 15.
Yeah, what did it measure at altitude when he went up the mountain?
It was slightly
Over
higher because
16 degrees.
Slightly higher at altitude because he had an error in there, but it's 15.
really?
So you also admit
Well,
that
he did it
16
twice, just in case he had an error because he moved it, he bumped it, he moved it. He did it again.
Yeah, and the other one was actually better. And so again, you admitted to
They
earlier
were
that
both, they
you
were both
admitted
more than 15, Paige. So the higher
you
we go on your
admitted-
Paul Earth, the
No,
faster
that's
we
more.
rotate.
You have 2 points. That doesn't prove anything. By the way,
Please,
again, you admitted that 16 is closer to 15 than it is 0, right? Because on your
Yeah,
stationary,
so what are you saying? That if it's either her spinning or nothing spinning? That's
Pretty
that's
much,
what
yeah.
you're waiting to.
Yeah, that's what the
so there
gyroscope
you go. It's either her spinning or nothing's
Do
moving.
you have another?
We
You
ain't
have another
watching the
explanation?
heavens move
Do you have
around
another
us.
explanation other than Aether? I mean, you've got Lemon came in
Yeah,
and
the
white
fucking
knighted
stars
you.
are moving. The
Yeah, but
lights,
that
the
would-
fucking heavens are moving.
That would not affect the gyroscope
How do you know?
because
Can I
that's not
ask-
how gyroscopes work.
Trying to get in for like almost
Okay,
an
I'm
hour
gonna
now.
shut-
Go ahead,
I'm gonna
Mo
shut
man.
up for a while.
Go
I'm gonna
ahead,
leave
Mo
for a
man.
while. You guys go ahead and talk. Go.
Yeah, Brian, so you said that it's 16 degrees when you go higher in altitude. Are you saying that days are different length because of the sky rotating at different rates when you get higher?
That's my question to you. Why are we getting a rotational rate that's higher? No, that's my question to you.
Sure. I would say that it's them moving the gyro.
Well, if you
What
want to
would
see
you
the result, no, they didn't. They didn't do a continual experiment and keep the thing going while they drove. They did 3 separate experiments. Okay, but listen, or not experiments,
more
but
than
tests.
that.
Let's say that. But listen, you can go to Brandon's channel, and I ain't gonna dig it out, man. Maybe we all could be use refreshment on the data. But it clearly showed that at higher altitudes it rotates faster. But it's on Brandon's channel.
That's
Look
the
at the data.
lie, Brian, that you keep repeating that lie, and you know it's a lie.
Brenda,
If
quit
you
calling
say
me a
that it- if you
liar.
say that it- But if you're saying that it rotates
If
faster,
I'm lying, then post the results, Brenda. Because I just told you where to find them, Brenda.
You've been corrected, and you keep repeating a falsehood. That's a lie.
I have not been corrected. You have not. You can't say, "Oh, you know what? It says 16, but let me correct you." Correct me, Brenda. Why does it reveal over 16 degrees?
The weighted averages is closer to 15 than it is to 0. So you're wrong.
No, I'm asking you, why did it average over 16 when he went up the mountain, Brenda?
Instruments have errors.
You called me a liar. Okay.
Yes,
now I
you're
want to
a
know
liar
because I know how to read numbers. I know what
Because you've been
1/6 is, Brenda.
You've been informed that you're wrong, but you keep repeating a falsehood that you know to be false. That's a lie.
No, why am I lying, Brendan? You ain't informed me of shit. All you're telling me is that I'm lying. Okay?
That's right. You are. You're a liar, Brian.
You're a fucking lying sack of shit, dude.
Come
you gonna
on,
let her
come
keep
on,
doing it
guys.
this hour?
Come on, guys. Let's don't go there, please.
Dude, she's sitting here telling me that I'm lying when I'm telling everybody that the results are posted for anybody to see. Okay,
Hold on.
and if you want to dispute them, then tell me why the 16 degrees an hour is wrong, Brenda. Don't just call me a liar.
Brenda's
regardless,
gone.
though. Regardless, they both left. But I wanted to know was like, I mean, they're giving it a cause, but all you have is observation of something rotating. I mean, a measurement of something that doesn't. Where do they get the cause from?
You can move the gyro on the surface of the Earth, and it picks up the motion. So,
like I said, you're attributing a cause. I'm sorry, Mo, man. I didn't mean to interrupt you. You're attributing to a cause, but all you're doing okay? It detects something, but you're saying it is the Earth spinning.
That's what the instrument is made for.
Really? So says the king. Therefore, it is.
No, because you can move the gyro, and it picks up the motion. And when you don't move,
but if we put it on a roundabout, it'll show 0 if you spin it at the same rate. So it's got to be in reference to something, because we can show 0 if we spin it at the same speed as Earth. So it's got to be in reference to something.
Sure. So it picks up rotation. I mean,
no, you turn it on and it takes off.
Yeah, but like Brian, I asked you, what is your reason for why it reads differently at an altitude? Is the sky moving at different rates, whether you're higher or lower?
Yeah, the further up you go, the further out you go, the faster you're going to get. Just like we see in reality. Y'all attribute it to latitudes and all that, or getting closer to the North Pole. I attribute it to doing a bigger circle.
No one is doing that. It's 15 fucking degrees per hour. You're now saying that a day is longer the higher you go, because it would be, it actually would be shorter.
Shorter, yeah.
Yeah. You're saying that it's like 23 hours per day at altitude.
Well, picture a vortex, man. Picture a vortex. I don't know, man. I'm just giving you a guess.
Why doesn't vortex? You're now going into La La Land.
I think we started in La La Land, bro. I think the people who invented these devices knew it didn't prove shit. Okay, it shows.
Oh no.
Okay, for us to act like it proves it works.
They get $20,000 for an instrument that doesn't work.
Yeah, it's like people who made thermometers.
They do work.
No, but people who built thermometers didn't build them to prove that water boils at 100 degrees.
These
So therefore,
same gyroscopes don't show us bending around in Earth as we travel. Okay, these same gyroscopes don't show us moving around the sun or moving around the Milky Way. Okay, so you get results with certain motions, and y'all try and use just them motions, but you have no explanation for all the other motions that we don't detect.
It does detect.
It does detect it.
Around the ground,
Yeah.
Yes.
No, it doesn't, because y'all attributed that shit to air. No, you attributed it to air. Michelson Morley, y'all abolished ether and attributed the motion to error.
No.
It's frustrating.
Yeah.
It's very frustrating, man, when y'all hold a solid case. Because if I'm gonna be honest, I'm gonna be like the people who did the experiment. The guy.
Well, I mean, the honesty of it, Brian, is that this instrument is built to detect motion. That's all. That's all it does.
But like I
And you
said, the
said it's
engineers who designed GPS, it's in the engineering document. He said that the Sagnac effect is not due to Earth rotation. Period. In the engineering software for GPS, I'll pull it up. I'll post it.
So does the ringless gyro, does it needs GPS coordinates?
No.
Sure.
Does it need GPS coordinates?
Yeah.
I don't think so.
I'm reading something here that the JSO Glide Bomber Guidance Package Corporate Company also includes GPS receivers to update the ring laser gyros.
Well,
would it need-
they're hooked
why
into
would
the
it- why would
instruments
it-
on the airplanes.
Why would it need?
Yeah,
a-
they're
why
hooked
would
in.
why would the ring laser gyro need GPS coordinates?
It doesn't receive any coordinates. I would think that the ring laser gyro information is hooked into the airplane's GPS system.
Yeah, you got to input it, or you got to import it, put it manually.
Yeah,
So,
input
the
it
latter
manually.
two.
I think that's one of the things that they had to do with ring laser gyro that what's his name had, the Glowbuster guy.
Bob didn't
Bob.
need to. He didn't need any coordinates. You don't input them in the gyro.
It says that you needs to update the ring laser gyro when this guidance package thing. It says Copper's company also includes GPS receivers to update the ring laser gyros.
So hold on. Where did you read that from?
It's Smithsonian.
Yeah, post the link so we can see it.
Sure.
Because airplanes in their IRS systems have.
It's talking about it's talking about a bomb, but that.
Well, it'd just be part of the tracking system, wouldn't it, Elbow? Just to work
Right, so
out.
it says the JSO Glide Bomb guidance package. Copper's company also includes a GPS receiver to update the ring laser gyros, which are arranged to measure yaw, pitch, and roll.
Yaw, pitch, and roll.
Howard's about the most qualified here in this chat to be talking planes.
They're talking about the IRS.
Yeah, we know. Yeah, the plane that I'm flying doesn't have any of that stuff on it.
Yeah, I know, Howard, but you're still the most qualified.
Yeah.
Yeah, it says the inertial guidance systems determine location and orientation, not from sightings of the stars or landmarks, not from signals from the ground, but solely from instruments carried aboard a moving craft. So before there was just, I guess, yeah.
Hey,
Before,
Mo-Man, the only reason I get so adamant and argue against is because y'all try and argue it so firm. The truth is there's no way to prove it either way. I don't think either. I can make an argument for either side, but the fact y'all stand so firm on it because it's, in your model dependent is why I stand so firm against it, because I'm just skeptical. I'm not saying for sure what it is turning. Okay, it could be the flat Earth turning. I mean, I'm just saying. To prove it, without a shadow of a doubt is not. That doesn't even exist in your model. That's 100% proven, right?
Not only that, they attach a cost to it because that's what they believe happens, the Earth spin. But they're really just correlating it measures 15 degrees per hour, therefore that's the Earth spin.
I think that the problem is that there's like other evidence that points in that direction too. It's not just this one thing.
What evidence?
Well, like the pendulum, depending on your latitude, etc.
That doesn't always work.
Forged with the gyro, the Earth is a globe and rotating.
Yeah, when there's an eclipse, it goes the other way or some shit like that.
Can you show a video of this happening?
Yeah, there's one guy that documented that, but then there have been other people have tried to duplicate that, and they were unsuccessful.
I've done it myself. It's not consistent by any manner.
You had a Foucault pendulum?
No, not a Foucault pendulum. I made my own pendulum.
That's the problem.
I need to make a video out of it.
Always the problem.
I need to make a video out of it, man. But I don't have the best control conditions, but still I have good enough conditions with zero wind. It's going to go whatever way it wants it. It doesn't even go for that long. You think it does. Sometimes it starts circling and shit. You don't never know what it's going to do. Man, I'm going to make a video out of this shit, but then I got to do all this bullshit again. I thought everybody knew this.
I mean,
I've done that shit where you put, actually, if you hold a string over your hand, it'll start rotating around your hand.
Yeah, the Foucault pendulum requires like a 100-pound bob and like a 30-foot pendulum. It's not something you can duplicate with a little piece of string and a weight.
So if you set it up just right, you can get it to do what you want most of the time.
That's just like when they tell you if you hold a string with a freaking needle over a woman's hand, if it goes one way, it's a boy. If it goes another way, it's a girl. That's what y'all doing.
Well, it says.
Hey, my wife did that shit, bro. My wife did that shit twice, and it fucking worked. So she either got lucky twice, but she held it over the belly.
Like it says in 1954 that Morris Alas reported that a Foucault pendulum exhibited peculiar movements at the time of solar eclipses.
Right.
And if true, his findings raise new questions about the nature of this. This is actually on the NASA website, actually. But I don't know if they've done any further investigation into it. But it's definitely been reported.
And and what I said about it is hearsay. I've heard it talked about so many times that there have been others that tried to duplicate that and did the observation during eclipses and full moons and other things, and they were unable to reproduce that effect.
Yeah. And I suppose when it comes to even viewing an eclipse, you've got other things on your mind rather than, I suppose, retesting Foucault's pendulum. Yeah, it is interesting, though. Who knows?
To me, it's weird that there's like many examples of Foucault's pendulums working, and then there's this one thing that might have happened, and it's like, yeah, this wrecks the whole thing. It's like, no. It's weird to me. It's like there's people who say that the whoever went to Antarctica, what's the Admiral Byrd?
Admiral Byrd, yeah.
He said that it's a vast expanse of land and there's darkness and whatever and whatnot. And then there's thousands of people who go there as tourists, and people say, oh, they're all just Masons. This one guy is correct. It's like, why? Okay, we just not accept what's happening.
Who says that everyone goes there as Masons? I've never heard that everyone that goes there is Masons.
Someone said, I don't remember the name of who said it, but someone said that all the people who go there are Masons, and you can't buy the cruises because they're full or they don't go or they're cancelled or something, and only Masons go there.
Well, I don't know anyone that's ever said that no one goes to Antarctica. You know, there's obviously thousands of people that have gone. That both work there and so if
Wolfgang said that you can't go south of the 60th parallel, so then no one would have gone there.
Well, I think freely is what he's saying. Like, I can't get my own yacht, old man, right? Without saying exactly where I'm going to go, without putting in the right paperwork. I just can't sail down there on my own. I will get intercepted. Like, there have been cases of that reported. That this stuff happening. Now, why should I have to tell anyone exactly where I'm sailing in the ocean? Right?
That's what would happen if I went and sailed to Australia. They would say that you have to have this visa, this passport, you have to know your first location where you come in. I mean, there's a lot of things that you need to tell them, and you have to follow their orders. I want to go to Australia.
Yeah, but they own it. Nobody owns Antarctica.
There you go. And
no one owns Australia.
We're talking in the open ocean. We haven't even got to Antarctica yet. You're going to be intercepted before you even step foot on Antarctica. So you haven't even gone onto the land.
Who's been stopped there?
Yeah. There's been a couple of reports actually, and I saw one 2 or 3 years ago. That there was a sailor that got intercepted and was turned around. Now I can't tell you his name, but I did see something on
Jarl
exactly
Vanderhoy?
that.
Or Jarl
I'm not
Vanderhoy
sure.
and another guy too, man. A guy from France. And that Jarl Vanderhoy guy, he went twice. He got turned around twice.
Yeah. So
they turned
that has
twofold.
definitely
He
happened.
had permission. He had permission from the Argentinian government, from what I heard.
Oh,
He had permission,
there you
and
go.
he still got turned around
How many?
twice.
Yeah.
You don't need
how
permission.
many? Hold on. How many fishing boats have been turned off for the coast of Australia by the officials? I bet
How many
tens, maybe hundreds.
I've got no idea. But if they're
Chinese fishing boats.
if they're
It's international waters. You get like 9 miles. It's international waters, man. Too.
if I was going to say, if they're fishing in Australian waters without a permit, 100% they'll get turned around. Yeah.
Yeah, and if you go south of the 60th parallel, you might need a permit.
Are you trying to say it's easier or just as easy to go explore Antarctica than it would be to go explore Australia? Because I'll take that bet for any amount of money.
Yeah, we can take, because I mean, if I go to, I think there's few crimes that
wasn't
would
my
stop
question.
me from. Yeah, that's I'm answering your question. There's few crimes I think that would stop me from going to Australia, but I would still be able to go to Antarctica.
That's not my question. I said,
Yeah.
do you think it's this with the same ease? Like,
What do you mean with ease?
Ease of what?
Yeah. Do you mean
think
the
you and I can go? Yeah, if you would shut up and listen. Ready? You ready?
Mm-hmm.
Do you think you and I could go explore freely in Antarctica just as easily as we could go explore Australia?
Easier.
What do you mean? Easily?
NASA still says.
Yeah, because there's no private land and nobody owns Antarctica.
Okay. I'll take that bet for any amount of money.
Sure.
What a load of rubbish.
No, you can.
Can
The difficulty is getting there, of course, but.
Okay, NASA. So you and I go down Antarctica. We land on wherever it is, Captain Scott's or bloody Scott Base or whatever, and we're in our little portable there. We get warmed up. We have a cup of soup. We're ready to go. We can walk out the door of our portable and go anywhere we like in Antarctica. Is that what you're suggesting?
There are certain areas that you cannot go that are considered historical districts.
No, you misheard my question, obviously. All right.
Hold on a second. There are certain places we cannot go that are considered historical places. We cannot interfere with any of the camps that have been set up there by the treaties to the Antarctic Treaty. Other than that, we can go pretty much anywhere we want.
Are you suggesting that we can walk outside our little huts, right, at 6 o'clock in the morning, put our coats on, our mittens, our beanie, and go wherever we want? Apart from those restricted areas, are you saying that we can go wherever we want, unrestricted, unsupervised?
Yep.
I'll take that bet as well, Rukia.
Sure.
100%.
Have you read the Antarctic Treaty?
Hey, look who's answering.
Have you read the Antarctic Treaty?
You gotta consider the source of where the
Have
answer is
you
coming
read the Antarctic Treaty of
I
Rocky?
don't know why Pete Nash still is even talking right now because I was asking the other guy, and now Payne Nassashill is, I don't know why he's answering.
Have you read the Antarctic Treaty of Rakia?
Now, it's got nothing to do with the treaty. We've actually had someone in this channel, NASA, right, who has actually been down there twice, lived down there once, I think it was for 3 months, and another time was down there for a couple of months. You cannot travel anywhere freely that you like whatsoever. The amount of paperwork, the amount of rigmarole that you have to go through to even step foot and go anywhere past your camp is quite incredible in actual fact. So you cannot at all travel freely wherever you like. You are 100% incorrect.
Where's your reference for this?
The fact
Where's
that
my reference?
Yeah, where's your
at all.
information for this?
Hello.
Yeah,
Why would there
Rocky
be an
is talking.
Antarctic treaty restricting people if it's unrestricted, you idiot?
The Antarctic Treaty says the only thing you have to do is, if you're from one of the signers of the Antarctic Treaty, you have to tell your government that you're going to be there. That is so they can tell everybody else that you're going to be there. There's no restrictions other than certain historic areas and the camps that have been set up that you can
Yeah.
go. Now, there are rules
Well,
that you have to
you
abide
need.
by, like you have to pack everything in, you have to pack everything out, including all your poop. But other than that, you can basically go wherever the hell you want.
You've got absolutely no idea what you're talking about,
Yeah,
and the
that's
more you
exactly
keep on
idea.
you just need to close your mouth now because you've got no idea what you're talking
No,
about.
I know exactly
Right?
what I'm talking about. I've read the Antarctic
No,
Treaty.
you don't. You go
Okay.
do a little bit more research and come
You-
back to us,
no,
right?
why
With
don't you
a
point,
more enlightened
why
way.
don't you point me into the right place to do my research then? Because I've
Okay,
read the
I tell
Antarctic
you
Treaty.
what. I tell you what. Go back, right, to Gems and ask them, right?
No,
They'll
no,
give you the
you
answer.
say I'm incorrect, so you should be able to give me the correct answer since
One,
you know.
I told you. Yeah, Mole Man, jump in.
Because Mo Man, I was asking you, not paid NASA Shield, because you were the one like comparing going to explore Australia to Antarctica.
No, I just said that you need permits for both.
Right, I understand. That wasn't my question. Are you hearing me right? Am I not saying the question clearly, or
You don't even
are
need a
you
passport
just
to go to
avoiding
Australia.
it? And
You
why
don't
is paid NASA Shield still talking?
You don't
when I'm
have. You don't even
asking
need.
that
You
guy
don't even.
Hey,
You don't
he's
even
talking
need.
to Mole Man,
He
NASA.
should be
You don't
muted
even
right
need
now.
a.
Go, Rocky.
Okay.
Well, I've already asked my question. If that guy wants to answer it, or if he just wants to avoid again, or maybe let paid NASA Shield come in and white knight for him.
I don't know what that means. Let someone white knight from me. What should I say? Shut up.
So talk about white knight instead of the question. Go ahead.
No, you started it, so I mean, avoid the.
Yeah, talk about me instead of the question. Go ahead.
Sure. So, what is your question? You said.
Oh my
it's
God.
equally easy to go to Australia or Antarctica.
Did
That's
not
it. It's
ask
not a lot of
that.
Okay.
So define easy.
Oh,
Okay. Are you talking about the ability to get there? Or are you talking about what you can do when you can get there, or the paperwork?
Oh my goodness, it's paid
He was
NASA
talking about
Shield
the ease.
talking again.
I ask a simple question of you, Rocky. Are you too?
I don't care about you, paid NASA Shield. I don't need anything from you. You weren't talking to
won't
me.
answer my
I
question.
don't want to talk to you. I'm asking
He
the
doesn't
other
want
guy.
to engage with you, NASA. So
Clearly.
don't engage.
This is ridiculous. This is just the time wasting BS that we have to deal with every day, and I'm just pointing it out. I really don't even want his answer because everyone else knows already in this audience, probably.
Hey, Rocky, what do you reckon the chances of you coming down here to Australia, landing in Melbourne, going to a car rental place, hiring that car, and being able to pretty much go wherever you want to? What do you reckon the chances of that?
100%. All I have to do if I want to come by a boat is just let the local authorities know what port of entry I'm coming from and where I'm headed and what my intentions are. Now, if I want to do that in Antarctica, it's a little bit different, don't you think?
One would think
hold
so.
on. How would it be different? You would tell you what's your port of entry and tell your intentions. How would that be different in Antarctica?
You don't even need a
You
passport
don't
to
think
go
it
to
is?
Antarctica.
And why is paid NASA Shield talking?
Because you'll need a passport to go to
You have to
Antarctica.
get an environmental asset or an environmental report. You have to bag up your own shit. You can't bring dogs. You can't bring gas. You can't bring freaking dude. There's so many stipulations. I don't think you've read the Antarctic Treaty, Paige. So
I
stay
read
out
the
of it.
Antarctic Treaty, and you're talking about the environmental consequences, which we're not talking about right now.
But Brian, you know that you can't even bring food to Australia from abroad. They would all your food is confiscated at the border. You can't bring food to Australia.
Yeah, you got
You can
dodgy
still
food.
bring
That's
food
why.
to Antarctica. So it's easier to bring food to Antarctica. That's for starts.
Okay, that's for starts. I know that I can book a flight, right, to America, my old man. And what's your purpose for the trip? A holiday. Yep. Happy days. So I book my flight, I land in New York, I go to the car rental place, and I can drive all over America without letting anyone know what my intentions are, what I'm going to be doing, where I'm going to be, what my time is, what my curfew might be. I don't have to put in any rescue plans, this, that, or the other, right? I've got absolutely no restriction on my movement whatsoever. But on the other hand,
there are areas you can't go to. You can't go on private.
not-
You can't trespass on private land.
I am not talking about. I'm not talking about going onto government private land and this, that, and the third. You know that, NASA. You know that that's not what I'm talking about. So stop obfuscating and stop red herring my point.
like I
Because
said-
my point is very, very, very clear. Right? As long as I know what these places are, right? Unless I want to get arrested. Right, I wouldn't go to them. Right, I wouldn't drive around and just walk into your place for argument's sake, uninvited. Right, because I'd be uninvited. You wouldn't do these things, but you can travel freely wherever you want, unrestricted, as long as you know where you can go and where you can't go. Not the same in Antarctica. It is far from the same.
It's exactly the same. There's certain areas you can't go. There are the
It's not the
whaling
same.
areas. There's some
You are just
historic
being
areas.
misleading.
No, it's exactly the same.
No, you are being misleading with your information.
Why
I'm shutting you down. You are being misleading with your information, and that's why I'm shutting you down.
Oh, the other guy is now insinuating that it's actually easier to go to Antarctica.
So you muted him for what? Misinformation?
Because he's been misleading with his information. You can't do it.
Oh, that's nice.
Yeah, really, it is nice.
So what is it misleading information if I say that the Earth is a globe?
You can say whatever you want, right? But whether it's globe or flat, right? We still can't go to Antarctica and do whatever we want to do there. Still exactly the same rules apply.
Yeah, you can't do it in Finland either. You can't do whatever you want in here.
Mm.
But are you saying that there is no way for you to go to Antarctica and just go across it? Is it totally impossible?
I cannot go there, right, unrestricted, not letting people know my everything, exactly where I'm going to be at what time, and with plans in place to do whatever I'm going to do. Yes, that is what I am saying. And what I do has to be approved. 100%. That is what I'm saying.
Okay, so I ask my question again. Are you saying that it's impossible for you to travel across Antarctica if you inform them about your intentions?
I know.
Yes, it's impossible. Just getting the environmental report is going to cost you anywhere in the order of $50,000 to a couple $100,000. And they want every single thing you do detailed. Like I said, you even have to bag up your own poop.
Now, I don't think they would charge you.
You are on a leash to go there, and it basically nobody can ever get through that process to even go there, except for people with so much money. I mean, I don't know, man. I think if you read it, you'd understand it.
Brian, post the evidence, or this is misleading information. Post the evidence that you need $200,000 for environmental paper.
I said 200,000, man. You heard me say that. Why are you changing my words?
Well, you said 200.
Anywhere from.
Anywhere from what?
Look it up, man. Look it up. I'm not going to have a debate with somebody who doesn't know anything about the subject.
True that. He just wants to send you on a wild goose chase and waste more time. Go ahead and post the evidence that it doesn't cost you money to go freely explore Antarctica.
No, I never said that you can freely go. He said that there's an environmental paper
You're
that you have.
insinuating that it's easier to go to Antarctica now than Australia. You don't have to. You can bring your own food to Antarctica, which is insinuating that it's easier.
You don't need a passport.
Is it easier to go to somewhere where you can bring food, or where you can't bring food? I mean,
that one thing. What does that have to do with anything?
That
you don't need a passport, Rocky.
Shows that it's easier. Now you don't need a visa.
Don't need a visa or a passport.
That's correct. There's
What
no
does
government
that
there.
Again, what does that have to do with anything?
Saves you $75 in paperwork.
Yeah, you need less.
Hey,
less.
now, still, listen up. You listening? I think you are a deceiving liar. I don't want to engage with you. Stop addressing me. Don't say my name, please.
Fine, I will comment to you and not say
No
your name.
one wants you, Pay Now.
No.
Still, take the hint. Wherever you go, no one wants you, even at
Yeah, I know. I
gyms
know.
and all that.
I know. The truth is
So
hard to
are you
handle.
guys? So there's less restrictions to go to Antarctica than there is to go to almost any other country.
Yep.
Oh, cool.
But I'm just because Brian said that there's some kind of environmental thing that can cost up to $200,000, and I would like to see this information about this paper that is so
That sounds like
expensive.
a fine or something to me, like
Yeah,
for
I would like
dumping
to see it.
oil or something.
Probably.
I mean,
Shitting
it's not a
in the wrong
paper,
spot.
obviously. That was a lie. So
A full report on you on everything you do and the impact on the environment. I'm going to post you the information right
Took
now.
two
But
shits on the North
comment if you don't know
iceberg.
this stuff already. Please quit commenting on it. You can ask questions.
that's
We'll
why I
answer them.
said post it.
If you don't know this
That's why
stuff,
I
then
said,
just ask questions, bro.
yeah, that's why 15 minutes ago I said post the evidence so we can.
He is. He's going to. Brian
Wait,
always
hold
posts.
on. What's your evidence that it doesn't cost?
What do you mean with my evidence that it doesn't cost?
You're saying you don't need it. You said you
No,
told
I'm not
Brian
saying.
you don't think it costs.
I never
It's
said
not like it's not like
Why did you
Cubans in
ask me
Miami, right?
why did
They
you
can't
ask
just float across on a log.
high? Are
Hold
you
on.
drunk and discordant again? Because you asked me, what do I mean? And I started to explain, and you immediately talked through me. Huh? What's the question again?
I wasn't
Same
talking.
old
You
script,
fucking
same
Hey,
old
are you allowed? Are you allowed to address him yet, or is this one of those times where you can
No,
talk
it
to him?
seems, Grim, it seems like you or me now because he's preaching that I caught him, even though you did it.
I did.
Oh,
Yeah, my bad.
please. Same old script from the same old deceivers. Hey, what was the question again?
Oh, I think that's against the rules, insults.
What, calling you a deceiver?
Rules are made to be broken. Let's keep going.
No, that's a shield. He gets rated for misinformation.
Oh my God. Whine some more. He's not muted now. We still get to listen to him.
Dave, we just roll around in circles, rolling around in circles.
I just posted.
Walking
Anybody
around
wants to
on-
see? He pulls up the
I just want
Antarctic
everybody
Treaty.
to
Anybody
know
wants to
if I
see
give
it? I just posted it in live stream.
I don't really.
From Taboo
Well, man, if you want to
Conspiracy.
see the rules, this guy pulls up the Antarctic Treaty and goes over it, okay, step by step of what's required. So look, watch that video before, or either just stay and ask questions.
Half an hour.
We've all seen the Antarctic Treaty.
Wait, is that Taboo Conspiracy?
Yeah, it's
did you
Taboo
say?
Conspiracy.
Yeah, no, that's Taboo Conspiracy.
No,
Who
I'm not
shows
watching
the
it.
Antarctic Treaty, okay, and reads
Just
it.
give us the link to the actual document, though.
It's only like 7 pages long. We've been over it several times.
Well, yeah, no, he posts it and reads it.
Yeah, I trust
How
his
many
reading ability.
pages is the Treaty of Restrictions for Australia, traveling through Australia? Left Lane, that would be a question to you.
Now you may talk to him.
How many times have we been over the pages of documents you have to read to know the restrictions of going to Australia and freely just traveling, going to visit place to place?
And it's never come up before, actually.
It's never come up. So you're
Sir.
saying there's a treaty that restricts you from going to Australia?
No.
Is that what it sounded like?
Not
He
that
said,
I'm
bro?
aware of.
Not a treaty. So you would
Yeah.
say it's more. You would say there's more restriction to go to Antarctica than Australia, then, right?
For me to answer honestly would take me more than just a minute. So
Yeah, I know you won't answer anyway, but the point is the fact that there's a treaty.
yeah, how do you
signed
know
by,
I won't answer?
Yeah, you're
You don't
cutting
ever
me
let
off,
me answer.
asshole.
Yeah.
Hey,
Wah.
bias mod,
Oh,
you're
no,
cutting me
man.
off. The
He's a
fact
rough
that
guy.
there's a treaty at all signed by more than one country should tell you people that don't ever use common sense, it's more restricted.
I mean, you're
we
only talking
actually
about
had
different countries that
Go,
neither
Grim.
one of you live in. We can't be getting this mad at each other. Not
I
over
know
this
it.
shit.
I know
I'm
it.
not.
What are you talking about?
I'm not mad at Paid Nestor or anybody here. I'm mad at the
Except for when you go, you fucking asshole. It just makes us feel like you're mad at him. You know, like
Yeah, well, if he's gonna be an asshole, he's
Yeah.
gonna get called out. If he's gonna be biased,
Yeah, I think
like,
the one being the asshole is obvious.
yeah, I know I'm
Yes,
being
man.
an asshole. I will
We
agree.
actually,
Will
yes,
you agree
everyone
that
knows
you're
I'm
being
the
an
asshole
asshole? I
here.
bet you won't.
let me say
I'm
something.
the one being the asshole.
We actually had Kirsten here a few weeks ago. You know him. Seeing NASA isn't talking, but the mole man will know him. Kirst with a high IQ. He's actually lived in Antarctica for, I think, in total, I'm going to say 6 months. He's been over there twice, and we actually questioned him. What does it take to travel in Antarctica? And you have to fill out a great deal of paperwork to go anywhere. It's not unrestricted. You have to fill in locations at where you are going to be, at what time you're going to be there, safety plans, all this sort of stuff. Then it has to be approved, right? And that was only for a journey that was, say, I think he said it was 350 kilometers from camp, so it wasn't really all that far. But there was a hell of a lot of paperwork that has to be filled out. It has to be approved. It isn't free and unrestricted. You can't go anywhere at the drop of a hat and do whatever you want whenever you want. So it is completely misleading and deceptive to say that you can do it.
But I think the argument really is that if it's possible to go there or not. Not that it, like I've heard this argument said that it's just impossible to go there. That's how this all started. Now we're moving. We're kind of blue shifting our own goalpost here.
One person say that.
Back to now that it's you have to tell them where you're going.
No, I've never heard anybody say it's impossible. It's impossible to go freely. Listen up. Freely explore once you get there.
I've been in these rooms for so long. You know, I heard. You know what I've heard.
You can't go to Antarctica.
You can't just lie and say that. You know, people were saying that you're not allowed to go to Antarctica, and they were spreading, and it was just becoming like wildfire. The meme. Yeah, but then the argument changed, and now that we can't go, freely anywhere we want to without telling somebody. I mean, but you could still. I mean, the whole fact of the matter is now you can go there and find out for yourself whether or not there's this 24-hour sun or not. That's the only part of the argument that matters. The rest of it is just people arguing over knick-knack bullshit, tit for tat nonsense. It's all about the actual argument, and that's if we go there and see this fucking 24-hour sun or not. That's it.
What's it got to do about the sun?
Go there. Now you know you're allowed to go there. You just go there and tell them you're going there.
I gotta agree with Bandsaw though, Grim. It's about more than just the sun. It's about the shape of that shit down there too, bro.
Well, whatever. Whatever. But the main argument was all about if there's actually this 24 hours of sun or darkness in Antarctica.
Yeah.
Darkness.
We're telling you.
I must say. Sorry, Rocky. Go.
Let me go. I'm going on mute after this. This is ridiculous. But we're telling you that we know people that have gone down there. As you tell us, we're lying about. We don't think we're allowed.
I didn't say you lying about shit.
Allowed as you talk through me again.
Yeah, I wasn't saying you're lying about anything. No, you're like overly amped.
As you're talking again,
I'm not your enemy, Rocky. I'm not your
Why
enemy,
are you
dude.
talking again? I wonder
because you're treating me very hostile.
Trying to explain that no one is lying about being able to go to Antarctica. Because we're telling you that we know people that have gone there and we think we can go there, but it's very specified where you can go. There's a lot of people that you have to fill out to go there. As I hear him talking again while I'm talking.
Because you just don't stop, man. Really. And today, you know that. I agree. Today, you know that. But it was.
I clearly go on mute when I'm done talking. Now just follow the script and say I ramble on like a dumbass.
First of all, you're way too fucking hostile for this level of conversation.
So that gives you the right?
Again, I'm not trying to interrupt you or anything. I thought you were going to take a breath. You didn't. My bad.
You thought I was going to take a breath, so you started talking.
You went on for so long that I thought that it was physically impossible for you to say another word. Yeah, you
That
did.
is ridiculous. That is the most ridiculous lie I've ever heard on Discord. He
Well, it
thought
was
I
the
was
end of
going
your
to take
sentence.
crap, so that's why he started
Anyway,
interrupting me several different
It was
times.
the it was the end of your sentence, though. It wasn't like you were in the middle of a word.
guys, stop.
Right.
Enough.
For one thing,
Right,
I'm not
let's get
saying
back
he's
to
lying,
the
Bandy. I know.
No. And
I'm not saying
I
he's
must
lying
say
and shit like
too,
that, you
Grim,
know?
what you said before in regards to hearing that people have said that you can't go to Antarctica, I've actually heard that too myself. I've heard that being
That was a long time ago.
spread,
Yeah.
right?
Yeah.
And that was
Yeah.
a long time ago, right?
That's all I'm saying. And
I've
now
never
we
actually
got new information, and I agree.
Yeah. I personally never have used that in an argument myself. I just didn't know. I didn't really care, to be quite honest with you, Grim. Didn't really bother me
I
too
hear
much. I'm not going down to some cold ass place in the first place. I like the sun and the beaches myself. That's the kind of guy that I am. But
I was always wondering about that, Bandy.
But to even suggest that you can actually go there like you can to Australia and just roam freely around is just ludicrous, Grim. It's absolutely ludicrous to say that you can go down there as a tourist, which you know you can, right? And then as a tourist, I can go to the little dog sled hire shop, hire myself some dogs and a sled and go wherever I want unrestricted. It's absolutely ludicrous to even suggest that you can do that. Right? Absolutely ludicrous.
Yeah, but that part, but to me, that part of the argument doesn't matter at all as far as being able to go to a location to witness a 24-hour sun in the place that's supposed to be the ring of the entire map. Right? We had to physically figure that out. That's the only thing that even mattered to me about that whole discussion, you know?
Yeah.
And that's why this blue shifting of the goalposts to now talk about it's like changing the subject almost. It's a non sequitur. It's like, well, freely move around.
Well,
I mean, you don't really need to freely move around to witness this thing.
Yeah, but we didn't even the sun wasn't even mentioned at all today. I don't think it may have been, but I wasn't even here. All right.
Well, it's because the conversation gets shifted and people don't realize what's happening. It gets shifted to this other goalpost, which is about freely moving around instead of actually talking about. We're there. We can do the science now. We can do the thing we said we wanted to do. But we forget about doing that. Sorry.
Well, talking with people that have personal experience down there and that have been down there and they have actually told their experience in regards to what they can and can't do there and the rigmarole in which they have to go through to be able to do anything, right, clearly indicates that you just can't go down there. Like you and I can't go down there and go, you know what, we want to do this experiment, we want to do that experiment, we'll just put it all in our backpack, just go down there and wake up in the morning, walk out of our hut and just go do whatever we want. We can't do these sorts of things, Grim. Like we know
Bandy,
this
is anybody going to stop us from putting a tripod up and filming the sun, though? You think anybody's going to stop you from doing that? Because that's the only thing that matters.
Yeah, I'm not really interested in a 24-hour sun myself or 24-hour daylight. I don't think that defines anything one way or the other myself.
Andy,
quite
what
honestly,
would you do? What would you
it
want to do?
Stops Antarctica from being the ring in the model that you're trying to make. Even if you're not trying to make that model, what it does is it just says, "Whoops, you can't go that way." I mean, whatever you're trying to make there, but it just shows you what you can't be doing in your model.
What do you want to do there, Bandy? What do you guys want to do there? I mean,
what I want to do there.
I know. You don't want to go there. I know you don't. I know you don't want to go there personally. But what do the flat Earth community want to do there?
But if for some strange notion I bumped my head one day and woke up a different person and decided that I wanted to go down there for an extended holiday, I'd want to tour all over the place, like hire myself a little RV and just go wherever I wanted to. Like if I came to Australia, I think one of the things that I would do as a tourist on an extended holiday would be travel all around the coast, all the way around it, because millions of people have done it. And not only do they travel all the way around the coast, then they travel up through the centre as well, right? Unrestricted, right?
You understand?
There's a sailboat. There's a sailboat race that goes around
You understand
Antarctica.
You understand that Antarctica is like one huge nature preserve. There aren't any roads. It's like really, really cold, and there's like glaciers and.
That's why I'd hire a dog sled, right?
You can't
Because an
take
RV
dogs.
just wouldn't cut it.
You
right?
need. I mean, it's. I don't know. It's a very hostile place to go. I mean, I don't understand why people want to go there anyway.
I don't disagree that it's hostile, right? Yeah, and I don't, and I'm not saying it wouldn't be a very, very dangerous place to tour around without letting anyone know exactly where you are. Like I personally wouldn't do it myself. I think there'd be grave risk. You'd be taking your life in your own hands. But the point still remains that you still kind of can't really do these things freely under the very strict guidance of whatever government organisation is down there controlling these things.
They're not really controlling you though. That's the problem is that you I've watched the thing that was posted here, and it's you have to tell people that you're going. There's really no one to say no. I mean, you have to abide by the what?
Isn't what was posted 30 minutes long? You said.
I skimmed through it. I'm not going to listen.
Oh, so you didn't watch it? Another lie.
I watched it. I'm not going to listen to Taboo Conspiracy. He's worse than listening to you.
Another lie. Now he hasn't watched it.
Am I supposed to sit here and listen to all 30 minutes of Taboo Conspiracy?
How many times did you lie in the last 30 seconds, Peyton?
I just told you that you're a smart person, so I guess it's a.
No, you said you watched it.
I did
That's
watch.
A lie.
I had to watch. I had to watch every single second of it.
Then you said you're not going to watch this Taboo Conspiracy. Another lie.
Come on.
Rakia, please shut up. I thought you weren't going to engage me.
No, I'm going to engage deceivers. I'm not engaging you as paid as
okay, fine. I'm not deceiving you.
Deceiver.
I know enough of Taboo Conspiracy and his thing.
You notice how many times I have to engage you as a deceiver?
I'm supposed to sit here for 30 minutes.
Come on, guys.
Jeez. Calm it down.
For fuck's sake.
Calm it down, Rakia. Come on. He has just said he has said that he's just skimmed through it, right? He said he watched it and he skimmed through it. So let's just move past it, please.
Talk for 30 minutes, but that's like
okay. We already got the picture. We already got that picture, right?
See, the thing is, once again, he misinterprets it. You don't have to get permission. You have to tell them that you're going. There are certain rules you have to abide by. Yes, you have to pack out all your poop. Okay, that happens when you go in like caves and stuff. It's the same idea. There really is no one to say no to you at this point. Now it's going to be difficult.
Well, no, there is.
Who is that?
Well, no, there is. Well, because with the person that we spoke to, how he was explaining it, NASA, is that you had to fill out all this paperwork, right? And you had to log your path, your locations, where you were going to be, right? A safety plan, right, had to be put in place, weather conditions, predicted weather conditions, all this type of things, and then that had to be approved.
By whom?
Right, they couldn't just lodge it. They couldn't just lodge it and then just go. Like all that process had to be approved. So the process does have to be approved. I'm not like it's not something I'm just making up. Like this. I told you whom.
A committee or something maybe.
I don't know.
Yeah, whoever the people are down there. Maybe they have an OH&S officer down there that puts the stamp of approval on it. I've got no idea exactly whom is responsible for rubber stamping that paperwork, but it's got to get rubber stamped, right? And it's got to get approved before you can undergo whatever expedition that you were going to undertake. Because what they have to do, right? Then they have to make sure the resources are available in case something goes wrong.
Yeah, that's pretty much this sounds no different than like a trek to Everest. You have to get but there's no one. I don't know. I've read the treaty. I don't think it says what it says.
I'm not talking about the treaty, NASA.
Well, that's
I'm talking about once you're there. I'm not. No, this isn't in the treaty. This is what happens when you're there, when you're moving around. It's got nothing to do with the treaty whatsoever. Why are you conflating the two? I have not mentioned the treaty once. I have not mentioned the treaty once.
Who's them then? Who's the they that have to make this approval, and who's the they that are checking up on you? Because there's no army down there.
I just told you, right? The person that has to approve it. What is his title? What department does he work for? I've got no idea. I didn't ask who he was.
All right, Bandy. I'm just saying I don't see this. I don't see this. I mean, I've looked through everything. I don't see that.
You can look through the treaty. It doesn't matter if you look through the treaty.
People,
Because it's not in the treaty, NASA, doesn't mean it's not so what I have just relayed. It doesn't mean that at all because it's not actually in the treaty. Because you're saying it doesn't say in the treaty if you want to take a trip that is 50 kilometers from your base camp, that you have to fill in this paperwork, you have to put in a safety plan, you have to report what the weather conditions are going to be, and then that has to get approved. Because you think it doesn't actually say those words in the actual treaty itself, that these conditions are non-existent. You can't be suggesting that at all.
Well, then give me the documentation that says that this procedure exists.
Oh, so now I've got to give you documentation.
Well, I can't find this documentation.
To say that this is what happens.
You say these are the rules, sir, and I can't find them. If you say these are the rules, then please at least provide me. If you have to provide me the rules themselves, how about a link to them?
I must be lying about it then.
No, it just makes sense that there would be environmental guidelines that you would have to adhere to,
right,
and potentially be denied access if you didn't agree to follow those guidelines.
Well, it does make sense, Howard. It makes total sense.
What Brian posted, the image from I guess it is from the treaty.
Well, there's the treaty itself, and then
hold on, just a second. So it says that what is highlighted there is for commercial tourism. So that's for organizers of commercial tourism, not just tourists that go there by themselves. So it's different rules for those people.
See,
here we go. Yes. There you go. Black and white.
Yeah, that's a commercial.
Yeah,
that's commercial.
Organizers of commercial. I'm not a commercial tourist if I go there alone. I'm not a commercial tourist. I'm just a tourist. I'm not an organizer.
So because it doesn't say private people, because it doesn't actually say private civilians, then those same protocols wouldn't apply to
no, because it says the next
private
paragraph,
civilians.
The paragraph is for commercial tourism, and then the next paragraph is for non-governmental, non-tourist expedition, and that's what I would do. So those rules don't apply to me. I don't have to apply for that paper because I'm not a commercial tourist provider. I'm just a tourist.
Plus, we can mount an expedition.
Well, you know what? I tell you what. You're saying it's quite easy to do it. Well, I tell you what. Show me where it can be done, where I can just walk willy-nilly without having to fill out any paperwork, any protocols, or no, I'm not talking to you, Howard. I know exactly what you said, but NASA and Mole Man are actually suggesting that you can do these things.
There are some paperwork you have to fill out. You need to tell your government, since your government is also a signatory to the treaty, that you're going to go there. That way, the rest they can inform all the other entities that you're going to go there, because the original treaty was trying to prevent people from like building up military and stuff in Antarctica. Now the environmental treaty came later. The environmental treaty is like 91. And you have to follow that too. So I mean, there are rules. Don't get me wrong. It's like going in any expedition. You need to plan. You better have some damn good plans. You just can't like fly to Antarctica today. You're gonna die.
And Banter, I never said that you can go there willy-nilly with no papers. I never said that.
Well, no, Bandy.
No. I meant what I meant was we can go there, and then I can wake up in the morning willy-nilly and do whatever the hell that I want and go wherever I want willy-nilly without letting anyone know, giving them any plan, any protocols in place, any safety plan, any coordinates, any of these things. I can just do it willy-nilly whenever I want. That's what you guys are suggesting, unless the only restrictions is that I don't go on to nature reserves or government military private sites.
No, that's not
this
what
document. This document that Brian put in there, commercial tourism, that would be like organized groups of tourists for money. Yeah. So I mean,
for the organizers. This is not for the tourists themselves. This is for the organizers. That if you go there with a ship, you can't just pump out crude oil. You have to take it away, and you can't just pump out gray water or black water over there. You just have to take it away.
Well,
but this is you can't just pump out crude oil. How
this is talking about
trying to make this argument.
I mean, this thing is self-explanatory. It says that all activities are to be planned and conducted on the basis of information sufficient to evaluate their possible impact on the Antarctic environment and its associated ecosystems. Blah 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 blah. And so, I mean, it's just saying that you got to register your activities, and here's what we're going to do, and here's where we're going to go, and they need to evaluate that and approve it prior to allowing access to it. And that only makes sense to me. I don't see why that wouldn't be a thing that you would expect to have to go through.
No. And logically, I would say yes to that, Howard. Like, if I was to wake up in the morning and go willy-nilly wherever I want, and I get myself in a sticky situation, and that now results in someone else having to put their life in danger to come and rescue me, right? I think that's very, very irresponsible. So I'm not necessarily against these things being lodged and have to be approved, because you want to make sure that the adequate provisions are put in place, right? But what I'm arguing against, which is what I think you can see, is that it's been suggested that you don't have to actually, me myself, if I was to jump on a ferry at Tasmania and go down to Antarctica, that when I wake up in the morning I can do whatever I want. Unrestricted, without having to let anyone know. No, yes, if it wasn't you, it was definitely NASA suggested that I don't have to fill out any of this paperwork, get anything approved by anyone whatsoever, and that's exactly what was suggested.
I don't think you have to do that as an individual. You still can't point to me where you have to do that as an individual going to Antarctica. You have to tell them that you're going. You have to tell them what you're generally going to do. That's right. You have to fill out the environmental impact. That's correct. You have to abide by certain environmental rules. You have to pack out all your poop. Okay, it's like going to any nature.
You have died on this hill, NASA. I can let you
tell me
know that
where
right now.
it is.
You dead.
I'll tell you what. If you can show me where it is, I will come in this room and say, okay, I was wrong. Yeah, but I can't find it. Please.
And this what Brian posted is again for tourism providers, like organizers. It's not for like just single persons.
How else do you think you can get down there?
Well, getting there is difficult. I mean, it's not an easy place to do. It's not like going to Australia where there's 5 flights a day direct for nonstop from Los Angeles on Qantas. It's going to be difficult to get there because it's just no infrastructure. It's not an easy place to get to.
Yeah. I know someone personally that has lived down there. I know a pilot that actually has flown there on multiple occasions.
I've known a couple people.
Occasions.
I know a couple people have wintered over. The staffing agency is not far from here. I know scientists who have been there all winter. It's their stories.
Now's the argument. There's no infrastructure there. That's not true. There's bases all over.
But not for tourists.
What do you mean? What do you mean? If it's not really hard to get, not restricted, You should just be able to fly into McMurdo, or can you file a flight plan right now? You can file it, right? You still have your license, right?
I don't know if you can file to McMurdo. I really
why
don't.
not? If it's not restricted, it's not really hard to get to. Then why couldn't you just file a flight plan and fly
once
into
again,
it?
I didn't say that it's not easy to get to.
Now you're saying it's maybe harder to go to and explore than Australia, because earlier y'all were saying Antarctica is actually easier. You can bring your own food.
Right, but that's why I was trying to get you to distinguish between going there, doing stuff there, or getting there. Getting there, I will give you, is more difficult than going to Australia. There's not 10 flights a day nonstop from LA. Yeah.
But it doesn't matter if you have your own plane. You should just be able to fly in there if it's not heavily restricted.
I don't know if you can.
So now you don't know.
I don't know what the. I have to look into that one.
So you don't know.
I don't know if you can just fly into McMurdo. I don't.
So it might be more restricted, right?
To get there. Yeah. Well, I'm not saying this. I never said it was easy to get to.
So we were talking about the we were talking about the restrictions, just in case you weren't smart enough to figure it out.
No, hold on a second, Mark. I asked you specifically.
We were talking about the restrictions of getting there, and once you get there, exploring freely.
I asked you. That's why I asked you specifically what you were talking
about.
And you were talking about being there. No, sir.
Lying again.
I asked you specifically.
You never asked
You're
me that.
changing the goalpost. You're moving the goalpost,
that specifically. You're lying again.
You're moving the goalpost.
Again. You're lying again. You never asked me that.
You're moving the goalpost.
You are lying again. You never asked me
You're
that.
You're moving the goalpost, Rocky.
You're lying.
No, the conversation has always been moving freely around there. That's how it started. That's how the question was posed. Moving freely around there, unrestricted. That's exactly how it started.
Andy, did you ever hear Peyton Askew ask me anything near what he just lied about?
No.
No, another lie by Peyton Askew.
Yeah, Rakia, you lie every time you open your mouth. But in the
meantime,
okay, Rakia, listen a second. It's okay, Rakia. You're right. It's harder to get to Australia because there's not an international airport in Australia. There, you happy?
Is it harder to freely explore once you get there than Australia?
You can't rent a car.
I didn't ask that. I didn't say anything about renting a car.
What do you mean? What do you mean? What do you mean by easy? Define what you mean by easy, Rocky.
Yeah, I'm trying, but you're over talking me again.
Yeah, like you do to me. I know.
Another tactic used again. Deception and tactics.
Come on, Rocky. Get to it.
Yeah.
Stop it. Stop antagonizing. Just let Rocky finish the point. The
point is, there isn't rent-a-cars. There aren't ways to freely explore. That's the whole point, you asshole. You keep making our point for us. It's harder to get to. There's more restrictions. There's not ways to freely move across Antarctica, which means it's harder.
You've been talking this whole time about the government saying no and limiting where you can go. Unless you can come up with some other document, I have not seen that document. Yes, it's harder to get to. There aren't international airports in Australia. Yes, there are no roads, so you can drive around as freely as you can in Australia. I don't see anywhere where the government can say, you can't go. You just have to say, I'm going to go here, and this is what I'm going to do. The reason for that is because the Antarctic Treaty requires that anybody who goes there, they be told to everybody. So when you tell the United States government, for example, fill out the form, I'm going to go to Australia, they tell Russia, they tell Norway, they tell all the other 50-some signatories.
The fact that your actual travel plans that you lodge have to get approved, right?
No,
before they do get approved, NASA. They do, and stop saying that they don't.
I don't.
They 100% do. They care what you see, right? Bandy, they do, and I'm telling you, they do, right?
Bandy, I will take your word for it.
Enough of it.
Bandy, I'll take your word for it. But if you could actually please provide your source, I would appreciate it. Best.
I've told you who my source was in regards to exactly. I told you who my source was. I told you the conversation with the person that I had. I mentioned that right at the very beginning, exactly the conversation that I had and with whom I had it.
Okay, I'll take it. I'll take this as.
And you know him. You know him.
You haven't.
I don't have anything in black and white for the at least the 13th time. No, I don't have anything in black and white. But like I said, the story has been relayed on how you do travel around there, and these are the steps that you have to put in place so you can travel, right? And seriously, NASA, right? The place is a very harsh place.
Yeah, no shit.
Right? It's a very harsh place.
Yeah,
So
I don't know why anyone want to go there anyway.
So logically speaking, just taking that into consideration, logically speaking, right? The fact that you would have to put in details of what you may want to do, right, and when you may want to do it, and then that plan has to get approved by someone there, actually makes logical sense if you think about it.
I don't disagree, but like I said, I mean, if you're gonna do a expedition like this, and this is an expedition, it's not, and this is, I just don't see where they can say no part to this.
Well, they may not have the manpower when you want to go. There's a reason to say no. Their helicopter may be out of commission. They say no. Their skidoo may have dropped a skid. They may say no. The dogs may be sick, so they can't pull a sled. They may say no. There is a million reasons I can think of that would be reasonable why they could say no. That aren't conspiratorial at all. Yeah, Bane?
Bandy, B-Ball just posted heritageexpeditions.com. I called the number. They're closed for the week. I don't know if they're on vacation or not taking calls today or through like a week from now.
Oh, there you go. There we go. Damn.
That doesn't say
Happy
anything.
day.
They might be open and can give information. I was calling to get information, and they just happen to be not in operation for a week.
Let me give it a try. I'll call them now myself, Rakia, live. Shall I? Let's see what happens. 1-800-143. What am I asking them?
Well, just see if they answer and just see what information you can get on coming down there and traveling freely across the continent.
Yeah.
But the number I called, the 866 number from the U.S., there was a recording saying they weren't open for a week.
Okay.
If you would like to leave a message, please press 1 now. If your message is
There we go. Unfortunately, they're not answering their phone. I tried.
I mean, they had information before that someone will bring Antarctica up, and they just said it's closed for now.
Well, in all fairness, it is Sunday, so so they're probably not going to be open today. But anyway, it is what it is. But I can't believe you guys want to die on this hill. It is really absolutely just bewildering to me, to be quite honest with you.
Oh, no one is dying.
Even Howard sees the sense in what I'm saying.
Yeah, no one cares if you can just really go willy-nilly where you want.
Oh yeah, no, that definitely was suggested. Right?
Someone might have ideted it. But it's interesting that what Brian posts, everything that he posts is only for operators, so it's not for like.
We need to get the paperwork, Rakia, and when they And when they ask what your intentions are, it's to travel willy-nilly and see what they come back with. We'll put in those words, willy-nilly.
Well, there are certain areas you can't go to. I mean, there are some, like I said, historic districts that are off limits. I mean, that's
Yeah,
the
but
same
that's
way.
no different. That's no different to any other country, though, NASA.
Yeah, exactly. It's no
Like,
different than going to the United States. You can't go to Area 51.
yeah, you can't go to Pine Gap and some state forest and stuff.
Pine, whatever it is, in the middle of nowhere.
It's already been explained to you how we know that, and you just seem to want to bring that up to demean the conversation of what we're not talking about.
Other than that, there appear to be no limits as where you can go.
Just heavily restricted, right, by a treaty signed by many countries.
No, it's not restricted.
No really major airports to fly into.
It's not
Lots
easy
of
to get to.
paperwork.
No more than going to any other place. No more than planning an expedition to, say, the Himalayas or something.
Why do you have to? Why do you have to do that? I
Because
just want to go.
similar. It's a
I just want to
similar.
go walk on the beach. Like I can fly to Florida tomorrow, no restriction. So you're saying there is more restriction to go to Antarctica?
Then what? Then I'm mounting an expedition to Mount.
Did
to Mount
you
Everest?
hear what I just said? I can hop on my own plane tomorrow, fly into Florida, and walk on the beach. That's what I want to do to Antarctica. Is there more or less restrictions?
There's more restrictions than going to Florida from Louisiana.
Thanks.
However, yeah, it's also a lot closer and a lot warmer. And
what is the temperature and how close it is? If I have a plane to get there, we're talking about restrictions.
There are many airports in Antarctica.
Well, I only need to fly into one now, don't I?
What's that? Yeah, well, do you realize that Antarctica is a fairly big place?
I realize that if there's an airport there and I can fly into it, I'm talking about how many restrictions there has to be. Why is there restriction? You missed the whole point of the conversation, it seems. You just want to argue.
Well, do you understand? No.
I understand. I do.
No, you don't, sir.
Yeah, surely I do.
Do you know how far Antarctica is from, say, the nearest civilization?
What does that have to do with it?
Well, it has a lot to do with it, actually.
You keep telling me about how hard it would be.
Yeah.
When we're talking about the restrictions.
There are some restrictions.
So it is more restricted.
Well, there are. More restricted than what?
Oh, my God.
More restricted than going to where?
I'm going to tell you to piss off again now. You're being disingenuous.
No, see, the thing about it is that you guys think to say that them has to approve where you go. And I don't see that there are environmental protocols you have to provide. You have to tell them where you're going. Right? What?
Like, what's making it harder
it's just it's like hiking in a cave. If you've ever been caving, you have to pack out your poop. Is that a restriction or is that environmental?
No, we're not talking about going caving. We're talking about just going to a continent, walking around.
It's the same thing. It's a huge.
No, not really. You're talking about going to a specific place, a cave in a specific area. We're just talking about going to a continent, walking on the beach.
Are you really this dense, or am you really this dense?
Yeah, now you're playing around on me. You sound dense, sir.
No, sir.
You're talking about a small little cave in some place that you haven't even named. We're talking about restrictions of a continent.
Yeah, a big continent.
Huge.
It's been declared a nature preserve. The entire place is one giant nature preserve with environmental restrictions that came out in 1991.
Which makes it harder to go to and freely explore, which is our point. Thank you for making our point again.
Well, no, you say it's prohibited.
I never said it's prohibited.
You're
a liar.
I keep people saying that you can't go there, and you can.
I never said you can't go there. Lying again. Liar, 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 liar.
Hands on fire. We have never said that, NASA. Not one of us have said that this afternoon. We have never said that at all.
I keep on saying you can go there, and you say no, you can't. You keep on saying you can go there and do whatever you want, and you say no, you can't.
Such a liar. Such a liar. It's beautiful.
You've been saying it all day. What are you talking about?
Twisting it. We have said
told you people
very
have been there,
clearly
you idiot.
that you can't go there unrestricted and travel willy-nilly wherever you want to go. That has been very clearly what we have been talking about.
You can go walk about there if you want to.
No, you can't go walkabout if you want to.
Yes, you can.
No, you can't.
Why not?
Because you have to put in the proper paperwork to go walkabout. That's why.
It's even more crazy.
Sorry, Crit, go, Boner.
I was gonna say it's even more crazy. You can't go past the 60th south. Everything. The only people going down there are the ones nuking whales at record numbers because they're doing scientific research. So they print on their whale killing fleets.
So no
I
one
don't
can
know
go.
what it is, but these last few days, you guys are driving me crazy. I don't usually get so worked up and fight things so hard, but when I'm right, I'm 100% right. And you guys are just really pushing my buttons
It should
very
really tell you
successfully.
something. When paid national skill has been here a lot, you know the deception has been ramped up then.
They're upset because of the fourth attempt to refill the rocket failed. In their mind, it was NASA is infallible.
Goodness.
They
I
can
like
do no wrong.
line that's going on right now. Who's the they?
They got no suit. They got no rocket.
Who's they?
They've got no plan for a lunar mission.
Has me muted.
You can interrupt all you want. I'm going to keep talking. You just don't have any control here to squawk like you do on their servers.
So yeah, no one's sad about any rockets. Don't even know about any rockets. And I wonder the whale that everyone who goes south of the 60th is using nukes to blow up whales. That's an interesting delusion to me.
That's another alt-hearted moment.
I mean, I've never heard of people nuking whales before.
Yeah, it's a figure of speech that you just completely brain farted.
And I would use nuke myself. But I think yeah, you can travel south of the 60th parallel. It's just that the treaties affect south of the 60th, and what Brian posted is all about commercial tourism, so it's just for organizers.
And even you look at just nuke, heat up with a microwave oven. So no one's ever heated up whale meat with a microwave oven. You're just that bad at very simple things.
See, this is amazing. And it's Sunday.
Nuke to inflict large amounts of damage in a short period of time. This is how bad you are, dude. Like, this is why you're deemed autistically retarded in globe servers. Because you cling on to one word you've got no context for, and then just spiral completely out of control. And now you know why.
You're done with the rant now?
You're the one who asked. And now you got your answer. Do you know why?
So now I can have
spiraling.
I don't have any that kind of roles on any globe servers. Another lie.
Okay, for those who want to know, it's cheaper now to go to Antarctica. 7 nights in Antarctica Express Fly the Drake was $15,495. Now only $10,459. 7 night, not bad actually for
All right, we going?
vacation. 20 nights Antarctica Peninsula, South Georgia, and South Atlantic Islands was $21,000. Now only $12,600. Not bad for 20 nights vacation. That's actually a fair price. Flash sale, 11 nights highlights of Antarctica, 9,800 down to 6,600. Interesting number. Ha ha ha. Number.
He's lucky 16.
Yeah. Number to call.
That's actually pretty cheap. That's actually
yeah.
pretty cheap, actually.
20, you can't go anywhere for 20 nights for 15,000. I'll list these just in case anyone's interested. And yeah.
Are you gonna go?
It would be
I'm going.
interesting
No, I
to
don't
go.
like the cold.
I hate the seas are fucking rough.
But I don't know, my man. If you want to start up a GoFundMe, right, to fund my,
You'll go.
I'll do it. I'll do it. Yeah.
Yeah, if people pay for me to travel, I would travel to anywhere. Then North Korea, whatever, I will go.
Yeah, definitely. I'll buy a beanie. I'll buy my own mittens. I'll go there.
You need more than that.
I'm willing to do that.
You're like 20 layers of clothing.
I'll get one of those new coats. They've got these coats apparently that they have like an electric blanket in them. You have like a little battery pack. That's what I'll be getting. Yeah. Those little puppies.
Yeah,
that's cheap as.
It would be interesting to drive to Siberia because it's far, but it's not that far away from me, and they get like negative 70 degrees Celsius.
Ooh.
Would be mental.
Doesn't Antarctica go like minus 120 Fahrenheit?
What's the tourist attraction in Siberia? Is it the salt mines or something?
I don't know. The borehole.
The borehole. Oh, is that in Siberia? That borehole.
I don't know if it's exactly in Siberia, but it's in northern Russia.
Oh, okay.
I think someone. I think Lowry went there to see the hole.
Oh, really? I think there's 3. I think there's actually 3 from memory. I think one goes about 7, one's about 7.5, and then they hit the record at 8 point something.
They recorded apparently minus 89 Celsius in Antarctica, which is approximately minus 128 Fahrenheit.
I can't even fathom that. But you said Lori went to and saw the hole. Did he post any pictures of it?
I think it was like a year or 2 years ago, because now that I think of it, I think it's somewhere sort of close to the Finnish border.
Yeah, I think. I mean, it's just like a capped off drill hole, like a well, oil well or whatever.
Uh-huh. Yeah, it's nothing. So.
Yeah.
But
the pictures I've seen looks pretty boring, actually.
But it's in Murmansk, so it's see, it's not too far away from Finland, actually. Yeah, it's not far. It's like 40 kilometers or something from the Finnish Lapland. I could drive there in 1 day from where I live. Well, 10, 12 hours.
Would you need to fill out any paperwork or bring your passport? You would? You have to cross the border?
Yeah, I have to get a passport, and then I need to file a visa and tell them where I'm going. And I can't have... I think I can only have... Don't remember the amount of fuel, but you can only have so much fuel because it's much cheaper in Russia, so you can't bring back so much. So
you can only cross the border with so much fuel in your tank coming back. That's something. They don't want you filling up with cheap fuel. That's unbelievable.
Yeah, you can't. Both ways, you can only have so much fuel.
Yeah, I get it. I get it.
Bastards.
strange rules everywhere.
They do that with beer too in the States, right? You can't bring beer or cigarettes to certain states.
Is there a limit
States.
between Mexico and USA? Like, are cigarettes much cheaper in Mexico than they are in the States?
Yeah.
Yeah, I mean, crossing the border like that, there's definitely, they don't want you just transporting things. When you fly international, you can't bring fruits and vegetables back or whatever.
Yeah. It was interesting. So I know a guy in the USA who works for the Kone lift company, the Finnish company, and he liked the Finnish gin and tonic that won the world's best gin and tonic competition, and they have lingonberries in the drink, and he was wondering like how can he transport lingonberries from Finland to USA because he couldn't find them over there. Then I just told him to go to IKEA and he can find them there frozen. It would be interesting to go to the Arctic Ocean because you can travel north over here and you can just arrive at the coast of the Arctic Ocean. Go and have a quick swim in there.
Like all they can do is just film them now. Japanese whaling fleet filmed by Australian government. Graphic warning: Japanese whaling fleet. What's been happening since 1993?
Come on.
They just slap a sticker on the side. You can't even post the images. There is considered gore. They just slap a sticker on the side of the ship saying scientific research.
Yeah, the whalers, right? The Japanese whalers. Yeah. It's fucked up, dude.
And this is okay to do inside the treaty. But going there and looking around is not.
It's condemned and they shouldn't be doing what they violated, right? And they just get like slapped on the wrist. Basically. Yeah, there used to be a show, I don't know if there still is though. I don't know if you've seen it, like Whale Wars or something like that.
Yeah.
Yeah.
With the Sea Shepherd and a couple different ships and
yeah,
it turned into like they rammed somebody. They rammed the boat and almost sunk it.
Yeah,
one of them got shot in one episode. Like these whalers are aggressive.
Yeah, they called people trying to stop them eco-terrorists. They think they're actually dealing with, and they're the ones terrorizing. I mean, the whales go to this area to breed. It's like a family reunion.
Yeah, it's fucked up.
Yeah, but the actual the Greenpeace people, whether or not you agree with their cause or disagree with their cause, they do some quite dangerous things and put other people's lives in danger.
Yeah,
yeah. I mean, the whole thing. That's what I'm saying. The whole thing is completely messed up. And what makes it relevant to this debate is that you can't go there legally unless you're down there killing whales. See, why is it okay to not go down there and film? Actually, me, you, and Rakia want to go down there and film whales.
We probably could, just need a lot of money, right?
Yeah.
And get the permits.
Yeah.
But you could go down there as the Japanese government and nuke them. You know, like.
Well, that's the thing.
No,
what they're doing is not legal.
Be fair, right? The Japanese are only whaling for scientific purposes, right? That's just what they're doing.
Right, but everybody knows that they're not, because, like, for scientific purposes, you're only supposed to get like X amount of whales, right? I assume, and they violate that.
Yeah.
They get like, like 8 or 9 or 10 or I don't know. I don't know the number. Right.
Exactly. Yeah. But that's the guys that they used to go down there under. And I actually think that those restrictions have been lifted slightly recently.
Huh.
But yeah, what's wrong with a bit of whale blubber? Is so useful. Whale oil, right? You got to keep your candles going. Right?
They eat it, right, in Japan, I think, and other countries.
Yeah, I think in bloody hell, I'm having a brain fart. Where do Eskimos come from?
Well, it's north.
Where do they? Yeah, is that in Alaska? Is it Alaska?
Yeah, Canada, Alaska.
Canada? Yeah.
I think you're supposed to say Inuit now. It's like
Inuit. Okay. I can't call them. Oh, really? I can't call them Eskimo.
No, I think that's considered racist now.
Oh, really? Well, I didn't mean it as such.
Yeah.
So
like,
anyway,
that's crazy.
Oh,
That's
well,
racist.
okay. That is crazy that you can't. Anyway, it's such a cute name, though, Eskimo. Like, what's racist about it?
Yeah. There's like nothing tied to that to imply racism.
But I think the Inuit have they get like a free pass because it's their native food, so they can kill a whale or club a seal if they want to eat them, whatnot.
Yeah,
I think I read that somewhere.
Yeah, those areas are a little bit different, because they use like the whole whale, and they use everything. They use it like all the bones, like the blubber, every single thing is used.
Yeah,
these whalers are making like 300K or more per whale. Just insane. The Japanese ones.
you can't say anything these days without, oh God, this is wrong, that is wrong, the other thing is wrong. Man, we used to throw words around willy-nilly at school. No one took offense to it at all. No one took offense at it. Have you clipped me crit saying Eskimo?
No.
Good. I'm going to delete it.
That'd be pretty funny. At one time, have you ever in your life used the term Eskimo?
Yeah. Yes.
Someone will be outraged. Some globalist will just be outraged.
Oh, I don't know why. Like, it's absolutely ridiculous. But what a harsh life that they live. Really, like,
why don't they just like jump in their canoe and go somewhere sunnier? Like it's ridiculous to live in an environment like that by choice. Don't know why you do it.
Like in between Kuwait and Iraq, there's like people who live on the. I think it's okay. They call them Bedouins. I mean that you never know what term is appropriate, but
yeah.
Out there, but for generations, like they just no contact with really society at all.
Okay.
Yeah, they're still out there. I mean, I saw them like, when I was anyway. So they have, a stateless Arab minority that lives between Kuwait and Iraq. They're somewhat considered independent. Their population's around maybe 93,000. Bedouin just translates to without.
Oh, okay. Okay. Gee, it's been a bit boisterous this last 24 hours, I must say. Good to have a calm in the storm. To all those out there in YouTube land, I hope you are thoroughly entertained and most importantly, well informed. Please feel free to join the Discord channel and drop us any suggestions of topics or issues you'd like us to talk about.
Look at this Sea Shepherd. They used to do that stuff for the whaling in the South Pacific.
Oh, Greenpeace.
Yeah, they're now just picking up plastic out of the ocean.
Oh, really? Isn't there some big floating plastic island?
Yeah, it's a huge
I read
one.
some time back. Some huge. Yeah.
I think it's interesting because that island doesn't seem to be affected by any sort of Coriolis force. It just stays.
Coriolis, yeah. Just stays there. Quite surprised that sand piracy doesn't get more airtime. I am. Ever heard of it?
Sand piracy?
Sand piracy, yes. Have you
No.
ever heard of it? It is a huge problem. It is literally a huge problem. It is the number one resource that we use in the world, sand, by far, more than anything. because it is used in absolutely everything. Absolutely everything. And the amount of it that we need is just incredible. Absolutely incredible. All forms of construction, glass, optic fiber, computers, you name it, ceramics, absolutely everything. Roads, everything. Sand is the #1 resource. And the amount of illegal dredging that goes on, as well as sand piracy itself, is incredible, and it is causing a huge, huge problem. And I think it can be contributed to the erosion that we see around our shorelines, actually. Because if you think about it, because I've watched a couple of TED Talks on it, and I've read a few articles, and the way they explain it is like sand itself is like one big living organism, right? It's all kind of interconnected. So you can demonstrate this by going down to the beach, right? And if you're near the water, where the waves come in, and you dig yourself a big hole, right? And we've all done this as a kid, and then the water comes in. What happens? The water will grab sand from another spot, and it'll fill in that low spot with sand, right? And that's what it does, but it has to get it from somewhere else. Well, if you are taking that sand from that one particular area and dumping it somewhere else that is not in the water, well, it has to replenish itself from somewhere else. So it drags the sand from all around it. Okay, and that is just a ripple effect everywhere, absolutely everywhere. It is sand piracy itself is the #1 organized crime cartel in India alone, right? The #1 organized crime cartel. It's absolutely, I think it's mind blowing, really. Sand, little old sea sand, right? The #1 criminal cartel activity in India. And that's just India, let alone any other country around the world.
I mean, that's interesting. It makes sense because it's like easy to black market because it's like
yes,
sand.
Mm-hmm. Yep.
As compared to like blood diamonds and stuff, which are hard.
Yeah. And people just think, oh, sand. Like there's so much sand in the deserts, in the ocean. Like can't possibly be a problem, but it is a huge environmental problem. Absolutely massive.
In a place in Florida, Hollywood Beach, Dana Beach, it used to be just a rocky beach there, and what they did is they did all these trucking events where they just dumped sand after sand after sand.
Yeah.
So they'd have sandy beaches, and they had like a restaurant there, and they wanted to build a pier and everything to kind of like make an artificial beach, if you will.
Yep.
So a storm came, a hurricane came, and just pulled all that sand out into the ocean and completely covered up the reef. Mm-hmm. It's still to this day there's like an ecological hazard that there's, like feet of sand that are just completely buried the reef.
Yeah, I saw in one of these TED Talks that I saw. I think it was along the Californian coastline. I can't remember exactly what part. But the erosion that is taking place there at the moment, there's houses right now that are slipping into the sea. There's erosion that goes back 2 or 3 houses, like deep, like 2 or 3 streets back, like the erosion. And the suggestion is that they're attributing this to the illegal dredging that goes on, and also to the sand piracy per se. That's what they think it is. It's got nothing to do with this global warming or anything like that. They're putting it purely down to the illegal dredging that goes on. And when you think of sand piracy, and in India, the sand piracy is done very, it's done in a very primitive way. It's basically, you know, they've got their little barge sort of thing, and they have 100 Indians jumping off the edges of these barges with buckets, diving down and pulling up sand and filling up the bucket. But then you have these monster dredges, like these things are absolutely huge, and the heads on them are once again they're just absolutely massive. And you know the amount of sand that they can pull up per hour, I can't remember it, but the figures that they were giving were just insane. But these dredges that they use, because you can dredge sand legally, but then once you've reached your quota, then they obviously do everything off the books. But the dredging alone is indiscriminate, right? Because it just doesn't lift up the sand; it lifts up everything in its way and destroys everything in its way as well. It's crazy. So, just a little tidbit for all you people out there in YouTube land. Do yourself a favour. Check out Sand Piracy and get onto your local MP immediately. That's funny, Branch. Oh.
Yeah, this is a really good information. It's something I didn't even know about. It's just spreading awareness is really huge. Like the Guardian, the world is running out of sand. The sad truth behind stolen sand.
Hey, see? People think I make it up. I've brought it up a few times and then everyone kind of just goes, yeah, rubbish. What a load of rubbish. But it is a real problem, Grit. It's a real problem.
Here's another hit for it. Sand pirate. Loaded derogatory term used for like part of the Muslim community.
Okay.
This kind of reminds me of that skit for Hitchhiker's Guide to the Galaxy, where they're worried about erosion, like biomass erosion.
Mm-hmm.
So, like, if they visited this like paradise planet, but you had to keep a copy, like a receipt for everything you ate and everything like you passed, as waste, and then you had to square that. Otherwise, you couldn't leave, until like. And it shows like as a guy getting like a hand removed. It's like, oh, you're a little short here. Yeah, okay, so why is it important? Like, if areas are removed of sand, water flows more quickly, causing devastation downstream. Depleted of sediment, faster soil erosion.
Mm-hmm. Mm-hmm.
Salination of the soil. But the sand acts as a buffer between like the ground and like the soil and the ocean.
Yeah. Right. It's quite interesting, actually, when you delve a little bit into it, Fred. And it's right under your nose. So,
That's where like the world's so messed up. People just stop noticing. They just don't even notice anymore.
Remember, I brought it up a few weeks ago, and someone in here just poo-pooed the whole idea. I can look outside and there's enough sand here to last my community a lifetime type of thing. But the funny thing is, though, that like you see all the sand in the desert, right? It's a completely different sand to the sand that's in the ocean, right? The sand in the desert, I don't think it's compatible for silica, making glass and stuff like that. It's got to be sea sand, number one, and optic fiber. That's the sort of sand they use. But it's also too unsuitable for anything to do with construction, because apparently it gets blown by wind. They're like tiny marbles, so they're like little spheres, but they've got very, very smooth edges, right? Whereas the sea sand is all jagged, right? So when you use that in a construction format, it kind of locks together and becomes very, very solid, and it's way more stable. So that's why you've got to use sea sand as opposed to desert sand.
Yeah, I've seen it like in NTC, this training center in California. It's like a desert that's like really close to like the Middle East, and it's like a powder. Like the sand just blows around, and it covers everything. It's like this. It's got a lot of static to it, so it just coats. But it's like a real fine sort of, almost like a dust, or powder. And then a huge windstorm will come through and like blow it all away, and it'll just be like a rocky ground. And then a couple days later, the winds change, and you're just covered in sand again.
Yeah. So apart from the fact that it's very fine and like little marbles, like I said, it's I don't think it's compatible for the making of glass. I think that's what they said in this head. I'll just Google it, actually.
Yeah, PBS did a special in 2013 with a French filmmaker from Champs-Élysées that 2013 about the international illegal sand trade. It's probably only gotten worse since then.
Yeah. Oh, yeah. Oh, I see it. I think
it won a bunch of awards for the film festival of the year 2013.
There you go. Yeah, like I said, I think Wiki have a site that it names India specifically as its #1 organized crime cartel, sand piracy. It's definitely out there. Like it's not as though it's kind of like hidden, like a hidden secret, but it just kind of goes unnoticed, really. What do you got for us, Branch? You gonna talk? Here's your opportunity.
Oh, he ran.
He ran.
Yeah, so you just said that he disconnected.
You put him on the same.
Has Brian been back?
Brian, no. Oh,
Flat Earth Fest?
as in. Oh no. Well, he's here, but he's on.
Oh, I know yesterday he got kind of frustrated, just left and wasn't sure.
Well, yeah, he was getting a little bit wild, and he got muted and then dropped out. People don't like it when they get muted. We had that issue last night. Go and drive.
You think it takes a little bit? It takes a little bit of time to realize that this is more about the energy they're putting out than what is being said. So if what they're saying is good, but it's such a high intensity, then it's like they're going to get muted here.
Yeah, well, you were here. You were here yesterday.
Yeah,
it's getting pretty. And you got to do something. You got to step in, create and people think they're wrong. It's just like, well, cop it on the chin, sunshine, and get on with it. I don't. You're not really going to win the argument, really.
I think what
Might as well
happened.
just let it be.
Oh, sorry, go.
Sorry, mate. Go.
I'll say my take is that the
you go.
globalists started to interrogate, or not interrogate, instigate, like after it happened in the text chat, like they were coaxing and saying a bunch of rude things and like you're gonna lose and like learn your lesson, or I can't remember exactly the verbiage that was used. I'm sure it's still all there.
I can't remember. I wasn't really watching the text per se myself, but I was quite frustrating, especially when you have some bigger personalities.
Yeah, like he's Elijah's whining. Left lane, you're going to lose. Mark Taylor begging Brenda, you're trying to turn this into the shit show. The Nathan Oakley shit show.
Look, I remember that. Yeah, because I think Elijah called on Geo himself and said, "Do you agree with the muting or something?" And it's just like, what are you trying to do? Override the decision that's been made, mate? Like, what other dramas are you trying to create? I did actually see that one.
Yeah, so it kind of was an intense situation all around.
Yeah.
Yeah, today was lively.
Yeah, it was percent, wasn't it, buddy? Yeah. He snuck in there. It was a bit, but you just got to try. You make your best judgment call at the time, don't you? It's not as though you're singling anyone out, but just trying to keep it under control, and then people take it as a personal attack, and then have to justify their position, and then ramble on for 5 minutes how wrong they've been. It's like, I don't want to hear it. The chat doesn't want to hear it. Just get on with it. You're unmuted now. Mm-hmm. No need to make a point about nothing. Is what I think.
I think we did good, all things considering how hectic it was and stuff.
Yeah. Oh yeah. Yeah. Like when I popped in, because I'd been out for some time, and I popped in, this morning before I went fishing, and it was like at 100% when I dropped in. Like it was just like, whoa, what have I come into? Like this is crazy hour, crazy hour.
Yo, did you catch a lot of fish?
Three salmon, yeah, 3 salmon and a blowy or a blowfish. So
big salmon.
he got fed. Smallest one was about 2.1 kilo, and the largest one was about 2.6 kilo. So decent size. Yeah.
That lasted a good week and a half, maybe more.
Yeah, well, the small one we're having tonight for dinner, that'll be gone. The whole thing will be gone tonight because I love salmon. Absolutely, I pig out on it. What's so good about it is that when you sit down at the table and you have this piece of salmon and it's just been beautifully cooked, and you're sitting down to a $100-$150 meal right there if you go out to a restaurant, like so.
Yeah.
So I just
Your
make a
wife
glut.
does a good job.
I make a glut.
I was gonna say your wife does a good job, does she?
Oh yeah, yep. Yeah, magnificent, absolutely magnificent.
What about the blowfish? Isn't that poisonous, right? I mean, for people, right? Can you eat it? I mean,
I don't think it's the blowfish one that's on the Simpsons type of thing that they yeah, we do eat it raw, Globy. We do eat it raw at times. But yeah, no, it's just
How does it taste raw?
What? Oh, it's beautiful. It's beautiful, and you have it like.
Oh.
How does it taste? How would I describe it? It tastes like salmon.
Really?
Yeah.
Raw salmon or cooked salmon?
It's quite a sweet fish. It's not very fishy. It's very subtle. It's a very subtle flavour. But yeah, it's quite a sweet and very soft to eat. And when we eat it raw, my wife she'll make up like a dipping sauce to go with it. And oh yeah, that's just to die for. You'll have the dipping sauce. You'll have some wasabi with it as well, and any other.
I don't recall ever eating blowfish, to be honest.
No, I wouldn't eat it.
I don't think I've ever.
No, I call.
Yeah.
Yeah, no, the blowfish, the first thing you do with them, because they are a pest, you just stab them and throw them back in the water. Oh, yeah. Yes. But then I think tonight it's getting, I think the boss, she's going to steam it, smother it with chili, lemongrass, a bit of garlic, a bit of pepper and salt, and we'll just have that with a homemade potato salad he makes with our homegrown potatoes, and a green salad with a nice little vinaigrette.
That sounds heavenly.
To boot. Oh, mate, like I said, and the best thing about it, pretty much all the stuff we eat is free. It's like homegrown, home caught. It's like it's the life of a king.
Dream.
Really, it really is. Yep. And my wife is a beautiful cook, absolutely beautiful. I'm very lucky there. But I have this thing going with her because my grandfather taught me very well. He said you never compliment the chef too much because their standards drop. So there was this one particular night she was making a sauce. We're having a steak, and she made a mushroom chili sauce. to go with it. Anyway, she thought she didn't have it quite balanced. Anyway, she brings over a spoonful and says, "Hey babe, taste this. Tell me what you think of it." So I tasted it. And I'm just like you're tasting wine, breathing in, making all these stupid little faces and what. Exactly. And I'm like, oh, I don't know, babe. It is so close, babe. It is so close, right? But I don't know. There's just something. Anyway, she's gone back into the kitchen. Yeah, there's something. I've got no idea. I've got a terrible palate, right? I just couldn't pick it, right? Anyway, she's gone back in the kitchen. I'm pissing myself laughing. It tasted absolutely beautiful, absolutely beautiful. Like I'm looking out of the corner of my eye. She's tasting it. She's trying to work out what to do with it. She's added a bit of this and a bit of that and whatnot. I don't know. Like, is it better or is it worse? She brings it over. Yeah.
Sorry, no,
Yeah. She brings it over. She's, what are you? Oh, a bit of latency, yeah. Anyway, she brings me over a second spoonful of the stuff, and it tasted even better than the first spoonful, to be quite honest with you. But I've just looked at her. Yeah, it did actually. It did. I don't know what she did to her, but I've just looked her fair square in the eye. I said, "Babe, it was perfect before." I said, "You've destroyed it now." I got the biggest clip across the back of my head. Like, she couldn't believe it. She goes, "You've made me go back in that kitchen and you can cook for your bloody self in the future." Oh man, I've had to give her a big hug and all that sort of stuff. It was quite funny to be there. But so now it's like this
in the end when you told her it was perfect.
Yeah. And so now it's this ongoing joke now. Like, if I get up and I go into the kitchen or whatever, I'll taste the sauce and I don't know, babe. I don't know. It's so close to being there. And she just looks at me. She fucking rolls her eyes and whatnot. And anyway, so I'll just walk off and I'll sit down on the couch or whatever I'm doing. And then when I least expect it, she just walks up behind me and just clips me across the back of the head. And I just glare. What the hell? That's for being a smart ass. All right.
Well, it sounds like you guys have a wonderful relationship.
Yeah, mate, we do. Yep. Most
it is good advice, though. Treat him mean, keep him keen.
Exactly right.
As long as you're doing it playfully and stuff like that.
Oh, exactly, mate. Exactly right. But she wears the pants in the family. She is the boss, so I know my place at the end of the day. So I've got no dramas with that. Sorry.
I said, is that a fact? You just whatever.
Is that a fact?
Yeah.
Yeah, pretty much.
Happy wife, happy life, right?
Exactly. It's such an easy recipe, percent. It really is. Like, it's not really difficult at all. They don't want much, but they really do not want much at all. They just want a little bit of attention every now and again, right? And occasionally just to listen to them. Right? So I can do that occasionally. I can pretend I'm listening.
You got to figure it out.
Which is, I pretend I'm listening. 100%. I pretend I'm listening. And then a couple of days later, she'll go, "Oh, remember when I said this?" And I go, "Baby, did you talk in my bad ear again? I'm deaf in that ear. Like, I thought you would have learned by now. What did you say again?" All right, so, but I think she's on to me anyway, to be quite honest with you. I think she's on to me.
I hope she didn't hear that. When you are on here, are you in the house and she's doing her thing?
Yeah, she just does her thing. She's been on here.
Huh? She has?
Yeah, she's been on here a few times actually. Yeah. She's been on gems too.
Oh,
actually,
in the lion's den.
Yeah, yep. They could not believe that I had a flat earther for a wife. They did not believe me at all.
Yeah. No, you're a lucky man. That's for sure.
I know. I know. I'm very, very blessed. Percent. I am very, very blessed, and you know what? I know that. I actually know that I'm very blessed. So I do not take it for granted one little bit. But you know, she has, got no problems with me doing what I'm doing. As long as I service her well, and tend to her needs, it's pretty much free reign, to be quite honest with you. Which is what you want, isn't it? Really.
That is exactly.
Yeah. As long as I take care of business, no problems whatsoever, and she looks after me very, very, very well, very well. Cooks and cleans and all the other things that a man might desire as well. So I have absolutely no issue whatsoever with any of those things. And all I have to do is just make sure that the weeds are pulled up, and something's painted, or a shelf is fixed, or a doorknob isn't falling off. That's about all I've got to do, mate.
Going on how many years
Happy
now?
How many? Oh God, a long time, mate. A long time. Yeah. I don't know. You know what? I'm absolutely hopeless with dates. Oh, that's my downfall. Ask me my children's birth dates. I don't know one of them. For some reason, dates and stuff like that does not stick. And all my children know. They have learned, right? And even my wife knows. If you want a birthday present, you've got to give me at least like 2 weeks notice and let me know when your birthday is coming up. And then I need a reminder 1 week prior, right? Because if you don't, no present for you.
That's a good system.
Yeah. I don't know what it is. I don't know what it is about dates and anniversaries and stuff, but those things just don't stick for whatever bizarre reason. But you asked me my license number, my credit card number, pins, this sort of stuff. Bang, I can remember. I can recite them. Bang, 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 bang. No problems whatsoever. But when it comes to my most loved ones in their life, remembering the simple things like their birthday, can't remember, or an anniversary. There is only one birthday I remember, and that's my mum's. And the only reason
your own?
no. The only reason I remember my mum's birthday, because it's my birthday as well, because I was born on my mum's birthday. Yeah. Yeah, that's the only reason. Yep. It's insane. Absolutely insane.
I've never heard of like a son being born same birthday as their parent.
Oh, seriously, mate. Imagine having a baby that was like 27 pounds. You'd have to push that out on your birthday. Man, that would have been an horrific birthday for dear.
Wait, why 27 pounds?
Well, I wasn't, but I was a pretty big baby. But yeah, I was about. I can't remember.
Pounds?
I think I was 8 or 9 pounds. Yeah, I was a pretty big baby. Yeah, but having said that, I'm 6'3" as well. All my sons are taller than me too. My eldest son is 6'6.5", 6'7". My other sons, they're taller than me. I've got a daughter that is slightly shorter than me, and another couple of daughters that are a little bit smaller than her as well. But I have bred giants. They're going to be Yes, I am a big baby. Exactly right, Globus. I'm a big cry baby. Don't get me going.
Yeah, my
Wait till
sister-in-law,
later on.
she's like pretty petite, and she gave birth to like a 10-pound 9-ounce baby. I think.
Damn. Yeah.
It's crazy.
Yeah.
Like looking at her, you would never have guessed that the baby that big came out of a woman that petite.
Yeah.
But
Yeah. My wife's pretty petite as well, actually. But we actually had a scare. Well, not a scare, but you know what I mean. About 4 months ago, thereabouts, we thought we were going to be having another one. How's that? Like if we had had another one, our child would have been younger than our grandkids.
I'm sure part of you would have would have been ecstatic at the chance to have another one. Hey.
Oh man, look when she broke the news to me, she said, well, basically she said, "Hey babe, I think I'm pregnant." And I went, oh, no, kind of thing, really kind of silly. Like I was excited. I was dead set excited. Like I was looking forward to it. Like really, seriously. Yeah. I've got all the signs and whatnot. Like blah 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 blah.
It gets boring when it's an empty nest, hey?
Yeah, and I was actually really, really excited. And then anyway, no, she obviously isn't pregnant. But yeah, when we actually found out that she wasn't pregnant, it was actually a bit of a letdown. Yeah, it was a bit of a bummer, I must say, because you got yourself all worked up, and for a couple of weeks there, we were sort of like fairly excited about it, I must say. We spoke about names and all this kind of stuff. It was really, really weird. Right? Yeah. I know. Like you're almost supposed to be retired type of thing. I'm talking about bloody baby names. Like it was a really, really good feeling. And but anyway, it wasn't to be for whatever reason, because look, because when it comes to contraception, we're pretty sloppy, I must say. So I'm surprised we haven't had any more. But
have you considered trying for another one?
We haven't gone out of our way to try. All right, we kind of got to the stage where it's just like, okay, then we'll just take these precautions. Like, my wife did try for a while to be on contraception, and that lasted a very short amount of time because it played literal havoc with her body. Absolute havoc. She absolutely hated it, right? And which is fine. It's just like, yep, no problems whatsoever. Don't do that. So then she got a IUD put in, and that once again played absolute havoc with her body, like really, really bad. Yep, pull the fucking thing out. Got no problems with that. Pull it out. And so from then, we occasionally we might use a condom, very, very occasionally, because she hates them. Well, she hates the things. Thank goodness she hates the things. So we kind of went on the whole rhythm method type of thing, or just kind of pulling out. And that's kind of what we've used for a long, long time now. So the fact that she hasn't fallen pregnant is probably arse, not class, to be quite honest with you, percent. But
I was saying, given the fact that you guys were excited with this, a potential pregnancy, maybe you want to rethink it and maybe go for it.
It's funny you should actually say that, because like I said, we've practiced the whole rhythm method and pulling out and all that sort of stuff, and we did have that exact conversation. And
it's something
well, when you think about it, percent, it seems quite it's like sacrilege to waste perfectly good semen and just have it like go all over the place. Like there's a perfect little nesting hole for it if you think about it. So why not just keep it there? So that's kind of the decision we have made, actually. And we'll see what happens, because she is going through that time of life too that women of her age go through with menopause and whatnot. So all that sort of stuff is all over the place anyway. But yeah, we have definitely made the decision to not be careful at all, actually, and just see what happens. Just see what happens.
Yeah.
Because it was a good feeling. It was such a good feeling, because we love kids. We absolutely love kids. So
in my faith, the rule is basically, if the woman, if your wife wants you to stay in, basically, then you stay in, and if not, then you could pull out or whatever. But if it's up to your wife, basically, and if she wants it, then it's your duty to do it.
It's your so your wife gets 100% of the say when it comes to that. That's interesting, man.
I mean, in the end, it's something that's like destined by by God, whether it actually takes or what have you. But yeah, you don't pull out unless like you and your wife are agreed that you're not going for it or something like that. But if she wants you to, and if she like looks you in the eye in the moment or whatever, it is what it is.
Yep. And it's actually been quite interesting, our love making since it's had this this newfound intensity, I suppose, for want of a better description. Not that it wasn't ever healthy.
Like coming off the pregnancy, like the potential pregnancy, or what?
Yeah. Like I said, we've always had a very good sex life. There's never been any dramas there whatsoever. But since the scare and since the discussion that we had in regards to, well, why are we being careful whatsoever? Like, look what it did for us. Look how we felt about when we thought that she was pregnant. Like, it was just a sensational feeling. So, the actual lovemaking now has this new intensity about it. Yeah, like it's like, it's hard to explain, percent.
Say less.
Like,
I understand. Understand exactly what you're talking about.
Yep.
And you never know. Maybe that'll maybe just the intention that goes along with that. The feelings that go along with that. Maybe it'll, improve the chances or whatever. But I wouldn't be surprised if you had another pregnancy scare in the near future.
Yes, well, look, you can only hope. Because she Googled all the things in regards to having children at her age and all the things that can go wrong.
I assume she's quite healthy. She sounds like she's like.
Oh yeah. We have a healthy lifestyle. We've got a healthy diet. She's actually healthier than what I am. She's a lot fitter than what I am too. But she started Googling, because that's what you do. You Google, Dr. Google. And started looking into all the dramas that can occur, with pregnancies of people our age, and Down syndrome, was a huge one. Being high on the spectrum of Asperger's and autism and stuff. You know, these were apparently a very real risks. Yeah, we spoke about it, and she said, "Well, what if?" And I said, "What do you mean, what if? What if it'll be our child?"
Absolutely.
Right? Yeah,
That's what you
it
need to
doesn't
hear,
matter. Yeah, it does not matter how that child is born. It'll be something that we created, and we will provide and love it the best way that we
Plus,
can.
the medicine is, very well equipped nowadays to handle these, sorts of issues, both before, while she's pregnant and afterwards. So
yes,
not to mention, what's one of those disabilities in the face of life, miraculous life, this blessing of life. There's no choice.
No, exactly. Yeah. No, we are definitely 100% pro-lifers.
Did you hear about the Roe v. Wade being overturned?
Oh, in the States, yeah. So now but now apparently the states can make their own laws individually, but they overturned it, and I don't know, but then what do you think about it yourself?
Oh, I like it, man. I just like that the blue states don't go crazy with making their own laws that that mandate abortions and stuff like that.
Yeah.
But if it was all pro-life across the board, I would be ecstatic because that's what's about. Abortion is murder, straight up.
Pretty, yeah. I agree with you 100%. That's how I think of it.
Except for exceptions, really. If the mother's truly in peril, or if the baby is going to be just not just handicapped, but deformed, won't kind of be able to sustain itself, what have you, then those are the exceptions that make it permissible, as far as I'm concerned, and as far as
there's got to be absolute extreme circumstances.
Exactly.
Extreme circumstances. And this, because I always mount the argument, because you've heard quite often, my body, my choice, right? Fine, it's your body, it's your choice. So you've decided to have sex with me willingly, unprotected, and now you've fallen pregnant, and you're the one that gets to decide whether or not we can bring that life into the world or not. I get absolutely no say in it whatsoever. My objections aren't heard as the father. I want to bring the life into the world, but my opinion is just rebutted and kicked out.
We should come up with a new
court
slogan, Bandy. We should be like, "My sperm, my say."
Yes, exactly. Where is the guy's choice in this? The guy gets absolutely no choice because it's not my body. Well, sorry, my body is in your body. I should have some say in it. That's how I feel about the whole my body, my choice. I just think it is just totally hypocritical and one way. And I think that and this is going to sound really extreme, right? Really extreme, right? A couple of things I'm about to say, but things because I think abortion is used as a convenient contraception. To be quite honest with you, for very poor choices that are made, and I'm not even comfortable myself personally with the morning after pill. If I'm being perfectly frank, right? If you want to make these decisions, be free and easy, right, and then wake up in the morning and go, "Oh my God, I suddenly regret it." Well, you should have thought about that the night before, in my opinion, right? But that's a pretty hardcore approach to take, I must say.
I'm very close to you. I don't know about morning after.
Yeah.
But I kind of, for me, it's like, if the zygote has, if the sperm is in the egg, then, you know, that's a future life. You know,
Exactly.
with our the technology and of our medicine, and you know, the current system of our medicine and stuff like that, the huge overwhelming chances are that it's going to be not like a healthy pregnancy and birth, right? So it's going to be a healthy baby. So for me, it's you know, as soon as that happens, you know, from day one, it's kind of like I don't want to impose rules on anyone else, but like personally,
no,
I would not condone
exactly right. That's my personal choice, right? And that's how I like. If I was dictator of the world, right, that's how the world would be. Right? So probably a good thing that I'm not dictator, right? But that's my choice. Now I'm not going to impose my opinion on anyone else, but don't criticize me for my opinion, because it is my opinion, and I am entitled to hold that dear to me and to my beliefs and my morals. And that can't.
Agree with it absolutely.
Yeah.
The thing with the morning after pill though is I think that sometimes like the sperm hasn't reached the egg in the morning after, you know, like, you know, first 8 or 16 hours after or whatever. Sometimes it, you know, takes a while to. I'm not sure. I haven't kind of like read about this in a long time, but if that's the case, if it hasn't actually reached, then I'd be like, that's kind of my criteria. That's where I draw the line. If it's fertilized the egg, then, you know, it's a no-go. But if it has before that, it hasn't before that, then sure. But you can't possibly know, really, right? So
exactly right. Like, how do you know?
Yeah, exactly. You don't know, so it's a good rule to say that, you know, it's the night after, like after that night, you know, it's too late.
Yeah, exactly right. Exactly right. It's just, you know, put a basketball between your legs and don't have sex would be the easiest solution, in my opinion, right? But like I said, you know, they are some pretty extreme views.
It's only extreme in this current society, you know. Like historically, I'm sure you'd have societies where that was the absolute standard, and you know, they didn't have the morning after pill and all
not
this
at
nonsense,
all.
you know.
Not at all. And look, you know, my wife is a bit more lenient when it comes to the morning after pill, but I said to her, babe, like seriously, like, what difference does it make if it's done by a pill or any other means? Like, it's still an abortion at the end of the day. Like, you can't look at it any other way. You are still taking a life. You are still taking a life.
The only difference, I would say, like one kind of technicality would be if she's on the pill normally, and then she like forgets a day or something like that, and then it takes the morning after pill after that, because when you're on the pill normally, it's setting your well, not yours but hers, you know, it's setting up the environment such that it'll never, like, there's no chance of fertilization, right? So that, like, some of those hormones might still be in her system such that even if she skips a day, you know, it might not fertilize or whatever. And then and morning after pill is really just the birth control pill, but a double dose. It, like, if you want to save money, you don't even have to get Plan B or whatever. You just take 2 pills of the OCP and you're fine, you know.
Yeah. But at the end of the day, the safest solution is to keep your dick in your pants and keep your legs closed. Like, that's the safest solution. Like, you just don't participate. And I think a lot of these options that are available to people actually make for a fairly promiscuous society as well.
That's true.
Which, you know, that's a different argument, but, you know, I don't necessarily think that is a good thing at all.
Yo, did you hear about the men's morning after pill?
What? No.
Not morning after pill. Men's contraception. It's like this pill that they take, like oral contraceptive pills, but for men.
Mm-mm.
Yeah, they have them now.
No. Okay, there you go.
Basically kills your sperm, you know, right from the source. I would not.
Well,
I personally would never put that in my body, but some guys do.
See, and this is the thing. Like, you put any man-made drug into you, there is always an adverse effect to it. There is always side effects to whatever drug that you put in your body.
Yep.
Regardless of what people say, oh, I've never had any side effects from the pill or this or that or the other.
There's even side effects from like natural herbs.
Yes,
so
exactly.
It's crazy.
Exactly right.
You drink too much caffeine, and you end up going to the washroom, and because it's a diuretic, right? So you're going to be using the washroom more. And that's the side effect of having this caffeine that you chose to like take just to be more kind of like stimulated, what have you. But and that's just coffee. That's like the most subtle kind of herb there is, or tea.
Yeah.
Anything has kind of like adverse effects.
So see, I got no problems with contraception being used in a relationship marriage. All right, you've got 3 or 4 kids, whatever the case may be, can't afford to have any more. Okay, then we use some contraception to prevent that happen. But maybe you should have to provide your marriage certificate when you go down to the chemist to be able to get that contraception in the first place. See, I'd be a hardcore dictator for Sen. Like, I'd have these ideas and I'd implement them. Bang, 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 bang. Get society back on track. We're going into the gutter here. Bang, get some morals about you. You reckon we'll work out the speed of light tonight, %?
Oh, not a chance.
Oh my lord.
But maybe tomorrow. I have hope for tomorrow.
Tomorrow? There we go. There's always hope for tomorrow. Jeez. I don't get the conversation when in regards to all the different fallacies and techniques and whatnot. It's like it's a very formal thing. Instead of just chewing the fat, just spitball some ideas, right? Show me where it isn't, a fallacy, pseudoscience. Show me the scientific method. Show me how we derive these sorts of things. But
I agree with you. I think I'm guilty of it a little bit myself, but I do agree with you. Like, it's absolutely more beneficial for the conversation to say how the person's wrong and just keep it real. But at the same time, the names of the fallacies, they have weight. I feel like, I guess it's more of like, wanting to be right than wanting to elucidate your point. But when you say it to someone and they have to question, like, how is it this fallacy? If you said that, like, the specific fallacy, and then you kind of like use that as a foothold to explain how they're wrong and stuff. And I guess it's a tactic more than anything.
Yes, exactly right. And I can't remember the thing that was it Elijah or Gregory, some Latin thing that they kept on throwing out there.
Ad absurdum.
Oh man, I had no idea. And thank goodness SE spoke up and said, "What the hell? Come on, can we start speaking English?" And it's just like, what? I don't even know. Like, you moderators need to be listening for this. Listening for what? You've said something I don't even understand what you're saying in the first place. I'm a very simple man.
A lot of times they don't even understand. Like, I noticed that sometimes it's said so the person, like, because the person wants to sound smart, and they misuse it, and it's not even the right fallacy and stuff like that. And then it gets into an argument about it being not being that fallacy, but this fallacy, and what does this fallacy mean? And sometimes actually, it's just from them trying to sound smart, and then they get corrected or what have you. It backfires.
You actually jumped in there and said, well, in actual fact, no, you're wrong. Yeah, it's not that at all. That was actually used correctly. I can't remember what the example was, but I did actually remember you jumping in and actually saying that exact same thing. But it is frustrating. It is frustrating, kind of. For a listener, just to listen to it, because you just want to sit back and because you know, you're not always partaking in the conversation, right? So you just want to sit back and just listen to it. But how do you listen to it, percent? Like, how do you listen to that sort of stuff?
I'm kind of used. I mean, I don't know. I'm kind of used to debates and stuff. So it's not new to me. But
yeah.
And like I took philosophy and stuff. So, but that being said,
you are.
I do understand how it's funny actually because you're going off on a tangent, like it's a red herring in and of itself, right? About fallacies and red herrings and stuff like that. So it's kind of it's ironic, really.
Hey, do you want to talking about because you enjoy debating, don't you? You actually enjoy it, don't you?
Yeah, not so much anymore. Well, I mean, I do enjoy it, but like I try not to do it that much because it's not really productive, really.
Fair enough. Well, I've been asked to look for an opponent for Babs. Do you want to have a one-on-one with him?
Who's Babs again? Probably not, but who's Babs? Remind me.
Moon gazing, Chris Matt. He used to be on Gems quite a bit. He used to be a flat earther. He's turned globe.
And I mean, probably not again, but I'm just curious. What's the topic?
Any topic you want.
Oh,
he's happy with any topic. Yeah, he wants to put flat earthers in their place and expose them for what they are. Yeah, apparently, yeah. He wanted a one-on-one debate with me. Called me out, DM'd me. Actually, called me out specifically, and I said I refuse to have a debate with you, but I'll have a conversation. But I refuse to debate him.
Yeah, just tell him to come around here and have a conversation. It's live stream. He could clip it if he thinks like that. If he's kind of impressed with himself, he clip it and use it however he wants.
Yeah, I said to him, I said, if you come here when I'm here, I said I'll have your back. I'll make sure you're not gangbanged, all right? And you'll get your fair say on the mic. But yeah, no, he doesn't want to do it like that in the room. He wants to have it more formal where there can be just say yourself and him in the room, but then everyone else is muted.
Yeah.
So.
Is he trying to like build up his? Because I don't. Does he have a YouTube page or something like that? YouTube channel he's trying to.
I don't know, to be honest with you. I've actually got no idea. I couldn't tell you.
I
know very little.
Like, if it's just for the joy of debating, it doesn't need to be so formal. If it's just for the joy of kind of, arguing something or something like that, then it shouldn't really matter where you're doing it. But if it matters to him, I feel like maybe he wants to, promote it somehow. Anyway, I wish him luck.
It's no, it's definitely with a purpose. Like I said, it's definitely with a purpose, and he would like an opponent, but finding it difficult, I must say, to find him an opponent. The only one that has stepped up to the plate is JJ, but I'm kind of feeling that'll be a rather one-sided debate if JJ steps up to the plate.
Shout out JJ in the chat.
Exactly.
Well, JJ will tear him apart in text
he will.
Debating.
Exactly.
Just use one of those programs that reads out the speech, like the text to speech or whatever. And then put a female voice just for shits and giggles, and it'd be absolutely just demolishing it.
It'd be gold. That'd be gold, actually.
Use that annoying TikTok voice. You know which one I'm talking about?
Sorry, mate. Say it again?
I said you could use the annoying female TikTok voice, the one like that female kind of robot voice that just narrates. Oh, it's so annoying.
Yes, yeah, yeah, I know the one. Oh, and it's not necessarily either Arnold for the moderator to do a job at all. A moderator should actually be able to just to sit back and listen to the debate if the rules are agreed to prior. That's what they should be able to do. In my opinion. But what would I know?
Been asking myself the same question, Bandy.
What do I know?
Yeah, what do I know?
Yeah, there we How you going, Blue? Good, mate?
Yeah. Looks safe. I don't see Rocky or Travis in here, so I guess I can hang around for a few minutes.
Hang around?
Yeah.
Chew the fat? Well, we had been talking about something, Blue, so we'll get your opinion, because you are a very learned and wise fellow. What do you think about the Roe v. Wade decision that's just been handed down?
I think it's a mistake.
Mistake? Okay.
Mm-hmm.
Interesting.
But that's my opinion.
Yeah. Why do you think it's a mistake? Can you kind of elaborate a little bit, or?
I'd honestly rather not, Bandy.
Fair enough.
It's an inflammatory sort of topic. Everybody's got their own feelings about it. I'll go that far.
Definitely. Yeah. No, I don't want to. I don't want to create any. I don't want to create an uncomfortable situation.
I'll neither defend nor attack anybody's beliefs when it comes to that.
Yeah, fair enough. Yeah.
I don't know.
Well, that's anticlimactic.
It was a little bit.
Well, I think I don't know. Maybe we need to start building Model T Fords again and get out the buggy whips.
Hey, they were a slick looking machine, the old Model T. They was sexy.
We're gonna roll the clock back. Let's roll it way back.
Yeah. Hey.
Yeah, they don't build them like that anymore.
Thank God.
Not at all. My very first car was an FJ Holden. That's what I had, right? And anyway, that thing used to handle like a boat on wheels. It was the worst car I've ever had in my whole entire life. Like, it looked good, like it was a sexy looking car, but you would go round a corner, this thing would roll from one side to another. You'd be fighting it all the time. It was absolutely, it was terrible. It was terrible to drive. Like, you'd have to put your brakes on 3 suburbs prior if you wanted to stop. Like, it was terrible, absolutely terrible.
Was a chick making it though?
It was. She was candy apple red. She had mag wheels. Like, it looked the part. It definitely looked the part. The Sen, but yeah, as far as performance or anything like that, no way. Thank goodness I have a car that has all-wheel drive, ABS, airbags, all the mod cons, Bluetooth, this and that and the other, climate control, heated seats, you name it, she's got it. So yeah, thank goodness we have moved on a little bit.
I don't like heated seats. It's just too much for me.
Really?
Yeah.
No, man, I tell you what, when you wake up on a crisp morning and you realise that you need milk, and your car has been outside all day, and you get in there and it's freezing, and you start the engine. Oh my God, that tingle that you get in your ass as it's being heated. Oh, there's nothing better.
It's a little too much for me. I don't think I can handle all that sensation.
Yeah, no, it's definitely.
It feels
it's
wrong.
definitely-
It feels like I'm spoiling myself.
Really? Oh, you got to spoil yourself. You said you got to spoil yourself.
You know what they say, Bansal? They say cold builds character.
Oh, well, that's why I've got so much character, living in a cold ass state that I grew up in. Yeah. But nowhere near as
No,
cold
to be
as
honest,
what
I've never
what
used
you
the
guys.
seat like warmers, when it's like really cold. I've tried it out a couple times on like regular days, room temperature and stuff, and it just like it was too much. Especially considering
Well,
you can't
yeah.
really like gauge or like set the temperature of it. It's
Yeah.
just like a button that you press on, and it was just too much.
Yeah. It's just on or off. There's no in between with them whatsoever. So there's not much point having your seat warmer on and then having to turn on the air conditioning. It kind of defeats the purpose, really.
Or like you turn it on and then you turn it off like 2 minutes later, and then turn it on again.
Yeah. But definitely in the middle of winter. Oh yeah, they're the bomb. And now, I got last Christmas from my kids because I love my coffee, right? And anywhere I go driving, I've got one of those coffee cups. It's a big one of those thermal coffee cups to go. But it takes me ages to drink it, and by the time I get to it, to the bottom of it, it's kind of lukewarm type of thing. So my kids they bought me an electric coffee warmer for in the car. So it doesn't get any better than that percent. Like, come on, every time you take a sip, it's beautiful, absolutely beautiful.
Yeah, it's a nice gift.
It was actually. It was.
How long does it take to heat up, though?
It from dead cold, it takes about 15 odd minutes to heat it up, but I just use it as a keeping it warm. So I make my hot coffee in it, so it just keeps it at a consistent temperature. Yeah, but when it because I tested it with a it was iced coffee that I put in it. So I was filling up at the service station. I bought myself an iced coffee, and I thought, I'll just see how long it takes to heat this puppy up. So I don't want iced coffee.
Tastes like hot.
Yeah, exactly. So anyway, I whacked it in there, and by the time I got home, it still wasn't hot enough to drink. It was hot enough to drink because it was lukewarm, but it was still just lukewarm. But iced coffee, hot. Yeah, I wouldn't recommend it myself. I definitely wouldn't recommend it.
You probably recommend it more than lukewarm. I don't think there's anything worse than lukewarm coffee.
No.
Like, you'd rather have it at room temperature than lukewarm. Lukewarm is just, it feels wrong.
It's yuck. Yeah, it is. Yuck, yeah. It's ganky. Absolutely ganky. If that's a word. If that's a word.
Yeah. I guess it is now.
You drink coffee, Blue?
Yeah.
Would you guys say you're
real
addicted?
men?
Like, can you go without a day without, and you're just absolutely not bothered, or are you kind of irritated when you don't have your coffee?
Oh, I can go without it, but I don't.
Yeah, I don't either. Blue. I don't go with that. I don't know. I would have in a
There's a lot.
day, and I drink double strength coffee, mind you, too. In a day, double strength, I reckon I would have minimum 6 coffees a day. 6.
That's a lot.
That's a fucking lot.
No, it's not. Come on. I need water, right?
Yeah,
So I have to intake water.
Sugar
yeah,
or no sugar?
But your body doesn't process it as water; it processes it as a food. You might think it's hydrating you, anyway. But the Americans, their coffee is like fucking hell of a lot stronger than ours for some reason. You can have 1 cup of coffee, and your heart will be racing.
Okay. Well, I don't know. I make my coffee pretty damn strong, I must say. In the coffee machine, perks up.
That's not bad sound effects.
Yeah. And I've got the little milk frother that goes next to it.
Yeah.
Yep, most definitely.
You drink it
And I
black,
can
or,
even do like
just with milk and that's it, or do you add sugar?
oh no, milk, and anyway, it's really cool because my wife will bring me a cup of coffee over to the house, and she froths it all up, and she puts the fancy little patterns on it. She'll put like a love heart or like a little leaf or whatever. Like she goes the
What a
whole
keeper.
9 yards. I know, I know, percent. Like I know. We were talking about that earlier. It's just like wow.
But yeah, any sugar or no?
Yeah, sugar. Yep.
I wonder what the actual strength is, because I work in retail, so we deal with coffee every day and stuff like that. But a lot of these companies, I find, are buying the seconds and the thirds. You know, the shit tobacco, like we call it Benson Hedges Sovereign, but it's like it's the second, third, fourth grade of tobacco, and the same thing with the beans. So I wonder if, you can drink 6 cups of coffee because the caffeine content is quite low in that coffee that you're drinking, possibly.
Okay then. Well, we have. I don't know if you've got Aldi over there, Realm or percent, but
yeah,
Aldi puts out their own coffee machine, which we bought one of those with the little milk frother and all that sort of stuff, and you use the little pods, like the Nescafe pods, so the little Aldi pods, and they used to
dark
have
roast or light
strength.
roast?
Oh, dark, 100% dark, but it's
dark
strength.
roast is less caffeine than light roast, right?
Yeah, but
I think. Sorry.
The darker
I
the
don't
roast, less caffeine.
Really?
Yeah.
So I have to go to mild roast now to get that kick.
Because the idea is that
You know what?
the darker the roast, like the more they basically cooked it or like roasted it, and as a result they burned some of the caffeine away. So the lighter, the more raw it is, basically, the more caffeine there is.
Interesting.
Yeah, it's counterintuitive. I thought dark,
know.
the darker it is, you'd think, that's coffee. It's more coffee-ish. It's more caffeine, but it's not.
But think about popcorn, right? If you've got a whole batch of beans, for example, and you roast them, but some of them over roast and some of them under roast, you can't therefore roast it again, those little bits and pieces, roast them again to equal, because you've already roasted them once at the same temperature. So those offcuts and stuff like that end up going possibly in cheaper bags. But we have got Aldi, and if you're drinking Nescafe, yeah, that's pretty decent. And strength or whatever, but I wonder what the actual caffeine content is of these things. But like I said, I had filtered coffee. I had a big filtered coffee in America when I was there about 10 years ago. And just 1 cup of filtered coffee, fucking my heart was racing, and it was like coming through my throat.
Mm-hmm. Who here
You might be
drinks...
a little hypersensitive, Realm.
I drink strong. I drink like like one teaspoon, 1.5 teaspoon, like instant freeze dried coffee. Make it into a proper decent coffee, less water, etc., etc., etc. Intensify the flavour. Yeah, I'll probably. I mean, it depends on the weather, really. At times I can drink more, but can drink less. But you definitely know when you're drinking because of the additives or whatever. If there's a caffeine, yeah, possibly, yeah.
1.5 teaspoons of if we have Moccona as a backup, like Mocona's our like emergency backup coffee that we have here, and if I ever have to use that, it's 2.5 teaspoons minimum.
Yeah, the Kenko does it is not as dark as the Kenko I drink is like the red. I think it's called a rich roast or something. And then but the Nescafe seems to have a more burn to the taste, slightly darker. Yeah, I mean, to be honest, a nice heaped one is good, depending on the volume of the cup. But I'll take a mug, but I'll get a nice sort of pinky's worth of milk, but I'll put a pinky's worth of water from the top, and therefore I get more of a retail latte taste, if you know what I mean.
Okay.
I can't froth that. I can't froth that shit with a kettle.
One of the
bandsaw. I can imagine you sitting in your Model T Ford, sitting on a corner, sipping on your Moccona as you listen onto Discord.
Beat it out, my friend. Like I have coffee before I go to bed. Like I said, it's literally like drinking water.
Yeah. You build up tolerance, right? Plus, if you're having it, if you're tired and then you just have it like right before bed, then it's not really going to do anything. It takes like a while to work. I think that's if you don't have it already in your system, but if you already are flooded with it, then your body's just adapted to it.
But I reckon if I was to go 2 or 3 days without coffee, I reckon my body would actually go through some pretty heavy withdrawals. Actually,
it'd be interesting.
Yeah, well,
maybe you need to detox.
I ain't gonna try it. I'll give you the hot tip. Not try it. I don't care for what scientific purpose it is. Like my kids often joke that I should just get an IV and just put it directly into my veins. I drink much coffee.
Yeah, I stopped drinking it on account of the sugar, because for me it's just so bitter, and I have a bit of a sweet tooth. I don't like it, so I have to put so much sugar when I have it. Like literally, I'll have like 5 teaspoons of sugar in a regular mug, maybe even more.
Damn.
Yeah.
Really?
I swear, man.
Damn.
Like in Canada, they say double, 2 milks, 2 sugars. For me, it's like I'll have a quintuple. I'm not even kidding. I literally go and I'll ask for like 5 sugars, 5 milks, or that's what it is. But because of that, like I want to cut down my sugar, so I stopped drinking coffee because I didn't like it black. It's not flavorful for me.
Yeah, and, I don't.
Now I'm starting to incorporate other things instead of sugar, like honey and some like syrups and stuff like that. So I might give it a try, but at this point I don't drink it at all.
I have probably 1 cup of tea a day, and that gets varied between like a normal, say, Earl Grey type of tea, and I'll put honey or maple syrup in it as the sweetener. And if I don't have that as the tea I drink, my wife drinks nothing but those herbal teas, like raspberry and apple, or this and that, and all those fancy kind of ones. And
those are delicious.
They are, but you don't need sugar with them. They are so sweet, just on there. Don't tell me you put sugar in those.
I would definitely still add sugar. I'm not even kidding.
No way. That's hardcore. That's hardcore.
Even tea, I don't like it without something to sweeten it. Even types, like fenugreek and chamomile and all this other stuff, I would need sugar still.
Oh no, the chamomile and fennel and stuff like that. I can understand you wanting the sugar in that, but I'm talking about like the raspberry and apple and whatnot, where they're quite sweet anyway.
Yeah, little chunks of like dried mango and apricot and
yeah.
Even so, I'd still probably add a little bit.
You're insane.
So, do you drink any water?
Me?
Yeah.
In my coffee?
No, I mean just water.
Yeah, I have. Well, at night I drink water. Like I've got a big bottle of water that's next to the bed, so I drink the water during the night. Because I'll wake up. Because I'm a very light sleeper, very very light. So I'll wake up two or three times a night. So the water bottle that I have next to the bed is a liter. So I'll have a liter of water throughout
You'll go
the
through
night.
it every night.
Yeah, easy.
I can only sleep, man. That having a cup of coffee before you go to sleep is dehydrating you. Drinking coffee in general will dehydrate you. And, I mean, things like that, you could be a heavy sleeper and then just drink water before you go to bed. 7 gulps from the tap, in the hand. That should do you throughout the night, depending on your body size, of course. And then you'll wake up refreshed and
Hold up, Realm. The coffee, like the caffeine, dehydrates you because it's diuretic. It makes you use the washroom. It makes you go take a piss. But if he's sleeping through it, then it's not really dehydrating him.
Yeah, but
Are you waking up in the middle of the night, Bandy, and needing to go to the washroom?
No.
So, yeah, then.
Not at all. I just wake up. I'll hear something outside. The cat will bloody knock over a pot plant or something like that. I wake. Like my wife will roll over and punch me in the face or whatever. I wake up.
You're going to lose certain amounts of moisture at night anyway. You're probably and you're drinking a litre of water while over the night or whatever. You're probably going to lose a litre of water just over at night time anyway, possibly.
Well, my morning piss takes me about 7.5 minutes. It's just like, when is this going to stop? Oh, that's right. I drank a litre of water last night. All right, here we go.
Do you ever ask yourself, when is it going to start?
No, I don't have that problem yet. Not yet.
You're getting up there, so I wasn't sure.
Yeah, I'm getting up there. Good Lord.
You'd be surprised, man. There's guys my age that they're standing in front of the urinal for a minute waiting for it to start. I'm like, are you serious?
Really? No way.
I'm not even kidding, man.
Like, what are you? You in your 30s%?
Close to
late 20s. Yeah. Damn, that's embarrassing. Can't take a piss where you want.
Yeah, it's weird. What about you? Oh no, he left. I was gonna make fun of Rel a little bit. What about you, Blue?
Huh? What?
Does it ever take a while for you to start the stream?
Nope.
Good
no. Everything's working. A-okay.
It comes out as quick as that answer. Nope.
Nope. Bang. Job done.
Not a problem.
Yeah, my heart goes out to people that do have that problem. It's, I can't imagine every single time, having to wait and kind of the stress that I just imagine in those 20 however long it takes, and you're just kind of like Jedi mind tricking your dick to start going. It's like, come on. It's probably the same feeling that people have when they have erectile dysfunction or something like that. I imagine it's stressful.
You gotta lean over to the basin and run the water, so you got the running water in the background to get you.
Have a cup with some warm water and stick your hand into it.
Yes.
That's tough.
Yeah, the only time it's a problem for me is when I go to the doctor's office once a year and they tell me they need a urine sample. for some reason.
like you just went
invariably.
before you left the house.
Yeah, yeah.
Yeah, that's the worst, isn't it? Could have
Like,
given me the heads up.
wish I could, but I don't. I seem to be out right now.
Disturbs me are the guys that grunt and moan while they're peeing.
Sometimes it feels good, man. I'm not gonna lie. You can't do that in public though.
They do it in public. I'm like, if they're passing like kidney stone
Are they
or
drunk?
something.
Oh, what? Damn.
You go to the club, you know, there's always drunk people. It's making weird sounds.
Yeah, this is different. This is like pain. This isn't relief.
Oh yeah. I can't imagine what it feels like to pass a kidney stone. I mean, I can imagine. That's all I can do.
Yes, I don't want to find out, to be quite honest with you.
Mm-hmm.
I'm perfectly frank. I must say though, I've been pretty lucky. I must say, like, I haven't really looked after my body too well over my lifetime. And,
Well, you say that, but you are very active. You fishing and doing work around the house and stuff like that, and all that counts as working out your body. So
Look, I suppose it does, but and look, we do eat healthy. It's all, we've got a very healthy diet, but yeah, I'm not an active exerciser or anything like that. No way could I run around the block. My life depended on it.
Depends on what's chasing you.
Well, this is probably true too. This is probably true. I ran from my wife the other day. She was trying to squirt me with the hose. Haven't moved that quickly in a while, I must say. Man, she's always getting me, Blue, because I'm a smart ass to her. Like she gets payback to me when I least expect it. All right.
Oh yeah.
When I least expect it.
Yeah. Yeah, mine's got a memory like a fucking elephant. She's still getting back at me for shit I did 35 years ago.
Oh man,
that's terrible.
I tell her she's evil. I said, you were dead set evil. I thought you were this loving, nurturing, forgiving, soul that I fell in love with, but
she's really a she-devil in disguise.
She-devil in disguise is right, mate.
But yeah, Blue, there's got to be like a statute of limitations on that or something. 35 years?
No, there is no statute of limitations.
No.
Hey, Bandy, you keeping away from holes? They still scare you?
I actually, funny you should mention that, Terry, because I was fishing this morning, and where I fish is like I think I've shown you photos and whatnot. It's like a little private little beach, but there's quite a big cliff and stuff that look, they do have a walking path to get down to it. But where you park your car and whatnot, there's a quicker way to go down, but you gotta kind of, it's a bit more treacherous. So here I am with my my rod and my bits and bobs and whatnot, and bloody well walking through it, and yeah, I rolled my ankle actually. I stepped in I don't know, it was an old kind of rabbit hole or whatever. My foot went straight into it and twisted my ankle. I thought, oh. And it is giving me grief, I must say, a lot of grief. So if it doesn't get much better, I'll probably have to go to the doctor and get it checked out to see if I've done any damage.
Yeah, the older we get, the more danger we're in. Being physical in any form like that.
Wow. And it takes longer to repair too,
Mm.
Terry. Really.
And every winter I feel it.
Oh, look, my ankles and you know the lower half of my legs, like the last few years, you know, I've had a lot of grief with them, I must say. I've tried all different things, but now I have a TENS machine. You know what a TENS machine is, Terry? No, it's like this little machine that puts little electric pulses throughout your limbs. So I invested in one of those, and that seems to help a lot. My ankles and whatnot are giving me grief. Much better than popping pills, I must say. Hey, Blue, is that the is that the flat soid that's on Nathan Oakley? Is that flat soid?
I'm not sure. I was just watching some of this stuff. I may have found a new target.
Who? Not me. Not me.
No, not you.
There's only one flatzoid, so there's not. So yeah, that's him.
Oh, I didn't know because it's got flatzoids. Oh, flatzoids perspective. I thought it was like the new perspective.
I think he just he's been changing up his YouTube channel a little bit of a refresh, I think. But yeah, so I think the name is a little different and a couple things like that, some new thumbnails and things.
Yep. How you going, Joe? Good, mate.
Yeah, I'm doing all right. How about yourself?
Yeah, good. Having a what is it? Saturday night or Sunday morning for you?
It's still Saturday night for me here.
Saturday night, party night. Oh, well, it'll be interesting later on then if it's Saturday night. Damn.
Somebody say new perspective. No.
Hey, Dave.
Hello there.
Hello.
Hello. So, quite a day for the ball, I'd say, huh? I can't believe they're still saying that. They're still saying that Bob proved the Earth spin with the gyroscope. I can't believe that's still something they think.
It is crazy.
They were waiting all that time to just find a flat earther to prove their spin.
Yeah.
Apparently. That's all what they needed. They needed their messiah.
It's so sad.
Now
it's like it's not only
they're thanking him so profusely.
Right. It's a flat earther that didn't actually say that, was taken out of context, and then totally, denounced any idea that he might have meant what it seemed that he said in that thing, and has gone to great lengths to show that's not what's going on. And still, they hang on that as if it's like their most glorious point of proof ever. And that's all they got. Pretty sad. But typical. It's so typical. It's a total straw man. But it's
Earlier on,
like the claim that they the straw man that they keep going with as if it were a real claim by himself, by Bob himself. Crazy. Go ahead, Ben.
It's crazy some of the claims that they make, Dave. Like, earlier on, it was just a simple question that was posed. Can I jump on a boat or a plane, land in Antarctica, and freely go wherever I want, unrestricted?
Yeah, I
Freely
heard some
do
of
it.
that.
Yeah,
Right.
and
No, you can't.
They fought tooth and nail. They reckon, yep, there's nothing in the Antarctic Treaty that says that you can't do
Right?
it. Absolute. They fought tooth and nail, and I actually could not believe how dishonest they were being with that opinion. I really couldn't believe it. I thought, yeah,
Yeah,
pretty
it's those
much.
kind of things that you might think, oh, well, they'll be at least real enough to admit the actuality of it, regardless of what they're hiding. You can't go there freely. We all know that. Supposedly, that's the case. I mean, I haven't verified it for myself. But.
No, and let's be frank. It's quite a harsh environment over there, Dave. By the looks of things.
Yeah.
And if you just think about it logically, right? You go over there on a tourist expedition, right? And you wake up in the morning, right? And you think, you know what? I just want to go wherever I can. Well, it is quite reasonable then, and quite easy to conclude that, you may have to fill out some paperwork as to where you're going to go, what time, what are the weather conditions, what provisions do you have in case something happens, right? And to get all that approved, right, is not really an illogical thing to think, because they have to know where you're going to go, because if the worst happens, well, now they have to mount a rescue mission. So they have to make sure that there's going to be resources on hand. So just that logic alone, without any conspiracy surrounding it whatsoever, makes logical sense, right? And yet they even fought that. They said, no, it's absolute rubbish. They actually even fought that. I couldn't believe
They
it.
usually use that as an excuse. Like, they don't want you to die, so they would have to it would cost money to send out people to look for you. Like they're really not worried about you dying somewhere in the middle of the cold, right? They're trying to find the edge of the flat earth.
Yeah, I know. Yeah.
I think you go north or even east or west, and we might find more land.
So what are you saying?
Maybe Antarctica's not surrounding us.
What are you saying about it, Bandy? You.
What am I saying?
Can you go there unrestricted?
I don't think you can go anywhere. Where can you go that's unrestricted?
Exactly. To begin with, right? You're right about that. Where
can I go that is totally unrestricted? Can I go wander in the Oval Office this afternoon if I want to?
No. That's that, and of course there are places where you can't go, like here in Australia, Blue. Like, you can't go to Pine Gap, for argument's sake. You can't go into any government institution willy or nilly type of thing. You can't go into someone's home uninvited. There are logical things. There are some national parks that you aren't allowed to go into. Like that is, got no problems with that whatsoever. But you can get a plane over here, Blue. You can land in Melbourne, Sydney, Adelaide, Brisbane, Darwin, Perth, wherever, right? You can get off that plane, right? On your visa, you've got, the only thing you have to put on there is tourist, right? You go through customs, you walk out the door, you can go straight to the rental car company, jump in that car and go pretty much wherever you want with no questions asked, without having to fill out any paperwork whatsoever. You can just tour around, go here, there, everywhere, willy-nilly. Right? That's what I mean by willy-nilly. Now, Paul, Gravity Guru, you know Gravity Guru. I think it's cursed with a high IQ. Like he was over in this channel about 3 or 4 weeks ago at least, and he's actually lived in Antarctica. All right.
Yeah.
And what he explained how you travel around, that you have to fill out paperwork, your provisions, where you're going to be, and all that sort of stuff, and basically get it approved. Because, like I said, I'm not trying to read any conspiracy into it whatsoever. I'm just saying this is the basic format that you have to go through to travel outside the base itself, where you are, right? So, you know, that is what it is. Now, you can read into that now whatever you want from there, but they're the basic facts of the matter. Okay.
Yeah.
And I think, which is what I said, Blue. Like Antarctica being the harsh environment that it is, I think it is fair and reasonable to let people know where you are going to go, right? The coordinates, the weather conditions, what provisions you have, because if something goes awry, right? If they have to mount a rescue expedition to come and get you, well, they need to know if the weather conditions are that bad. Are they able to delay that rescue for 12 hours or 24 hours, knowing that you may have enough supplies to survive, so they don't have to then put their lives at risk? Because if someone has to come and rescue you, you are now putting other people's lives at risk. So I think it is a fair and reasonable thing to have to do in such an environment. Like I'm not disagreeing with it whatsoever. Now, people can extrapolate into that whatever they want to read into it, but I just think that is a very logical thing, train of thought to have myself in regards to the area.
No, I think it is
Yes,
too.
sir.
It's one of the
Yeah.
most hostile, if not the most hostile environment on the planet. So,
Yeah.
and you're right. If the worst happens and you get injured or trapped or whatever, it'd be pretty handy to know where the search party ought to go to try to find you.
Exactly. Like it's common practice here in Australia. We have many bushwalkers and people that go four-wheel driving and things like that. And it is common practice to leave a log of where you're going. Like if you're one of these bushwalkers that likes to go for, 3-day, 7-day bushwalk type of thing into the middle of nowhere, you let people know where you're going to be and what your ETA is going to be. So then, if you don't get back and people know about it, they know. Well, then okay, then something might be up. All right, and then generally they wait 24 hours after that time, and if you still ain't back, then they'll mount a rescue operation or search and rescue operation to come and try and find you and rescue. Right, so these sort of things are quite sensible when you're going into terrain that is harsh and rugged and hostile.
Yeah, well, I mean, I've spent an awful lot of my time in my life flying over these mountains down here, searching for an aircraft that went missing.
Yep.
Trying to figure out where the hell the guy might have gone, because if he wasn't flying on a flight plan, and a lot of times they don't, they're not required to. We don't know where the hell to look.
Yeah.
I mean, we have no idea. The FAA will go back through the radar tapes and try to find, analyze all the VFR flights and try to figure out, which one might have been the guy. And usually that doesn't have a good ending.
No. And what was disappointing about the whole premise, Blue, is like, I thought it was quite a reasonable statement to make. Like, you can't go down to Antarctica and just roam willy-nilly without having steps in place. Like, your movements have to be approved.
but because it came from this side of the fence, well, straight away, you're thinking about it. You don't know what you're talking about. It. You got, show me the citation, this, that, and the third sort of thing. It was only just because it came from this side of the fence, and you yourself, think that just with that statement alone, not thinking about any of the conspiracy sort of stuff, it is a fair and reasonable thing to actually think and expect, probably.
I think it would be, and I, personally, I would wonder about your sanity if you tell me that you're going to go wandering off into a wilderness like that, into an environment that is that dangerous, and you've got a problem telling us where you think you're headed, just in case the worst happens.
Yeah.
I mean, me for one, I want somebody to know where the hell I'm going.
Not a chance would you get me down there, Blue. Too bloody cold. I can tell you that right.
Oh,
It's too
yeah,
bloody cold.
I agree. I have no real need. I can see video of it. I don't really need to go down there.
Yeah. I can go down to the local zoo and see penguins. I'm happy with that. Take my grandkids down. We'll see the penguins. Happy days.
Yeah. I used to talk to those guys down here on the amateur radio back in the.
Has anyone seen the 1958 encyclopedia that mentions a dome? I just put the link in the live stream. 1958 encyclopedia mentions a dome 13,000 feet high.
13,000 feet. What's that a mile? 13,000 feet.
That's 2.5 miles.
Yeah.
Is that all? It's all.
Yeah, that's way too low.
Yeah.
That doesn't seem high enough to me.
It's like about 5,000 something miles, 58, 60 or something like that. Miles per or feet per mile.
5,280.
There we go. Boom. Spot on the money. Get into metric, Lou. It'll be so much easier.
Oh, I've been doing both all my life, Danny. I'd rather work in metric, but
it's so simple. Multiples of 10.
Yeah.
It's so much. I don't know. Why have America been so resistant into converting to the metric system? Really?
Oh hell, I don't know.
What's been the pushback there?
It's communism.
I have no idea.
Communism? It's a conspiracy, I tell you. It's a conspiracy. It's an imperial conspiracy.
It was a pain in the ass in school. Most of the engineering classes were conducted in freedom units, and then you go to physics class, and that's all in metric. So you end up becoming bilingual, so to speak.
Yeah.
But metric was always been so much easier to use. I like it.
I think we still had the when I first started going to school, we still had the conversion. They were still kind of teaching both in school, but it's actually funny because pretty much everything I measure metric, but when I'm talking a lot of things like lumber, for argument's sake, it's 6 foot by 4x2, or if I'm talking my height, I'm 6'3", sort of thing. Like you still have that both imperial and metric. Well, I do anyway.
Yeah.
How far is it? If I'm measuring something, it's always it's about 5 foot, about 6 foot, about 6 inches. That gap. I still think like that and still use those measurements. But if I'm actually measuring it with a tape measure, right? I'll measure that 4x2 and it'll be 90x45. by 1800 long. So it's quite strange. Not strange, I suppose. It's
Well, pretty much everything you buy over here is printed, in parentheses underneath the pounds or ounces or whatever, the metric equivalent to it. But people rarely use it.
Yeah.
I think if they change all the damn gas pumps over to liters instead of gallons, would be a good start.
Yeah.
Let people get used to that. I think about filling up the truck. I think in terms of 30 gallons. After a very short period of time, if I was forced to do it, I'd be thinking more in terms of 120 liters or whatever.
120 liters. Yeah.
Yep.
Yeah. Yeah. When it's come to volume and weight, I've always been metric. Like I don't refer to things in pounds or gallons or whatever.
Yeah, we mess that up anyway. Both systems do. Kilograms are not. That's not weight. That's mass. And pounds are force. But they can be mass too.
Well, I don't know.
Funny how we mix stuff up.
I weigh about 97 kilos, Lou.
Right. But that's actually a mass. Your weight really should be stated in newtons, not.
Well,
So you should. Yeah, you actually weigh about 900 newtons.
Oh gosh, that's just too complicated for me. I'm happy just sticking to weight being 97 kilo. I'm happy with that. You can keep your Newtons and your Einsteins all to yourself. We were talking about that, Dave. Now he's dropped out.
What?
It came up in the conversation. There'd been a couple of people that had been tried to sail down there, but had been prevented from going down there. And I saw something years ago on it, but I had no real recollection of
the details or under what circumstances they were either. But Dave's just posted the link for it. He made an unauthorized trip to Antarctica. And he got arrested off the coast of Chile. He and his 4 crew were arrested in waters near the border of Chile, Argentina. They were escorted to a nearby naval base at Porto Williams, and their sailing permit has been revoked. Go. However, the New Zealand Ministry of Foreign Affairs and Trade says that the men are not under arrest as far as it knows. Okay. So it says government. So they weren't arrested, but it seems like they were stopped. But they didn't have the right paperwork. Like, is all the water down there blue, do you know, or whatever, is that considered international water? All the water around there? Because I know, like, around Australia, we have a line in our waters. Right? This is Australian waterways, and if you go into them and do any unlawful activity, you definitely can be stopped and arrested. But in international waters, I think it's a slightly different case. I thought you were able just to sail around international waters because no one particular owned them or had rights to them. Or is it the waters that are around Antarctica fall under the treaty itself?
That's a good question. I mean, I think it's all run through the Antarctic Treaty System, which is sort of a larger umbrella than just the Antarctic Treaty was sort of a. I mean, it's really more of a propaganda piece from the late, 50s, early 60s thing, because the real laws and things in place are the Antarctic Treaty System, which is all run through the United Nations, and there's all kinds of additional restrictions and documentation and rules and restrictions and all that go through the Antarctic Treaty System. So, yeah, it's a good question though. The maritime laws around all that. I mean, I guess since it's all run through the United Nations, and then all those countries claim to all be agreeing, so.
Yeah. Yeah, because I was under the impression that in international waters it was kind of a free-for-all, right? Then when you entered the waters of a particular country, well, then you had to abide by their maritime laws. I know, we have them here in Australia. New Zealand have theirs. But it's really only used in regards to illegal fishing and refugees coming over on illegal boats and stuff like that. Any boats that enter our waters have to have the boats have to be certified and up to date. That is mandatory. So they've got to be seaworthy and have the current certs to prove any of that. Otherwise, you're not allowed to import. They won't let you in.
Yeah, it'd be so cool to know what's in the Antarctic region and in the North Pole. It seems like the only possibility of ever being able to see that would be to get the truth out that the Earth isn't a globe, and then these people in power would have to be in some way disarmed or dissolved from their position so that the rest of humanity could be able to see what actually is in those areas. It'd be awesome to be able to see that in our lifetimes.
Like you can't travel around there willy-nilly on foot. But if you've got the appropriate aircraft that can get from say one side to the other, right? You've got enough fuel and all that sort of stuff. You don't have to land, blah 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 blah. You know, why are you restricted from necessarily flying over there, flying all the way around? Well, we know why. At the end of the day, that was a rhetorical question, Gio. But yeah. There is so much pushback.
Yeah, I mean, in theory, if it was what they say it is, it seems like you should be able to at least fly over it. But I guess they would maybe say, oh, well, if you crash, then we don't have the emergency crew.
Yeah,
but I mean,
same sort of thing.
But I guess it would be at your own risk.
Well, exactly right.
It would be a kamikaze mission, but it also is just kind of a cool idea just to try that stuff, see what happens.
Imagine if you only you got some terrible illness, right? And you knew you only had like 7 days to live. Okay, you got your bucket list of everything that you want to do. So you fulfill your bucket list, but the very last thing you're going to do is just, jump in your own personal Learjet and just go from one side of it to another. Kamikaze or what, like bang. Okay, they're going to shoot me out. I'm dead anyway, so I may as well go out this way in a blaze of glory type of thing.
Yeah.
Blaze of glory.
I mean, I think they would just like that. Did you see that clip from? I guess it's in the new level 2 or whatever the next level. But those guys were in like the southern waters, and there was this huge military ship that was radioing that they had to turn around.
No. I haven't seen that yet. The next level 2 or the new level. Is it on YouTube yet?
It's around, yeah. I don't know whether it's completely available free on YouTube or I'm sure it's on BitChute and all those. Rumble. I think maybe he was trying to charge for this one. Like it wasn't just completely free, but I'm not sure like what the status is on it right now.
Yeah. Jin was going to get me a copy. He said he'll get me a link. But I'm through the next level, isn't it? The next level? No.
Yeah, but I mean, in a sense, it's not really hard for them to keep people out of those areas because they have all the radar and all the monitoring equipment to see who might be going there, and then they have all their rules and restrictions and paperwork that they can enforce. And yeah, I'm sure they would first ask you to turn around, far before you got to anything juicy. They would be telling you to turn around, and then if you kept going, they would either come and arrest you or, I mean, whether it would come to them really shooting you out of the air or something. I mean, I suppose it would if you were in an airplane or something, then you were really just kept breaching. Maybe they would, but yeah, they'd be able to monitor that pretty easily and keep it enforced. Even with drones, when they have all the drone technology, remote controlled drone stuff, they wouldn't even have to send any humans to do any of that.
No, not at all. Put no lives at risk.
Guys.
Yo, what's up?
I'm sitting here watching the alignment, fam, and I'm telling you, the sky is crazy as fuck. The sky is crazy as fuck. I'm here with my Celestron. Say again? I'm here with my Celestron binoculars. You can't hear me?
Yeah, we can hear you, Elijah. Yeah, we got you.
Oh. So yeah, now it's really in alignment. Look, now it's lined up. So anyway, I'm looking at the alignment right now of the celestial bodies, the planets and the moon, and it is a really amazing sight, guys. What was very weird just now is there was something did you point it out? She's like, what did you say?
What is that? I said, am I seeing what I mentally just wanted to always see, which is a shooting star. And I was just like, oh my god, I've always wanted to, because he was talking about that, and I'm like, I've always.
Now,
and then it just started cascading.
Right.
And it was bright as shit.
Right.
It kept cascading downward, and it was not going straight, going downward, and then it's kind of like.
And it just disappeared into that band of air.
Because something.
It might still be there.
Now it's round.
So guys, like, okay. So first of all, just the moon and the planets and all of that are cool as shit. And then there's like a whole bunch of stars that I'm in New York, so I don't get to see the sky like that. Like, you can't really see it, but with these binoculars, like, you can see things that you normally wouldn't see. And anyway, so there was this moving thing. It wasn't a shooting star. Well, okay, people describe, because they say, okay, shooting stars, they go by really fast, right? But then there's sometimes people have said, but I've never seen for myself, that they've seen something just moving, but it looked like a star, but it was moving and it's too slow. It's too slow to be a shooting star. So I'm like, nah, man, that's like some kind of, that's an aircraft or something. But I'm like, that is really high. Like I watch planes all day and all night. I've seen these planes in the sky. I've never seen that. As a matter of fact, the the planes have what you found it.
You gotta put them up.
So the planes are you talking about that gate of stars that that's what I'm calling it.
I don't know what I'm seeing because it's not up there.
What does it look like?
So you're gonna go. I'm gonna have to guide you through. You see?
All right, guys. I don't want to. I guess I'll go on mute, but it's amazing.
Cool, man. Enjoy it.
Oh, fuck no, guys. Okay, so here's so the thing that I told y'all was moving towards. It was moving towards the horizon, right? So for it was high. It was kind of high, a little under the moon. Well, you gotta go outside and watch it if you're on the East Coast and later on the West Coast. Well, you won't see that, but when like say 4:30 in the morning, what is that? What is that about? How high would you say in degrees that is? I'd say about 30, 30, like 35, 40, 35, 30 ish. So that's where the moon is at. And I could have just opened timeanddate.com. And then so it kind of it kept going and going. It was very far. It didn't look like a plane. I mean, anyway, so it disappears into this band of atmosphere. If you've ever been out in the morning, you know what I'm talking about. It looks all purplish and everything before the sun comes in. Here's the thing. It disappeared beyond them. So if it was a plane or something, or well, I can't make the claim of if it was. It's not a plane. Whatever it is, whatever flying craft it is, the light I can see it like it's a star. Like the light is not dimming at all. It's not twinkling. It's not even doing what the planets are doing. It's not doing anything. It just looks like a light. But here's the thing that's freaking me out. And I'm gonna pause because I gotta go back and watching it. It's moving back up towards the moon.
Can you video it, Elisha?
No, I got my let me see what this maybe I can catch it. I probably could have caught it when it was a little darker. Okay, so where's that red light you were talking about? Okay, so there it is, and then I move over. Okay, I'm trying, guys. If I get this shit on video with this crap ass phone, oh my gosh, I would be the GOAT. Okay, so I don't think it's gonna pick it up. I could have sworn too, guys, that I saw it dancing, but then I realized, nah, my arms are just like shaking. Cause I started getting freaked out when it was doing figure eights and shit. And I was like, oh hell no. But I realized, oh no, it's just getting further. So the angle that I'm viewing it in is like, tighter. And so the movement is what was doing that in my flimsy ass arms with these heavy ass binoculars. They're huge. I'm trying to get it on video. I can't. It's not showing up. It's not showing up at all. Let me start from. But look at that. That's worth videoing though. Oh, I gotta get out of here to video. All right, I'll be back.
I haven't really looked in a while what's available for binoculars, but it'd be cool to have binoculars that have video built right into them. I imagine that's a thing.
Probably they might already have them, actually. Or if you can put like one of those holders on one of the eyepieces and stick your phone to it while you're looking at the other one. Hey, Jackpot. How you going, mate?
Oh, sorry, I didn't realize my mic was on this whole time. That's my bad.
You're right.
Can you?
You're right.
I hope I wasn't like echoing through because I know I had my speaker on there.
No, you were fine. You were fine. Nothing at all.
Okay, that's great. How's everybody doing tonight?
Doing pretty well. Pretty well. What about yourself?
Honestly, I'm doing pretty great. I just came in here to honestly like listen to the conversation, see what was going on here. I was going down that Twitter thread that I was going on, and there was a Glober on there that actually wanted to get into some of this conversation and shit. So I'm trying to send him through to a couple of servers and stuff.
Okay. Oh.
Yeah.
Do your bit, mate. Do your bit.
Yeah, for sure. Just trying to bring in more people to the conversation, and hopefully wake some more people up to what we think is going on.
Exactly. That's what it's all about. But yeah, no, thanks for coming over and joining up.
Hey, I have no problem. I'm just here to like listen to some good conversations here, and seems like that's what's going on most of the time.
Yeah, it's a bit early now, but yeah, it'll heat up. It'll heat up. So yeah, stick around.
Yeah, no, though. What's like the big topic of tonight?
Well, one's really to be brought up. You're welcome to bring something up if you want to chew the fat while there's a bit of space to talk. If you want, just kick back and relax. Yeah, if there's something you want to talk about, there's people here that join in and see where it leads, what rabbit hole we go down.
Well, I don't know any like specific rabbit hole to bring down here, but if anybody has like any super interesting like conspiracy type of stuff, or anything related to like I guess the shape of the Earth that they would like to bring up, they should probably do so, because I would definitely like to hear what some of the people in here have to bring up, because I've been doing a lot of research myself these past couple of months, and I definitely want to see like what more people have to bring to the table, from whatever side you're on or whatever you think is going on.
What sort of research in particular have you been doing in regards to the shape of the Earth? Like what in particular caught your eye per se and alerted you to something's going on?
Honestly, the biggest thing to me is just like the fact that I have never seen the curve. I've been up in airplanes many times, I've never seen the curve myself. you know, I've looked out many times at open water. I've seen mountain ranges and stuff, and you can see way further out than you're supposed to. I've seen stuff that I've never supposed to been seeing. And so, you know, just on that very basic level right there, which I feel like is the most that you really need, to be honest, is because, you know, you should get, before you come at me with like any type of wall of math or anything like that, you should be able to just very basically show people, you know, where the fuck is the curve if you're on a globe.
Yeah.
No, I'm happy with that. Let's just eyeball everything and say fuck it. That's good enough.
Hey, well, your eyeballs work pretty damn well, Rig, at the end of the day. Mine do anyway. Don't know about
Only
yours.
sometimes, Bandy.
Yeah,
You know this.
right.
Not all the time.
You're getting a bit long in the tooth, so I can understand why you don't trust your eyes. Yeah. Yeah, no, I definitely.
How can you just lean on that though? That you think you've seen as far, you know, further than you should. Do you know how far you're supposed to see?
Well, I
From
mean, as
whatever
far as
elevation you were at, do you know any of that math?
well, I don't know, man. I've heard many different answers as to how far you should see depending on your elevation. So I don't know. It really depends on what you like think that you're seeing, I guess, at the end of the day. Because, you know, if you think that you're on like a globe Earth or whatever, maybe for even a second, you know, you could trick your brain into seeing some kind of curve. But I've never seen it myself. Even though I thought for like 20 years that we were on like a fucking sphere. If that makes sense. And like if you look into like the state of Kansas as well, the state of Kansas is 420 miles straight and it's flatter than a fucking pancake. That should be impossible.
Oh my god.
It's true.
But that's how you know it's a globe, because it doesn't look like a globe.
It doesn't look like a what, sorry?
That's how you know it's a globe, because it doesn't look like a globe.
It looks like a globe?
You know it's a globe because it doesn't looks like a globe.
Oh yeah, great point.
No, it's curving because it measures flat and level, and you know it's moving because it's motionless.
Exactly. We all know it's moving because we never see it move. Don't you know how things move?
It's pretty simple. If you want to know what the ground is doing, you just look at the sky.
Yeah, I mean, the sky will definitely tell you what's going on with the ground that you're standing on for sure. You know, if you look at a ceiling, that'll definitely be the same as the fucking floor that you stand on.
Exactly. Yeah, you got it. Pretty simple.
Rig, how did you come to the conclusion the Earth was moving?
That's a
That the Earth is moving. Well, the sun doesn't get bigger or smaller, man. So that, yeah. There you go. We're spinning.
Yeah, the ground is moving because things in the skies are moving. Yeah. And when I look at an airplane and I see the airplane moving, it's because the ground is moving. When
Don't say that.
Yeah, when I see a bird flying, it's not that bird, it's the ground.
Don't say that, man. They'll get into a bunch of fucking Coriolis bullshit.
So birds are stationary?
Yeah.
Yeah, no, the bird doesn't go anywhere, yo. The Earth moves. I mean, it makes it a lot easier for the bird, don't you think?
Yeah. Just like the sun. When you look at the sun, it's because you're falling backwards. That's why you see the sun moving. You're just falling backwards.
Alright, well, if we're staying still and the sun's moving, why doesn't it change angular size then?
Because reasons.
It'd be smaller and then getting bigger to noon
That's
overhead.
the
It'd
way
be
it
its
is.
largest and then it'd slowly get smaller again, but we don't observe that, do we? Next.
Exactly, and that's the way it is. And your opinion and my opinion won't change that fact. That's the way it works.
Rick, for what you're saying to be the case, aren't you assuming the medium and assuming what the sun is? A double assumption?
I don't know, am I? Why would I need to know what the sun is for that observation? I wouldn't.
You can see it. You can measure the angular size of it. What else do you need?
It's consistent.
Yeah, but sounds like you're assuming that it's a physical object with a one set size, right? I'm not saying it is or isn't that. I'm just saying you're assuming that to make that conclusion.
Yeah, well, that's what we observe. We know it doesn't change size that much, so.
I've seen videos of the sun looking like it's getting smaller as it goes like further away, or appears to look like it's going further away. I guess if you subscribe to the globe.
Yeah, and there's times at sunset where it looks huge.
Yeah.
It's only because you've got something to gauge it against. It's like the moon as well. It always looks big when it's on the horizon because you've got houses or whatever to gauge it against. But once it gets a bit up in the sky, it looks sort of normal again, doesn't it? It's just an illusion.
Yeah, that part is. With the sun, you've got the issue of how bright.
So
that
if
thing
you
is.
ever see
If
the
you're
sun
not
at a
looking at
size
it-
that it's
If you're not looking at the sun through a proper solar filter, you get very fooled about how large it is.
Why are you assuming a solar filter gives you the right size and your eyeball's not giving you the right size?
I don't assume it. I simply know that that's what happens when you're staring into an extremely bright light. You can prove that to yourself.
How looking at the sun determine the shape of the ground, and that looking at the sun determines the ground you're standing on. It's spinning, in motion, and curving.
No, the point was that the sun doesn't change angular size.
That's an observable phenomenon. You're saying that's the case, right? So we observe that, right? So what?
Yep.
What does that say?
We observe no easily measurable change in the angular size of the sun, and that says that the sun. Yet we see it move all the way across the sky. That says that that the sun must be an object which is very, very far away.
Must be.
Must be, yes.
Is that the only way it can happen?
Well, I'm open. Tell me how else it happens.
What if the light that we observe as the sun, right? We call the sun. It's an effect of a construct that is above your head, and the light is going through lenses, and the phenomena you observe is just an effect that is being caused by other variables that you're not taking into account, like the medium above, or multiple mediums, multiple lenses.
We can start tossing in all kinds of woo-woo, but you need some evidence.
Just like the woo-woo you're adding, right? Like, it's really far away.
I'm just giving you a simple observation and a simple explanation. Now, if you want to make that a much more complex explanation, I'm open. Tell me what it is.
Well, we can have lenses on. There's lenses on Earth that do that. There's lenses they showed on Globebusters. Zero Landucci did a presentation. There's lenses that will keep the angular size of an object behind the lens, no matter how much you move away from it. So that is reproducible. The idea of the sun being far away, I don't see why that's any more of a leap than the idea that there's lenses that are causing that effect.
Yeah, the idea of the sun being so far away is really complicated.
I mean, technically, if you think about it, I mean, no matter where you are, right, the sun is kind of far away. It just depends on how far you're arguing away that it is, right? Like, it's still, like, when we all look at it in the sky, I don't care if you're a globe or a fucking flat earther, it still looks pretty fucking, like, far. But, like, I'm not saying it's like 93 million miles, though, is what I'm saying, Like, yeah, maybe it is far away, but definitely not that fucking far.
Definitely not. You know that. Okay. Well, that's some sound evidence for you.
That I wasn't making a claim with evidence. I was just saying, like, when we say, like, it is technically, like, far away, yeah, but we just don't agree on the distance.
Well, how would you measure the distance?
I don't know. How would you measure the distance?
Well, there are several ways, but I'm not about to do it myself.
With a tape
measure. Okay. Yeah.
Well, like, what's like one example?
Well, one way that it can be done pretty accurately these days, because we've got equipment that can do it. That we can bounce radar off objects like the moon or like planets, like Venus or Mercury.
Okay. So,
and we can get a distance. We can get a distance to them.
So, are you saying that the code of those programs, that that when those programs come back at you with a number that they're 100% accurate?
Not a program, it's radar.
How does radar work?
You don't know how radar works, or are you just trying to test me?
I'm asking you. Because you seem to know more about this than I do, so. How does radar work?
Radar works by bouncing high frequency radio waves off an object and timing the length of time it takes that radio wave to come back to you. That's radar.
Okay. So, if you didn't know whether or not the sun and the moon were actual objects, would you actually be able to have radar go on that object?
How does not knowing if they're objects affect whether? I mean, I don't understand that question.
So, like, if the moon or the sun were not physical objects, if they were just lights in the sky, would that show up on radar as well? It's not a physical object.
I don't know what a light in the sky would be if it's not a physical object. You're saying it's just a mirage of some sort, just an aberration,
Well, a light, as in light. Light, yes. It's not physical.
Okay, there's nothing creating the light. It's just materializing out of nowhere.
Is a rainbow a physical object? It materializes out of nowhere.
No, that's an
No,
illusion.
So
that's what I'm asking.
That would require an assumption that the sun and the moon are physical objects for the radar to work on them. Yes. Or am I wrong? I don't know. Maybe I am wrong.
That seems rather strange to me.
Because if they
I don't know why.
you
If
need
you-
something to bounce the signal off, is what I'm saying. If there's nothing
Yeah.
to bounce the signal off, then you wouldn't get the radar, right?
Now, I have personally bounced radio signals off the moon.
Okay.
I have personally done that. Been a long time ago.
When you see when you're watching TV, right, and you see a moon projected in the TV, right, and then you also see like the light of the ceiling in your house being bounced off the screen. Is that light in your ceiling being bounced off the moon?
No,
Because
of
you see
course
the
not.
moon on the screen?
No, of course not.
Oh, okay. So you might be looking at an image that is being, projected up in the layers above, and you're
Yeah.
projecting off something else
Okay.
instead of the image itself.
I wonder what I bounced radio signals off of.
Maybe there's a ceiling up there. Possibility.
Did it come back with like a distance, or how does that even work?
Well,
You bounce
transmit.
Sorry, go ahead.
You transmit a signal with a directional antenna that has to be aimed at that light in the sky, as you call it. Because if you don't aim the antenna properly, you're not going to get a return from it. And 2.5 seconds later, you will hear whatever signal, whatever transmission you made, come back to you.
Okay. That's an interesting point.
So what you can only bounce things off the moon. That's it. You cannot do it any other way. You just do it on the moon.
Have you done it with not to like move the goalpost, but like have you been able to do that with the sun as well?
No, I don't know of any amateur radio operator that would have the wherewithal and the money and the equipment that you would need to try to bounce stuff off of one of the planets or the sun. That's particularly difficult to do.
Okay, well, no, that's a fair point. Okay.
So
But the moon is not.
That's it.
But the moon is not. That's the large body that's closest to us, and amateur radio operators do Earth, Moon, Earth bounce every day of the week. Somebody's doing it right now, I guarantee you.
Okay. Does that have anything? Does it like show you how far away the radio signals are going? Does it say, what is it? What is it? 290,000 miles? Or not yeah, is it miles or is it kilometers? I'm not sure. I don't want to,
Distance to the moon average is around 240,000 miles.
Okay, so 240,000 miles, right?
Yeah.
So is there any proof that your radio is going up 240,000 miles coming back down? Because if you can prove that, then you can pretty much prove a lot of other shit.
Electromagnetic radiation travels in a vacuum at a rate of 186,000 miles per second.
Would it be a vacuum? Because the moon.
It doesn't really matter because the difference in Earth's atmosphere is minuscule. It doesn't change it by very much at all. So you measure 239,000 instead of 240. Who cares?
I mean, that's a pretty significant measurement difference. So it's like what, 60,000 fucking miles.
What are you talking about? Measurement difference?
Well, you said doesn't matter if it's what 40K away or 290. That's a pretty significant.
I didn't say that. I said 239.
239. versus
239
what?
or 240. Who cares if you're 1,000
Oh,
miles off because of the Earth's
okay,
atmosphere?
that's my
Who
bad.
cares? Who cares?
Wait, so you're saying the number can be off?
I'm not sure how much it will change in the atmosphere, but other than to say it's very tiny. You want me to look into it? I'll find the answer for you.
Okay, no, don't worry about it. But that's that was just something I was curious about. Okay, though, so you got like people bouncing the radio signals or the radar signals like at the moon, right?
Yep.
Does anybody have any evidence that it is 240, 239, whatever, as within that ballpark range? Like, does anybody have any proof that the signals even went that far?
Just by the length of time it takes to receive the return. Yeah, that's how you know.
Based on the assumption of what?
Speed of light.
Being the same as the speed of the signals?
Yeah, all electromagnetic radiation travels at that speed.
Okay.
Doesn't change.
So these radio signals, right, that you're talking about, what do you think you would be able to transmit with them? This is just like what do you think you'd be able to transmit with those signals? Like video, audio, what can you do with that?
Well, you can transmit pretty much anything you like. If you want to verify it's your signal that you're receiving back, I prefer you just a CW transmission. Transmit one character, like an A or a C, and then listen. You can tell when you start sending. You can time it. If you got a little storage oscilloscope, you can time the damn thing from the point in time that you transmit it, and then you've got to stop transmitting to hear the return. Right? It's going to return on the same frequency that you transmitted on.
And you're saying you can send like videos, whatever the fuck you want, through these radio signals?
There's nothing stopping you from doing that. I don't know anybody that's doing it, but I don't know why. I can't think of a technical reason why you couldn't if you wanted to. I don't know why you would want to. But
Well, isn't that what NASA says they're doing in their satellites?
oh, now you're talking about something different.
Well, that's what I was curious about, because don't they say they use like radio signals
Well, of course.
to get their footage and video?
What satellites are you talking about now? Communication satellites?
Well, I shouldn't have said satellites, rather like telescopes and shit. The big old space cameras. Because they can like transmit like photos and stuff back, right?
I have no idea really what you're talking about.
You don't know about space telescopes?
Are you talking about optical telescopes? Or are you talking about radio telescopes? What type of telescope are you talking about?
As in telescopes that are supposedly in space. Like the Hubble telescope, that
Okay,
type
that
of
helps.
telescope, yeah.
All right, that helps me a lot. Yes, thank you. Yeah,
Sorry,
those,
I should have clarified further in, but when I said I thought it was enough clarification to say big fucking space camera, but I should have said rather big fucking camera in space. Yes.
Yeah, that would have been helpful. Thank you.
Sorry about that. Go on.
Yeah, those telescopes are looking at imaging objects in the very far distance, and yes, they send the information down by radio link. Yeah.
Okay. I was just curious because I've never really heard of people sending photos and videos, that type of shit over radio, but I guess, like you said, you wouldn't really need to on Earth.
Well, we do it all the time.
Well, I thought you said I don't know why people would do that.
Well, this conversation has gotten a little confusing. I thought you were talking about bouncing signals off the moon.
Oh, okay, my bad. I don't know. Maybe I'm just fucking not listening properly right now. Sorry, I'm kind of fucking high.
We receive television. We've been receiving radio and television signals for way over 150 years now, I think.
Okay.
Yes. Quite well-known technology. And it just so happens that's the best way to get images back from a satellite, right? I mean, we're not going to go up there and retrieve the Polaroid pictures, for Christ's sakes.
Right.
Pretty handy to send that somehow or the other. Doesn't work out too well trying to run a wire up to them, so piece of cable. Send it by radio.
So if you got like big old satellites and shit that are like moving around in space and shit, how many consistent, like, because would you get a consistent signal, do you think? If you were up there and you had like how many satellites do you need to get a consistent signal orbiting around the Earth in like the same spot? If that makes sense.
How many satellites do you need? Well, if it's an orbiting, well, regardless of what sort of satellite it is, no, you can't just have one satellite and continuously receive from it.
Yeah, that's why I was asking how many.
Unless you're talking about a geostationary satellite, like the weather satellites, like Himawari and stuff like that. That's where you get your weather pictures from. Those are in geostationary orbit. So, if it's Himawari, anybody over there in the Pacific can always receive a signal from it. Always. But nobody where I live can ever receive a signal from it. We can't see it. It's blocked by the Earth.
What was I going to say? Is the same shit that, is that the same type of shit that they're using to get you direct TV and stuff?
Yeah.
The geostationary satellites?
Yeah, that's the things.
Okay. So, you got fucking satellites that are supposedly, like, turning up there, right? And then some of them that are not turning with the Earth just because they're higher?
Yeah, it depends on the altitude of the satellite. You got to be, I forget what the number is now, 22,000 miles or something like that to be in geostationary. But then we've got a whole shitload of satellites that are at much lower altitudes, like GPS satellites. That's
in lower altitudes.
Huh?
Oh, nothing. I was just saying, like, they're in lower altitudes as well, so like they should be like easier to see then.
Easier to see.
I don't know. I've never seen one of these satellites, or I know they say you can see like the ISS and stuff, but I don't know about the satellites.
Maybe go check out Wolfie 6020 sometime. He makes good pictures of the orbiting satellites.
Interesting. I wonder what type of satellites.
No, it can be a variety of types of satellites, mostly communication stuff.
Yeah, so they must get like pictures of hundreds of those things flying around every night then.
Oh yeah, it looks like a swarm of those things when you point a telescope at the above at the equator, above the equator. That's where most of those geostationary ones are sitting, and it's really cool too to watch some of the video that Wolfie's been able to make. He's got really nice tracking mounts and really nice telescopes and cameras and things.
So
you can focus on a satellite and you can watch the star field behind it move, or you can look at a stationary point, just let the tracker track the rotation of the Earth, so the star field stays stationary, and then you see the satellites go whizzing by.
Interesting.
Yeah.
So, like if they're
you got the money and the equipment, anybody can do it. You got the equipment.
Well, yeah, I'm not saying that you can't like see the quote unquote satellites or the ISS or anything like that. Whether or not those are like actually fucking physical objects is up in the air for me, but but like when it comes to stuff like the ISS and stuff, I know people say that you can see that shit. I haven't heard anybody bring up the I guess you get to call them like equatorial satellites that you can see on the equator as well, but that's interesting that you brought that up.
Yeah, check out Wolfie's channel. He's got some of the best. There's lots and lots and lots of that stuff out there if you look for it. But
have you sent like radio signals to these satellites and gotten a return signal?
No, you don't do that.
You can't do that?
I don't know how you would do that.
Should it be possible?
Not that I know of.
So you can't send a signal out to a satellite and have the satellite that's sending out signals send you a signal back?
Well, if it's your satellite, you could, but I don't have one of them.
Okay. Well, I was kind of curious about that.
I don't think DirecTV is going to donate one of their satellites to me just to play around.
No, I wouldn't think so either. Suppose that they are as you say they are. But when it comes to the satellites and stuff, I don't know. I don't really know about them. People like they claim that they're up there and stuff, but I don't know. I think that they might be holograms. That's honestly my best guess as to like what they are, because people like to talk about the ISS and that type of shit for all fucking day. But I don't know anybody that's done like an independent experiment where they've shot a satellite, quote unquote, like up into space, and then they've been able to receive signals back from the satellite. You might be able to receive signals back from the moon, but you can't shoot a signal out to the ISS and have it even give you like some type of signal. I don't know.
Actually, you can. There is a repeater the amateur radio operators use that's on the ISS now, and I think it's 144 megahertz uplink and a 440 megahertz downlink. And you can, for $100 or so, equip yourself so that you can actually receive the signals from that repeater. You can at least listen to the downlink for certain.
Interesting.
So that's one that just came to mind. That you can.
But it only works with the ISS, is what you're saying. Yeah.
Well, you've got to have the proper equipment to have it work. Yeah.
Well, I'm not saying that you but with the proper equipment is what I'm saying, right? Like it only works with the ISS.
The ISS happens to have a device that is specifically designed to do that.
Okay.
Other satellites don't necessarily have anything like that. In fact, they don't have anything like that.
Okay. So is there I would say that like you could prove the satellites as being like physical objects very easily. If you could have them send like if you could prove that signals that are being sent to you are coming from the satellites. Is there any way to do that?
Well, I don't think anybody's gonna be able to satisfy the burden of proof you guys put on it. No.
Well, is there any way to prove that though?
Oh, you can prove it to me pretty easily, but I don't think you guys would buy anything I would buy.
Okay.
It's quite simple. You have to point your satellite TV at a particular spot in space, and if you don't point at that spot, you don't get your signal. It proves that that thing is there. You're an idiot.
That won't be good enough, Rumpus. You know it, and I do.
Yeah, but he's not. But I don't think he even realizes that. I don't think he even realizes there's that level of. It's rather suspicious. You have to point it somewhere particular in space, and you get that particular signal, and therefore there's something in space at that point that's sending the signal, and you have to point at it to receive it. Therefore, there is something there sending out your TV signal from that point in space.
Yeah, same thing true with Earth, Moon, Earth bounce.
So why don't
you
all
don't
of the
point the antenna
antennas
at the moon? You don't get it.
Why don't they just point all the antennas straight up then if it's just coming from space?
It's coming from a geostationary orbit near the equator. So you have to point it somewhere above the equator. And it's a particular spot. If you've got to subscribe to a particular satellite channel, you have to point to at the particular point where that satellite is. You can't point it anywhere. You have to point it at the point of where the satellite is, which will be above the equator at a geostationary orbit.
Okay.
So therefore, you can show that that's where it is.
And so every single time you got to point it the exact same way, no matter where you are, basically.
Yes, but there are lots of them though, so there are lots to pick from. But the particular one for you, that your satellite operator installer will have to know. There's one that has a particular coverage of a certain area. So presumably there might be one that covers, I don't know, half a certain band of the USA or something, and then the signal's strong enough, and then you point at that particular one. But it covers quite a few degrees. I don't know how many hundreds of miles each one.
How close together are these things? Supposedly.
Thousands of miles apart. When you're at 24,000 odd miles up in the geostationary orbit, they are very far separated.
Okay, yeah, okay.
And you can't bounce stuff off them. The moon is a very big thing, so you can bounce stuff off the moon, but you can't bounce stuff off of little things that are only a few tens of meters across, if that actually.
Not even that.
Yeah, not even that. Yeah, so about what,
Size
5 meters?
Minivan or something.
Yeah.
So wait, how big are these things supposedly?
I'll go with Blue's minivan size. That's why the ISS is special. It's 100 meters across. It's a very, very, very large satellite in comparison to the other ones.
Okay, but that didn't really answer my question. Like, or maybe I missed it. How big did you say the usual ones are? Like
the minivan. I say, I don't know.
Oh, a mini. Okay,
5 meters across. How about that? Is that okay, Blue?
Well, I was just curious, like how big you're saying these regular satellites are. So they're only 5
meters. We say 5 meters. That's probably a little bit over. But that'll do. I think 5 meters. Probably is a bit oversized.
Yeah, something like that. Maybe a little bigger with solar panels deployed. I don't know.
Yeah, it's difficult to know exactly what the.
Those things are.
Have an antenna there as well.
Go back to something like the Hubble Space Telescope. That's about the size of a school bus, roughly. Would be something about that size.
And of course, if you go and lie down in the dark, if you're going to go to a very dark place, just lie down for half an hour, get your eyes adjusted to the sky, you will see low Earth satellites go overhead, little sparks of little dots of light going over you in a satellite type way. They're very obvious. They move across the sky incredibly quickly, and they're very small, and they shoot across, and you can know for a fact that's a satellite. They don't behave like anything else.
So DirecTV and many of these TV providers are connected to these satellites for the signal, for the shows and stuff?
Of course, how you get them, yes. They send up a signal up to a geostationary satellite. You point your satellite on your house at the thing over the equator, and then you receive it. So they retransmit what they receive a signal from down on Earth, they retransmit it. That they're special, and as Blue was saying earlier, they're not going to transmit anybody's signal. They're dedicated to transmitting the signal from the TV providers. And they go to great lengths to make sure that no one else can do that.
Do they have what do you call it? Never mind. I forgot where I was going with that.
Yeah, are these devices even capable of transmitting these signals to millions and millions of receivers?
Yeah.
Like the data transfer between them, the data transfer that is happening, that's what they do?
It's not transmitting to any particular receiver. It's transmitting to every receiver.
It's a broadband of a signal, and
Not
you just
broadband.
cash in
It's
it.
not necessarily broadband. It's just a radio signal. Your local radio station doesn't know how many people have their car radio turned on and listening to it, does it? Same thing. It doesn't care.
So these devices are just transferring this data from the source to the receiver.
It's receiving a video uplink from the service provider and retransmitting that to any satellite receiver that can see that satellite.
Yeah, it does have to have line of sight to that satellite.
Yeah.
So yes, it just simply, though presumably they can focus it in a particular way so it covers a
And they
particular
can.
area.
So does that mean that DirecTV has like different headquarters all around the world? Like anything that's doing like a satellite, they have them all around the world basically? Or well, I guess you wouldn't need them if they're quote unquote geostationary, right?
No.
No idea what you're talking about. There are lots
So,
of
like-
satellites.
so, like-
there.
so, like,
There
if
are
you're-
lots
if you're-
of TV providers, and they've got their own satellite. Or in fact, actually, they sometimes share satellites, and then they just brought up that which can send out different frequencies. And so it's just like radio, as Blue was saying. You've got a provider. Okay, it's slightly different from radio because you actually have to go and send it. But you can have a repeater radio. In other words, you can have somewhere your little radio station. It sends along a cable, but in this case it would be a radio link to a transmitter, and then everybody who's within range can see the transmitter gets the radio. It's no different except for that first link in a radio station's case. That would probably be a hard link. But just think of that as being a radio link up to the satellite in space. I mean, what is difficult about this to understand?
But the radio signal is the same thing as the TV signal. The sound.
TV signals are just another variation of radio signals. It's just a different
So
frequency with
the
different
image and the sound are basically transmitted the same way.
Radio signals and TV signals are very, very similar. They're on
So
electromagnetic radiation.
why? So the radio stations do have satellites as well. That's why they transmit the radio. That's what the radio
No, not your local radio station doesn't. But I'm saying the principle's the same.
So why they do any difference? Why don't the radio stations have like satellites everywhere to transmit the radio? Why do they use antennas? And why do we have TV antennas like around most cities? Why do we have that?
Right, a TV and broadcaster antenna can only reach, because it's low down. It can only reach, I don't know how many. Probably have a range of about 10 or 15 miles, I suspect, unless they build a really high one. Well, that's not very. Whereas if you can have a satellite in space, you can cover hundreds of miles with one satellite. You can cover.
So this TV antenna that is probably thousands of times or hundreds of times bigger than this satellite, and it's closer. The TV antenna is closer, bigger.
Yeah, but it's low.
Can utilize more power to.
They don't have a line of sight to it. Unless it's a very, very tall antenna, you can't.
He can do less than this smaller tin can device floating in space.
Yes, it does less because it's lower, and you can't have a line of sight for things like HD TV. You need a line of sight, And
Yeah,
unless you
Rumpus,
build an antenna that's bloody miles high, the range around it is going to be limited to about 10, 15, 20 miles.
Yeah,
Yeah,
regardless,
that's why there's
actually,
multiple of
what I
them, right?
what I understood,
That's why
what
the TV antennas are built in high grounds and in multiple
It's not
locations,
good
right?
enough. It's still not going to get you there. It's not going to get you hundreds of miles coverage of the satellites. Going possibly,
yeah,
I think probably might
yeah,
be more. I mean, satellite coverage might be up to, could easily be near 1,000 miles. I'm not quite sure.
Hey,
The details.
Rumpus, what I actually thought is the way that the radio stations do their statistics, their data to how many viewers or listeners that they have. It doesn't matter if it's coming from a repeater or straight from their main signal. Is that they can see how much draw is coming from the signal, the power that they're putting out, and they can calculate how many viewers or listeners that they're getting. So
No,
yeah,
no, absolutely not.
No, we can't
yeah,
see how that works.
because they're on a certain bandwidth and they pay to use that bandwidth, that certain number, say FM 95.8. And then they're actually putting out a shitload of power, and the draw from that, they can calculate how many
No,
listeners they have.
no,
I
you
don't believe
can't.
that.
No, you cannot do that. It
Yeah,
does not make
I'm
any
trying to
difference.
tell these TV towers
Let me finish,
people
please.
that they're doing it the
Hold
wrong
on.
way, using satellites.
Jamesy, let Blue finish what he was saying, please.
Let me finish what I was trying to say. No, you turn on a radio transmitter, and it doesn't matter if you're putting out a megawatt of RF from that thing. It does not make any difference whether there's no receivers listening to it or 1 million receivers listening to it. You cannot tell how many receivers are tuned to that radio signal that you're transmitting. There is no way you can do that.
But you can do that with the handheld, the radio systems that they use on boats. Is that VHF? I think it is. They can tell how many people are actually tuned into that
You're talking about
particular
Wi-Fi. You're talking
signal.
about Wi-Fi link.
That is
Because
a technical impossibility. That is a technical impossibility. It cannot be done.
I think you're getting mixed up with internet connection, where you can know how many people connect to you, because the things you get have to have a signal, Wi-Fi sort of thing sends a signal back to the station to say, here I am. This is
That's right.
So that's a completely different system. It has to be able to receive information from you. So if you're talking about internet connections, yes, you can. But if you're just receiving radio, then no, you can't, because it's not sending anything back.
Well, you have to log into that signal, don't you? So that can be tracked, where you can just
if you're on the internet, you have
the radio
to
signal.
There's a two-way connect with internet. You have to have a two-way thing, so you can know then. But not with radio. There's no reverse. No one.
You can't just indiscriminately. You can't just indiscriminately tap into somebody's internet system, right? That you cannot do. That's right. You got to have permissions, bandsaw. But radio transmissions are not like that. Anybody with a receiver, if that's being transmitted, anybody with a receiver can receive it. Now, it may be encoded in such a way that you can't make any sense out of what it's sending, and that's how they protect themselves.
If it's digital,
Yeah, with encoding, with digital encoding type software. So unless you've got the proper equipment that the satellite guy or the television station could do that too if they wanted to, but they don't. They just transmit a radio or a television signal, and anybody with a receiver can receive it.
So that's good for the future. If you can wirelessly transport electricity, then if you're doing, say, 10,000 megawatts, then there's no limit on how many people can do it.
Tesla tried that and made a fool out of himself.
Absolutely. You can do it at a very short distances. In other words, you can charge things on. I think people think they can charge their iPhone on a little charger. It's right next to the thing, and yes, that's done via waves, and you get induction in the phone, but it has to be right next to it. You cannot do that sensibly across.
Well, apparently they're doing it. They're experimenting with doing it over the 5G network. Once they pump it up to the full power, they're going to be able to do wireless electricity, wireless charging to a mobile phone.
Oh, really?
Yep.
I don't
That's
see how.
interesting.
That's what they're all planning. Yeah.
Well, that's a very interesting
Over how far?
Well,
tidbit.
however far, it's not very far from each transmitter from 5G. They're only like one block apart, but that's what.
So basically, while you're walking down the street, your phone is consistently charging. Is it, Carlos?
Yeah, that's what they're planning. Yeah.
Damn, that's cool.
And if that's possible, then wow, wireless electricity everywhere. You know.
You not heard of that, Rumpus?
I don't believe it.
Okay.
You can do it. You can do it by sticking it on a plate or something.
All right.
But I do not believe walking down the street you will be able to charge your phone from 5G.
Okay. Well, let me find out.
Oh yeah, so what I was going to ask earlier regarding the satellites and stuff. So like when it comes to the satellites receiving the signals, like do you guys claim that they're like all geostationary, like cuz like if they are, right? Like they got to have like what do you call it? Like some type of ground place, you know, sending the signal to the satellite, right? So like no matter where you are in the world, right, if you have one of those satellites, they need like somewhere on the ground to receive the signal, right, and like send them out, or sorry, not receive it but send out the signal rather.
Yeah,
Actually, oh damn, go back. Well, I just googled an article, but I've got to subscribe to the actual site to download the rest of the article. And it's actually very interesting. It says overall vision of 5G ready wireless charging. For decades, wireless energy transfer and harvesting remained of focused attention in the research community, but with limited practical applications. Recently, with the development of 5th generation 5G mobile technology, the concept of dedicated radio frequency charging promises to support the growing market of wearable devices in this. And that's where the article ends, but it actually has a picture above it where basically you got your 5G towers in your neighborhood and people just walking around with their mobile phone, with their 5G watches, and they're kind of getting charged as they're just walking around. So there is actually something to what you've just said, Carlos.
Yeah, I normally, if I'm not stoned, I really don't tend to talk shit so much.
No. I just never heard of it before, and it was a very simple search. I just typed in wireless 5G charging, and basically it was the first article that popped up.
But they say that they're using the 5G on the ground though, right?
Yeah, the towers, Jack. So basically you're walking around the street with your 5G compatible phone, and as you're walking around, it's getting charged on the go. This is what the article is indicating, that first one that I read. And there seems to be a few other articles that are suggesting very similar things, Rumpus. Maybe you should look into it.
Yeah, I've been reading since I read
Well,
that comment.
now that you just mentioned that, sorry to cut you off there, but now that you just mentioned that, though, I know that Tesla, they're talking about putting the quote-unquote Starlink satellites up there, right? Wouldn't you be able to achieve the same effect of basically giving everybody internet with those types of 5G towers? Yeah? Because that's kind of what it sounds like to me.
You are pumping out energy, but the trouble is it gets so dispersed after any sort of distance. I mean, if you're right next to a tower, then you conceivably could do it. If you were very close to a 5G thing, then yes, you can get some power.
Yeah, if you're only looking at very, very tiny amounts of power. Yeah.
Yeah, and you're close to the source of it. Yeah.
But when I said Tesla earlier, I wasn't talking about.
No, I know you weren't.
I'm
I'm the one
Nikolai.
that. No,
Yeah.
I brought those up just because like I know they're saying that they're sending those satellites up there. So it sounds like to me at least that you could do the same thing with these 5G towers that they're talking about.
No, I was speaking specifically about Nikolai Tesla, who envisioned a system where you could, power your house that way.
Oh yeah, that's probably real at this point. Like if they're saying that you can do this with the 5G stuff, what do you think they're going to be able to do another 5 generations later of that type of tech?
I think I talked about this with Rumpus years ago. There's actually no real need for a separate line in your house for your internet. Everything can just go through the electrical wiring, or your internet, your phone, all your signals just go through the power wires. You don't need another set of wiring for that.
That's a good point.
There's one article here about something's going on in New Zealand where they're going across 130 meters.
Okay, then. Well, so
the powerhouse or something.
Yeah, I can definitely see. Okay, if it's only a short distance, but if you're in a major city, pretty much wherever you are in a major city, you're probably not going to be any further away than 130 meters from some sort of tower.
Yes, I mean that would be conceivable. That wouldn't be high power, but you might have enough to power your phone.
Yeah,
it would be handy. I think the application would be really handy for drones, like if you're going over a particular area, rather than having it's just charging as it's flying.
But this technology, Rumpus, this new technology, right? Let's not get into the conspiracy side of it with Tesla and whatnot, but let's just say that this is just recent technology. Okay, we'll go with that train of thought. So it's in its infancy at the moment. So we can generate enough power now for mobile phones. Well, who knows? Yeah, but all I'm saying is, Rumpus, like, who knows what they're going to be developed in the future? Like, where can this go? Where's the limit? We go from phones to cars, perhaps to your home. Like, who knows where it can lead?
Yeah,
like
but
the world's your oyster, really.
If you start radiating it at that amount of energy, it disperses, to the inverse square law as it's radiating out. And so you've got to be close to these things to be able to do anything. So the idea that you can be anywhere, in a field tens of miles away from one of these things and picking up is just not going. That just can't happen.
Well, with the technology we have today, Rumpus, I'll agree with you. Like with the technology
there's a fundamental physics thing here.
Right.
Well,
don't be such a negative Nancy. Get on board. Go, yes, we can do it. We can do it.
Those of us who understand a bit about physics don't just randomly say you can do this. We say there's fundamental principles. We're constrained by reality, whereas flatties not constrained by scientific problems, whereas we are.
You're such a pessimist.
All I'm gonna say is that the idea of satellites came from 2001: A Space Odyssey, man. So that came from a science fiction.
You just made that up.
Yeah.
Where did they come from?
Arthur C. Clarke proposed geostationary satellites in, I think, 1948 or something.
Something like that.
Well, we already have wireless electricity everywhere. That's what solar power is. You charged by wireless.
Yeah. Come on, Blue. Jump on board. Come on. Jump on the bandwagon, Blue.
Yeah, to do solar power, you need something to power the sun, emitting the most amazing amount of energy you could possibly imagine.
Yeah, I heard you, Ben. So, and that Wii shit works. That Wii shit works until somebody hands you the fucking screwdriver. and says, "Fine, have at it, bandsaw."
Hey, you can do it. I'm the ideas guy, right? You can put it into practice.
I got a whole toolbox full of screwdrivers. I'll send you a couple. You get to work on this, okay?
I'm only interested in left-handed screwdrivers, Blue. Only left-handed screwdrivers.
I don't use those at all, so I'll send you all my left-handed screwdrivers.
This is a classic case of Dunning-Kruger. If you have no understanding of the problems involved, you can come up with anything. Whereas those of us who have some understanding, we realise some of the limits.
Pooper.
I'm doused in reality. I'm afraid. Yeah, I don't. I don't live in fantasy world.
I wish Rumpus was here last night when Wolfgang was on. Wolfgang was running circles around Kosho. But it was a good conversation until Rakia came on. No offense, but that was a shit show. I don't know if you were there, Bansel.
I came in for the end of it, Carlos, and
yeah, that's sorry, by the way, that's my bad. You're right, I was wrong about the Space Odyssey thing. Somebody made it up in another sci-fi novel from 1899.
1899.
Yes, Edward Everett Hale apparently was the one to come up with it. So that's my bad.
Well, you've got everything wrong so far, so why change habit?
Rumpus, be nice.
Well, I mean, when someone tells you that things are holograms in space from nothing else than wishful thinking, I mean, there's no point in.
Be nice.
Hey man, you guys said that the only radio signals that y'all are getting is from the so-called ISS. So
no, you get radio signals from stations in space. The ones you wanted a specific sort of radio signal where you had control over it, where you could send it a signal and it would send something back. Well, no one's going to spend millions and billions of pounds providing you with a radio repeater, except the having the ISS case where you have to pay a bit of money. And you got completely confused between that and bouncing it off the moon, where it's just a passive response, and you need something dirty, great, and big like the moon to get a response from it. You got completely confused about those two things.
I didn't mention the moon together in that statement there. I was talking about the other
from
satellite.
A preceding point. You were wondering why you could get signals back. You can get signals back off big lumpy objects like the moon passively because they just bounce back. But then you seem to think that everybody around the world should spend billions of pounds on providing you with a service which takes your signal, decodes it, and then sends it back using power. They have to draw either from a nuclear reactor inside the thing, or some very nuclear source, or radio, or solar power. And they think you think someone's going to build something that just provides you with a service to give you a signal back. No, I mean you don't seem to understand the basics of physics or economics.
I mean, I guess it's fair to say, yeah, it'd be too expensive to put it on there, but to be like, oh, wow, it's so stupid to act like, oh, they wouldn't put it on another satellite. I don't see, like, some of the people, like me, I guess, would think, why don't they have it on another one than the ISS? I suppose that's a good answer.
It costs a great, huge wad of money, and they've got to provide a service to do that, and you'd have to pay for it. So on the ISS, there is a service you can pay, as Blue was saying. I just had a look at it. There's this repeater service that costs you a great wad of cash. So that is provided, and that's a novel thing. But surely you can see the technology involved in taking a signal from you, because at the moment these TV satellites, they're dedicated to receiving a signal from a particular person. It's all encoded, and they then broadcast it to a particular spot on Earth. Why you think that they should be providing you with the option of going into their satellite, using up their power and their technology, and then beaming it back down to you is just incredible. It's like saying, why don't oil companies provide you with your own car for free?
Well, they should.
I know, that's a good
point.
But
there for them? You have to think, why is the satellite even
give
there
you not only provide you with a car, but give you a car. Why aren't there companies around here that are giving me a car and some nice clothes and a restaurant? I'd like to go and eat in a restaurant, really the best restaurant in the country every day. Yep. Why isn't someone providing me with that? That's the same sort of logic. That's the same sort of logic you're providing here.
And to be fair, though, it sounds like you're getting a little I don't know, just a little bit more heated around this. But all I'm gonna say is that you're saying that it's a ridiculous idea that people would even do that, and then they do it on the ISS.
It's the same reason it's ridiculous that people would come round to your house and provide you with a restaurant meal.
They did it on the ISS. You're saying
you have to pay money for it. And it's unusual. They're dedicated on the people who are providing TV stations are worrying about providing TV to people, not providing you with an individual service that's going to and a service just for you or individuals. It's not going to pay the bills.
And so nobody else
These
has
things
thought of
cost
that
millions
except for
and
the-
millions of pounds, and they've got to get, they want to buy, I don't know, tens of millions of subscribers on their service who want to receive TV.
There's
You might
plenty
as
of
well
money.
just-
There's plenty of money to pay for it. It wouldn't cost them a dime. It would be
Hey,
paid for by
Dan,
the enthusiasts that want to see
check
that.
out the
How
check
many
out the
problems-
battery.
Yeah,
check
like
out the battery.
if you like, I understand what you're saying, but like they could make a satellite where you could have like.
And
So
the-
the same type of shit that you're doing with the ISS, where you have a
Look,
subscription
Starlink is
service.
like this. There's a similar thing with Starlink, with an internet service from the sky. That's what Elon Musk is trying to do, providing you with the ability to talk to a satellite and get something back from it. That's the service he's providing. And that, I can't remember, was that going to cost $500 or something per person? So if you're willing to spend that sort of amount, then yes, you will eventually. I mean, Ukraine has got that service installed now, but I think that's the only country that has. So you need an amazing. He's having to launch, I don't know how many satellites. Is it tens of thousands of them to provide the coverage so that you can talk to them and then get a signal back? For that, you have to pay, was it $500 a year, or was it a month? I can't remember now. But an insane amount. So then that would be a viable economic prospect. And even then, that's been slagged off. I think the economic model has been shown actually to keep those satellites in space, etc., and serviced will cost him billions and billions of pounds a year, and is actually not economically viable. And it's basically going to turn out to be a waste of time. But nonetheless, that's the current attempt to do it, and that's still going to cost you, as I say, an enormous amount of money per month to do that. There's a case where someone's not feeding you something, you're going to that's the restaurant model. If you want something, you have to go to a restaurant and pay for it, and then you get service back. You seem to live in some sort of fantasy world where people are running around providing you with very difficult services for free. You don't seem to expect that in the real world that you live in, yet you seem to expect space to do that. Why?
Well, I just said that they already okay, no, I understand that it's not free, and you guys already just told me that it's not fucking free, and you need to pay for it to use it with the ISS anyway. So I'm saying, what's stopping anybody, even if it's a failed fucking economic type of shit, how come nobody's ever even thought of the idea of putting one up there just to be like, yeah, like you can put a fucking repeater up there and then
have the ISS, they have done it as a novel thing. The ISS, as a novel feature, have done it, for which you have to pay a considerable sum to use it.
Check out the little.
And it's a right old pain because you have to keep on pointing. Whatever you're using has got to follow the ISS. It's not geostationary based. You have to follow the damn thing. So it's not really a very useful thing.
Imagine they could stick one of those on the moon. You could live there for however many. See how many households it can power.
A miniature nuclear battery. It lasts 20 years.
No, the one below that, the next one I posted about China developing their small nuclear power plant, and it can power like fucking so many 50,000 households.
Really?
Yeah, you see that it can provide enough energy to power 50,000 households. The power plant could be installed on an island in South China Sea. The reactor could run for decades without needing to be refueled.
What's that got to do with the price of fish?
Stick one of those up on the moon, and it can be useful in so many ways.
To the people who are there, yes. It's not terribly useful to anybody down here.
There'd be plenty of enthusiasts that would pay for that, for the moon footage and for the sunlight footage. But the reason they don't do that is because they know they're a fraud and they get caught. That's why.
What?
Yeah, gotcha.
What was that gibberish? Something about a fraud?
Did that come through clear?
I missed the start of your sentence, whatever it was. Something to do with someone doing a fraud.
Everything's monetized now, so that they'll have plenty of enthusiasts that would pay more to have moon footage, to have satellite footage, but they won't do it because they know they're a fraud and they get caught.
You
So
think
that won't
people are
cost them
going
a
to spend?
dime.
What do you think the cost? What do you think the cost of transporting that
They'd
to the
have
moon would
low
be?
heads like yourself that believe in the bullshit that would pay
What
a
cost do you
good portion
think would
for it.
be to take one of those to the moon?
If they went to the moon, they'd already have that on the moon. If they went there, they'd already have it established there. Think about that.
No.
would they?
That thing would usually have they're surrounded by huge steel jackets and things, and have a whole system to look after them. Nuclear reactors are huge things. We're currently building one for in this country. I mean, admittedly, it's much bigger than that one. I can't remember. It's 30 billion pounds. Nuclear reactors are incredibly expensive. They need constant maintenance, and they're very, very, very heavy. And the idea, and the fact that all this struggle getting back to the moon we're having with this the current NASA SLS Artemis thing, the idea that you could go and plant that on the moon for next to nothing. I mean, it would be billions. I mean, it would be tens of billions of pounds to put that on the moon with a system to keep it going. Tens of billions plus the cost of the rocket. I mean, it's just insane.
$2.7 billion.
To do what?
Get to the moon.
And NASA's budget is just what, 30 billion a year. So there you go.
Yeah, so they had,
$2.7
so in other words, I thought it was 33 billion. Not that it makes that big of a difference.
You know what?
But
I'll give you the 30. I'll give you the 33. I'm sure I'm an old number.
yeah, and they don't want to spend it all on sending a reactor there. They've got other things to do. That's just to get there.
Why don't they just use solar power? Why would they need a reactor?
Well, that's what they do.
Doesn't the moon light up?
They're not suggesting putting this reactor on the moon. Just where is it? WTF is?
Doesn't the sun light up the moon? They just have to put solar power. If it really glows from the sun's light, it'd be the best solar power station in the world.
Yeah, but it's dark half the time.
Oh, but there's no atmosphere to worry about. There's no clouds.
But it's still dark half the time.
Solar power heaven, bro. Think about it.
You're not. Try to listen to what I'm saying. It's dark half the time. The solar day was it?
Like on Earth?
So for 13 days, for 13 days, a month or something, it'll be completely dark.
You mean like on Earth? We have solar power on Earth.
Oh my God! Can you focus on the moon? You just made a suggestion. You can have continuous solar power on the moon. No, you can't. The solar day is about 27 days. Is it?
28. Yes. Yeah, 27, 28 days.
Yeah, 20 varies a little bit. 27 days. So that means that if you split it into half day and night, half for 15 days a month, it's completely dark. So don't start suggesting it's some sort of solar heaven.
The solar power works. Okay, it can power whatever you need to power from the light it gets, and it'll still work at night. It doesn't just turn off.
Yes, but it's for 13 days. It's going to be dark.
If you store the energy some other way,
exactly.
Yes, your equipment can continue to operate in the darkness, but not from solar radiation. At that point, you're drawing it from batteries that you charged up while you had solar radiation.
Oh, and how heavy are batteries? Oh, very, very heavy, and they take a lot of installing. We don't even have that technology for wind farms at the moment. For the storing all the excess energy they've got, because it's storing it in batteries. Storing energy in batteries is incredibly expensive and difficult, and you need 30 great big batteries.
Here we go, Rumpus. So to the SpaceX built human is about $2.9 billion. All right. And from that initial investment, it will then only cost only $10 million per trip. Boom. Bargain basement prices right there. Jump in quick.
So you're claiming that the SpaceX mission to the moon, the total cost of the SpaceX mission to get to the moon is $3.9 billion.
Well, I'm just reading an article here.
I think you said 2.9 billion.
2.9 billion plus 10 million per launch, but it costs it costs.
Yeah, but that's
It
not allowing for the
costs.
development cost of the rocket. I mean, if you
We're gonna
sold
double
it-
that 10
No,
million.
hold on. Yeah, I'm getting there, Rumpus. I'm going to be fair. I think it costs 40 billion to actually develop it in the first
Yeah,
place.
there you go.
So, okay, well, they've already developed
As I said,
Now they've got it. Now they've got it. All right. And seeing as it's reusable, it's only 10 million bucks per launch.
I think
Let's
you're
double
underestimating
that to 20 million because of the Biden gas tax.
Wait,
We got
isn't
food.
that their own estimations, not bandsaw's though?
Anyway, that reactor is not transportable as it stands to the moon. It's a ridiculous idea.
Why would you need that much power on the moon?
He's trying to make it so it doesn't work out, but obviously they can do it if they wanted to.
What would you do with a power plant that size on the moon? What would you power with it?
Shouldn't you be asking WTF that? I think he was the one that made the claim about the whole thing.
There's billions of private money that would pay for, a hotel on the moon. They can do it. More moon trips.
Yeah, like as if there isn't any like millionaires out there or whatever that wouldn't pay to go to space. Billionaires as well, yeah.
Well,
But they don't
want to spend all their billions on just transporting a power station and putting it on the moon for no reason.
I'm not talking about that. I'm just talking about going to space in general. Like, you got supposedly like Richard Branson and shit going to space apparently, but nobody else does that. Richard Branson, Jeff Bezos, I guess those are the only two guys.
Yeah, so
they won't let
you need to be a billionaire to do it. Yes, and what's the point?
Well, I thought you needed to be physically fit, and there's a lot of other things that you need to be an astronaut rather than just have fucking money.
All you need to be is a globe head with money, and you can do that. You can pay for all that.
I don't know what your point. Yes, but Branson and Bezos have billions of pounds, and they spent it on a rocket system which got them up not into orbit, but into space. Yes, and what so?
Not quite to the moon.
It should be pointed out that I'm pretty sure the government paid for that. They didn't even pay for it.
I think the Branson thing's entirely independently.
It's done by Blue Origin.
No, that's the Bezos one. I'm talking about Branson.
Yeah, that's how they did it, wasn't it? Through fucking Blue Origin.
Branson had his own system. Jesus.
Okay, sorry. No, that's what I was asking you. Sorry, maybe I'm wrong. I'll look into.
You are wrong, as you're wrong every time. Yes.
Okay.
Rumpus.
Well, he's got 100% record so far.
Rumpus.
Jeff Bezos, contrary to popular belief, Jeff Bezos and Richard Branson are not the same person. It's actually two different outfits. One's called Virgin Atlantic and the other is Blue Origin or whatever.
Is it Virgin Galactic, I think? Virgin Galactic.
That's what I don't know what I
You
said.
said Atlantic. Well, at least it sounded like Atlantic.
Virgin Galactic. Yeah, okay, whatever. Yeah.
Yeah, I don't think even the Blue Origin.
I'm being fucking dumb, like a lot dumber than I usually am. I'm like that. Sorry.
Good. I'll accept your apology.
Okay, yeah. I just I'm just trying to have like a decent conversation here. I'm high as fuck, like I said, So if I sound dumb as fuck, honestly,
go away, get low, and then come back and talk to us. Anyway, so the point is transporting a dirty, great, big, very, very heavy reactor, which you cannot transport on even the Artemis thing. There's no way. They can only... Transporting that to the moon is not possible with any current technology, or even any proposed technology over the next decade. Reactors are big, chunky, very heavy things, and that very big, heavy things, exactly what you can't chuck around. I mean, getting just people over to the moon is difficult enough, let alone some great chunky reactor.
Take it in bits and pieces. Put it in a couple of backpacks.
Okay, if you want to do it over 20. Oh, well, the trouble is transporting radioactive material. You have to put all lots of protective lead around it and stuff. And that's always going to be heavy. And even if you did take it I mean, okay, you could spend 2 decades at it. This would not be cost effective.
Oh, rumpus! They can get golf clubs to the moon. Sure, they can
Would it?
get a reactor up there.
Yeah, well, that's the trouble. You don't understand the difference between a golf club and a nuclear reactor.
Wouldn't you also need like a bunch of lead and shit like around the rocket and stuff to protect against the Van?
I just said that.
No, around the rocket. Around the rocket is what I'm saying, to protect against the Van Allen belts as well.
No,
you don't need that.
No.
Okay.
Because that's the radiations from that. You don't want to spend a long time in that, but you can actually time the launches to avoid the radiation from the Van Allen belt, and it's also very transitory. You only go through it very quickly, so the radiation upon you is actually quite small. And a better way of doing it would be having a sort of electric field around the thing to fend off the particles that. Well, that wouldn't affect gamma radiation. I think the Van Allen belt is mostly protons and things which you can deflect with magnetic fields and the like. But it's not fun. You don't spend long enough to do those Van Allen belts to worry about. I mean, things like when the astronauts, when all astronauts report, well, they didn't report them for the first few years. Astronauts were reluctant to report the fact they were getting all these flashes in their eyes, and eventually, and what these were, these high velocity particles coming into their brain and eyes, and so. Eventually, some of them said, "Look, hold on, I'm getting this experience." And someone said, "Oh, yes, I am as well." And then eventually, they realised that these poor astronauts are being subjected to all sorts of radiation just by being on the moon, let alone being in the Van Allen belts. And that's a problem. If you're out in that for a long time, you're going to suffer unless you're surrounded by, lead thing or whatever. So, astronauts, so you are subjected to solar radiation when you're out there, and you will suffer. And it's something that's a big problem.
Oh, put some sunscreen on.
Did anybody get cancer from that?
I don't know what the cancer thing is, but they definitely were subject to much more radiation than we would.
Did they have a headache? Did they have cancer? How do you know they were hurt by this?
Because they reported these experiences and then they measured it, what the radiation was, and they could see, and we know the damage that. I mean, there are many studies on the damage that.
How do they measure the radiation you claim?
Well, they've got devices.
They all wore radiation monitors.
They all glowed like glow juice when they came back.
Have you ever seen a radiation badge? I used to wear one in the Army. I was an X-ray technician.
What did the radiation badge say?
It's a little radiation badge. Carries a piece of dental film like they used to use for when they did real X-rays.
Wonderful. So when they went to the Van Allen belts, what was the radiation badge showing?
About the equivalent of a chest X-ray.
and Rumpus is claiming that they were harmed by this radiation.
No, I didn't hear him claiming they were harmed by it.
Well, yes, I don't think I can't. They certainly were having the.
They were noticing that effect that you're talking about.
Well, they know they're being subjected to quite an intense radiation, so obviously they know that this is well documented. What happens to you when you are subjected to that sort of radiation for long periods of time?
Is it intense? Is it intense though, or is it the same as a chest X-ray? Because that's not the same as intense fucking radiation. I would say, at least. Well, maybe again, like I'm dumb right now, so you could debunk me on that too. But
well, put it like this: I've seen photographs of the metal structure inside their helmets, I think, of these astronauts, and you can see the impact of the high-speed particles from the sun, the radiation from the sun, in effect, and that is actually, you can see it destroying the metallic structure of the inside of the astronauts' helmets at a molecular, atomic level, and that is the sort of thing that's going to ultimately kill you. Now, whether or not they've had cancers and things, I don't know. I don't know off the top of my head whether the rate of cancers in astronauts is great. I mean, we've had 13 astronauts on the moon. I don't know whether they've had what their rate of cancer is. I mean, certainly Neil Armstrong didn't live very long, but I don't know I can't remember what that was now. But yeah, I don't know the details of that. But I do know I've seen the pictures of these radiation which you don't get on Earth, and I can imagine. That's not going to be doing you any much good if you're under it for very long. I don't know the details.
Well, that's just interesting because, well, the Blue, I think it was Blue that brought up the point, right, about the chest X-ray thing. So, I would be curious to know whether or not the radiation that they're claiming that they went through is like as serious as they claim. That's just what I would say.
Well, put it like this: I thought it was equivalent to a chest X-ray if you actually went high up in an aeroplane journey, something like a visit on Concorde. I thought was similar. I thought one Concorde trip was similar to a chest X-ray. So, but anyway,
so not so bad.
Yeah, quite bad. Well, yeah, that's just up in Concorde. Where it's 60,000 feet up.
Well, which is it though?
Okay, well,
is it
right,
is it the chest? What do you think it is? Like, do you think it's the? Was it Blue who said that? I don't know who said that. I think it was Blue, but he's not talking. Okay, well,
right. So here, when nuclear reactor workers and patients who have undergone therapeutic radiation have received low energy transfer radiation dosages in the same. Right. So okay. So if you receive therapeutic radiation treatments, you receive this 50 to 2,000 millisieverts, whatever they're called, which is what you get for a 6-month duration on the International Space Station. Okay. So in fact, Blue, I think, was basically correct.
Yeah.
So that's on the space station. The moon, I think, would be much worse. I was talking about astronauts. I think presumably you're still protected by the Earth's magnetic field on the ISS. So on the ISS, it looks as like a 6-month mission is equivalent to various therapeutic radiation treatments. But going to the moon, I suspect, would be rather higher.
Well, I don't know, but from what I've seen, it doesn't seem like anybody else is talking about that stuff. But I don't know. I haven't looked at the stuff that you're showing me.
Yes, we know you don't know. Let's just see if I can find out. Here we go. How much radiation do astronauts get on the moon? Here we go. It's much, right, that's 60 microsieverts. Right, which is 10 times higher than experienced on a transatlantic passenger flight, and about 200 times higher than we got on the Earth's surface. Right, so it's basically 200 times what you get on the Earth's surface on the moon.
Is that from the sun?
Yes.
So you would get a sunburn if you wanted to take your suit off, but you would actually die from vacuum before the sunburn, correct?
This has nothing to do with sunburn. This is to do with particles of going through the suit and into your body. It's got nothing to do with sunburn.
Oh, I don't think it would. They're not saying it's 200 times the Earth.
No, we're not talking about sunburn. We're talking about the radiation. We're not talking about optical radiation. We're talking about particles, these invisible particles, high energy protons and electrons.
Rumpus, they're talking about 200 times without a suit, so the suit would definitely protect you. So it's not really an issue.
I would suspect these would penetrate the suit. I think this.
The suit doesn't get protection.
This is how much radiation astronauts get, which will either be in the suit or in their spacecraft. They're getting 200 times the ionizing radiation that you would get on the Earth. This is not anything to do with the optical.
That would be without protection, though, right? Because they have a space module. They have a suit with
this is what they get. I just said this is what they get, even with their protection. They're getting 200 times.
I don't think that's correct. I think you're overlooking that.
Which says how much radiation do astronauts get on the moon? And it says here, astronauts hopping about on the lunar surface will soak up about 60 microsieverts of radiation per hour. So that's actually what they will get personally. So that will be through the suit. Through the suit.
But it doesn't say that through the suit. You're inserting that.
Well, they will soak up. It says. Well, I must admit, I haven't got that.
We would have to have the suit data to be sure, but I get what you're saying. There's no point arguing.
Well, it's just
so, Rumpus, do you think they lost the technology to go back to the moon?
No. I mean, obviously, you've lost the engineering thing. That's why they're doing it. I mean, that's why they're due to go back there. Was it in 2025 or something? So they've obviously when you build a custom thing, obviously as effectively the Saturn V thing was, obviously you then lose the people when I don't think they document. I mean, it's all handmade, well, just about all handmade, and therefore if those people die,
handmade.
Yeah, essentially. Then effectively, obviously, when those people go, they lose those sort of individual skills. But the new way of doing it presumably will be more. The equipment will be generated in a more manufactured, normally manufactured sort of way. So the technology will be sort of inherent in, I don't know how you build things, machine built and things. So it'll be that so that we can reacquire that knowledge. But the individual people, craftsmen who made these things, obviously they died, and some of that knowledge you can't really document. You know, fiddly little things you have to do to it because it's handmade is it's almost a craft, and that obviously died with the people who then died. But obviously you can the parts of it were documented. The principles, obviously, we understand, but just the engineering particulars were held by those people who, over decades, acquired work, find out what worked and what didn't, and they did various things.
The technology decreased or increased after 55 years?
Well, no, we have more technology. We just lost people who are familiar with it. We obviously know more about it, and that's why the way we're going to be building it for the Artemis thing is more conventional production techniques rather than handmade. You can get computers and engine what is it, machine what is it called, machine making stuff, computer controlled machines building stuff, and obviously it's not in a panic at the moment. Whereas all part of the Cold War, they were building Apollo as fast as they possibly could in a race. Now, such that they presumably didn't quite have the didn't document everything as they wanted to. They just had the people had the knowledge, and that was good enough. Now, presume we'll be using sort of computer machining principles, which then will be kept. So it's like saying, have we lost the ability to build to paint? Actually, you could argue, just painting. Have we lost the skill to paint well? Yes, the painting tricks that people had hundreds of years ago is in advance of what people have now, because they practiced. It was the only thing they had in terms of the visual arts. There were more skilled people who could paint pictures hundreds of years ago than there are now. So you could argue we've lost the technology to paint well.
You know what I think? I'm thinking of like the first car that was electric. I think you had to like wind it up. I don't know if it's electric. I don't know what it was. But the first car is essentially like the first moon lander, And now we have a Ferrari 0 to 60 in 4 seconds. So now, did space go like that too? Do we have the space rocket that's going to be much more advanced and efficient?
Obviously, the technology. Well, that wasn't the question. The technology is obviously much more advanced, but the question was whether we've lost the ability to make a Saturn V rocket. And the answer is yes. We probably can't. Well, we cannot make it exactly as it was, or it would take us a good, 5-10 years to build it exactly as it was built in the 60s. But now we're building it using more modern techniques. You're getting machine building to do it, computer controlled stuff. So our level technology has increased, but we just have lost some of the craftsmen who could do it by hand.
I get that the computer technology was like an Atari 64. If that was before your time, I'm not sure, but
Atari so the technology has increased. But you asked, I think, have we lost the ability to build Saturn V? I think was effectively what your question was, and yes, we have effectively lost the ability to build a Saturn V rocket because it's basically handmade.
Well,
we don't have all those technicians.
I got that from Dave Pettit's statement. His statement was, we've lost the technology to go back to the moon. It'd be a painful process to put that back together.
Well, no, that's what we're doing. That's what's happening in 2025.
Is that a lie, or was he wrong?
They didn't just say that they lost it either. They said that they destroyed it. I know I'm not wrong about that.
You are wrong about that. So
am I?
But we are going back in 2025. Whatever. NASA's planning to go back to the moon with people. So that you'll be able to see for yourself.
So can I make a prediction?
To clarify, by the way, the quote is, "I'd go back to the moon in a nanosecond, but we destroyed the technology."
Well,
I believe that's correct.
Well, there's a combination. Yeah. Okay, if you want to the equipment, they don't have them. I mean, they don't keep the equipment hanging around to build Saturn V rockets. Okay, if you want to say that's destroying it, I mean, it's just the fact they was space. They're building.
I'm not saying they destroyed it. They said we destroyed the technology. Do you understand? Yes.
Well, do you understand that the phrase is what do you do if you start building a new car? Then you had an old set of cars using an old assembly line. If you want to use the phrase "we destroyed the old assembly line and built a new one," okay, you could use.
Did they build a new one? Did they build a new one though? They did not build a new one.
Yes, they built space shuttles, and now they're building Artemis.
55 years later, they're building Artemis
because it's incredibly expensive. So why there was a part of the Cold War. There was a race to get there and sort of plant the flag there. And there's not the incentive. There's nothing. What can you gain there? We can't go there and mine stuff and bring it back. We don't have the technology. There's not as much there to mine, actually. I think it's different from the Earth. So going there's no economic advantage to do it. There's no political advantage to doing it.
Why are they doing it then?
Then they have to fall back on it being a scientific endeavor, and there's no before it had all the money because there was a political will to do it. So therefore, why 5% of GDP of the US was spent doing it. Then now NASA's only getting 1% of GDP.
So right after,
if they upped it to 5% of GDP again, then yes, you could be rockets going there weekly. But they're not. There's no incentive to do it. At the moment, you're facing a bloody cost of living crisis. Goodness knows what. There's other things to spend. You've got a huge deficit at the moment in the US. So spending that on a rocket system or not is a discretionary spend. And in the 60s, it didn't seem so discretionary because the US was relatively richer and because there was a huge political goal to be had. But there isn't anymore.
They're doing it right now.
Yeah, I know, but they're doing it on the cheap. That's why it's taken 50 years. You're asking why it took 50 years to go back. Well, now we're doing it on the cheap, doing it slowly, doing it incrementally with the best technologies becoming cheaper and cheaper. So now we're doing it because we can justify it on scientific grounds. Whereas before in the 60s, it was just get there however much it costs, basically.
Right, so you only needed to go there once if all you were going to do was put the flag there, huh? But they had to go there 6 times.
Well, you have to build more than one.
So you went there once, right? And then the other 5 times were also political.
You have to build more than one. Imagine if they'd done one with Apollo 13. Imagine if the first flight had been Apollo 13, then it'd been propped up.
Slow down.
It's a stupid point. You're saying I'm answering the point. I'm answering the point. You're saying why did they build more than one? And I'm telling you, if the first flight they knew that something like Apollo 13 would happen, so they built more than one. It's what
yes or no question.
And the question is they had to build more than one to make sure they got there. You don't just, if your objective is to get somewhere and you have to absolutely guarantee that objective, you don't just build one vehicle that can go wrong. Rockets were incredibly unreliable. They went bang regularly. So they made sure that they were going to get there. So they had a program for 5-6 flights. And so they did that.
Okay, yes, but what you're saying is for one flight to get there, you need multiple rockets. But now you're saying for 6 flights, right? Okay, you would need that many more times rockets. So how is that economically? What do you even call that?
It wasn't an economic. NASA's
it's not.
Was not
an
economic.
Just slow down. You're
listening to what I'm saying. I'm answering your question.
You're fucking interrupting me in the middle of my point, trying to fucking answer something before I even asked a question. Okay, so what I was saying, right, is you said that the very first moon landing, putting the flag up there, is political. So how were the other 5 political? How were the other 5 political?
I'll now repeat what I said, and this is why it's frustrating talking to you. They had to build a number of them to make sure they achieved that political aim. So they built 6 or whatever, and obviously there is a scientific part of it as well. They knew also they were going to improve the technology. So it was a combination of a political aim and a scientific one, but the political one was the main aim. So they had to make sure they got there. So just building one rocket would not have been enough to guarantee it, because they knew that something like Apollo 13 was going to happen. And they didn't. So they only built one and that happened to it, then it'd be bollocks. So they also built the other ones to make sure they got there, and also to then provide them with some scientific justification, because they had to say, they didn't want to just say, well, we're going to go there, plant a flag, and go home. They did want to do a bit of science as well, and so the NASA's justification is a scientific one, but obviously it was egged on politically to say, look, we want you to get there, and and the cover for it was as a scientific enterprise as well. So the combination meant that they had to have more than one, and if you're going to make sure you're going to get there, you definitely want a few, and that's what they did. And then the other ones were, while most of the expenditure was actually building the damn thing, and one. But okay, if you build another few rockets, that's as a fraction of doing it was quite small. The overall program, I can't remember, it's 5% GDP for 10 years. Go ahead, Blue.
Apollo 17 was not supposed to be the end of it either. There were 3 more planned originally, 18, 19, and 20.
Why didn't they go through with them? Because of 13? Because of 13?
I can answer that. We were in the middle of a war in Vietnam at the time. The U.S. population had pretty much lost interest we'd already seen it 6 times, and NASA's funding was being reduced. We were trying to get our asses out of Vietnam at that time. All kinds of political things were going on. Exactly. And they said, okay, that's it. We've done it 6. We've gotten away with this 6 times. We've tried 7, made it work 6 times. That's good enough. We'll let it go. And we had pretty much covered all of the areas that we wanted to look into to see about the makeup and the characteristics of the moon. So there was no real reason to want to continue flying those missions.
Well, then why are they flying back now?
Why are they flying back now?
Yeah, why would they do that? Why would they go back?
Well, I can answer that too. It's a stepping stone and a necessary step to take if you ever want to launch a mission to Mars. You're going to need to be able to test all of that apparatus when you're only 3 or 4 days away in case a rescue mission is necessary. You're not just going to launch from Earth and aim the damn thing at Mars and hope for the best. What are you going to do if it gets in trouble? So they need the moon again for that reason alone.
So what are you saying that they're going to use the moon for exactly? Like in relation to the rocket going to Mars?
Well, I can't give you a day by day itinerary.
They sort of pointed at the moon and they hoped for the best. Wasn't that what they did? First time, first try.
Yeah, and you're 3 days away from it. If you had to go after them and do something, there was no plan for any rescue mission. Let's be clear about that. Everybody knew that. They got in trouble.
There's no testing footage of the original Apollo 11 lander either. I'm pretty sure there's no evidence that they ever even tested it to begin with.
You can't test it in Earth gravity. There's no way to test it.
But they tested other landers.
I saw a video where they had a lander and it couldn't even land on Earth. It just fell up.
They completely didn't work on Earth. But if you're gonna say, Blue, you said that. Why would they test? They had to test it on the moon. Well, that's not true. Why would they try and test it on Earth first with other landers? Or is that complete bullshit?
I didn't say anything about testing the lander on the moon, did I? You were misquoting me, misrepresenting me. I wish you wouldn't do that. I would appreciate it if you would stop.
Okay, what did you say?
They built 5 simulators that they did fly that acted like mimicked to the best of the engineers' abilities, mimicked the way the lunar lander would fly on the moon. They had 5 of those things. They crashed 2 of them. They were very, very dangerous to fly. And Neil Armstrong crashed one himself.
Mm-hmm.
But that's the only way they had to simulate it.
And
the first time it actually flew was when it flew on. The actual lander. First time that ever flew was when it flew on the moon.
Yeah,
so it was a huge gamble.
So
I've
it
seen
was never
hold on,
tested.
Jack. I've seen film footage of them simulating landing on the actual lander that was there, of it coming in at speed and landing on a substitute moon surface to see if it could actually cope with all the stresses. And that was, I presume, that must have been before Apollo 11. They were actually when they were building the landers. I've actually seen film footage of them doing that. So your claim that somehow they didn't test this lander in any way whatsoever for Apollo 11 is absolutely ridiculous.
Well, is it a simulation that they did in a computer?
Yeah.
That's it?
No,
They
this was
tested
real.
The actual lander could not fly in Earth gravity. It didn't have the thrust.
Okay.
You wouldn't be
You're
able to
saying
fly.
you can't test it. You're saying you can't test it. Remember, they're saying they tested it. So which is it?
No. You compensate, as Blue said, you then set up some system, like, for instance, you have it doing its thing, and then you put some extra, I don't know, cables on it. The one I remember seeing of simulated landings of the lander, it was being suspended partly by something. And that's how we also did the recent thing that flew around on Mars. The way they checked that would work is they put it in a low vacuum environment, and then they also put a cable on it to compensate for the increased gravity of Earth. So they set up some sort of environment that vaguely modelled what was on Mars, and they did the same thing for the lunar landers. You add some extra cabling or some other support that does not be there in real life to give it that moon-like gravity. So you can do all sorts of things to try and emulate the situation on the moon.
I made the straight. It's harder to land on Mars, but they needed a cable on Earth to test it.
Yes, correct. That's right. Because the gravity on Earth is something like, in comparison to 3 times or whatever it is of Mars.
On Mars. And 6 times what it is on the moon.
6 times on the moon. And so, therefore, the test for that Ingenuity, that was it, the name of that flying thing on Mars. So they put it in a vacuum jet, or near a vacuum. They set up to the relevant atmospheric density of Mars, and then they put an extra little, effectively a spring on the top of it to help it up to make up the difference between the Mars gravity and the Earth gravity, and then they set it off and it gets then flapped about with that. So that way you then emulate the situation on Mars on Earth.
That's exactly how they would have done it, Rumpus, because back in the day they didn't actually have the computer simulated technology.
Indeed, but that's what I was saying. I've seen film footage of them suspending the lander from a cable and then it landing on something at quite a speed to see if it could cope with the impact of landing now. So it's part of the program. So this idea that Jack is coming up with, that they never tested these landers in any way whatsoever for Apollo 11, is absolutely ridiculous. They spent years testing those various components. I mean, the amount of effort those guys put into testing everything they did was just extraordinary in the time given.
What you're saying is correct. They did everything practical, but they didn't have any sort of computer simulator at all.
No, I wasn't talking sorry, that's fucking word vomit right there. When you guys said simulation, that's what I pictured was, oh yeah, they simulated it. But no, yeah, so they did it with a fucking cable or a wire or whatever. Yes. Okay.
Yeah, you do whatever you have to do to simulate the conditions, just like a flight simulator.
I mean, that's why
And by the way, they did have flight simulators in those days. They had flight simulators prior to World War II.
And so what about the part where the lander is flying through space, though? Did they account for that? Like, how do you even know how much quote unquote gravitational force you're experiencing at that point?
Because
you can calculate the gravitational force that's easy one there on the moon. That's simple.
Yeah, that's the easy one to do. We can calculate what the Earth's gravitational field is at any distance away from the Earth. That's something we can easily calculate. And therefore, basically, what you're saying is how much rocket fuel do you need to put? Do you know you've got to put inside Apollo to get it to the moon? Is effectively what you're asking. And those calculations, well, they weren't trivial. And there are films about this, but you can work it out. I mean, even I could come close to working out.
Well, what about the gravity of the moon and the gravity of the Earth, so-called putting together? Yeah, because you're in the middle of space and you'd be getting pulled by both of them at the same time.
You can do this with a few lines of. I can do the same thing. There's a midpoint. There's a point between the moon and the Earth where they're both equally pulling with the same value, and I can draw you a graph of that. And that's with my first off thing. They had teams of people devoted to working this stuff out.
So they're saying they had to thrust more closer to Earth, and then thrust less closer to the moon. Is that what you're saying?
Well, the way you do it is you have a burn. You don't tend to go burning onto. You have a burn. So if you're in orbit around the Earth, then you at the exact point it's going to arrive, because you have to allow for the movement of the moon, of course, orbiting, and then you point where the moon's going to be, and you say, how long is it going to take me to get there? How fast do I have to get? Right, I'm now going to set off a burn for I don't know 30 seconds or something, and that'll then accelerate the thing out of orbit, and then pointing to the point where it's then going to meet the moon. They had to make corrections along the way, but they were actually very good. They actually managed to use just simple maths, modelling it with maths, and say, right, I need to do a 30-second burn here, and that will get me to the point where the moon is going to arrive and put me into orbit. And then, of course, they had to do burns to slow down to go into orbit around the moon. So the burns were few and far between, and they actually were incredibly good at getting that right.
Yeah, that was an incredibly delicately balanced act that they were performing there.
Absolutely.
You want to reach that point where the gravity of the Earth and the gravity of the moon are equal at as close to zero velocity as you can, right? Because if you get there tearing ass through space really fast, still headed for the moon, you're just going to go faster.
Good point, Brian. Yeah, I hadn't thought of that one.
And now when you get there, you've got the problem of having to use fuel to slow down to get into an orbit. Otherwise, you're on a free return trajectory.
And how do you turn around and then land upside down on the moon and to see a tranquility?
Upside
down.
That's something that I was going to ask as well.
Right?
Well, you realize there were two components there that were flying together. There was the command module and the lunar lander. The command module remained in orbit. The lunar lander separated and did a deorbit burn and slowed itself down and landed, period. That's how they did it. And it had an ascent stage then that it could use to take off from the surface of the moon. So only the upper part, just the little crew cabin. That's the only part that returned back to the command module.
You do know there were various little rockets on it to rotate it around, so it can reorientate itself however it wanted to. So this idea that you say it's landing upside down, it can rotate itself around their reorientation. They got these little reactive rocket things, or whatever they were called.
Yeah, reaction rockets.
Yeah,
reaction motors.
Reaction motors. I think they use gas rather than natural.
Well, they were hydrogen, I think.
Oh, right, okay.
Side question: is the gravity on Mars similar to the Earth because it's a similar size to the Earth?
No, it's about a third. It's not similar. Venus is similar to the Earth. Mars
How much
is not.
is it?
It's about the gravity is about a third.
So let me get straight. It's a sixth on the Moon. It's a third on Mars. Is that right?
Yeah.
Isn't Mars just as big as Earth?
Nope.
No.
It's smaller.
Jesus Christ! Yes, a lot smaller. That's why it doesn't have any atmosphere. That's why its atmosphere has been blown away, and that's why it's got no atmosphere now, because it's been blown away by the solar wind.
Maybe
it couldn't hang on, whereas the Earth can hang on to its atmosphere because the extra gravity. Because the Earth's bigger, it's got a much bigger gravity. It can hold on to its atmosphere, whereas Mars couldn't.
I think it's Venus. I was thinking about Venus is close to Earth. Yes.
Yes.
And Venus has its atmosphere.
Yes, it has a very, very dense atmosphere. The pressure in the atmosphere on Venus is 400 times that of the Earth.
So all they would need is just a submarine. They'd be fine. Put a submarine on there.
A submarine on Venus.
Ones that go
We've
into
got
water.
to get it there. The atmosphere on Venus consists partially of sulfuric acid. It's also the pressure so great that the first, I think, 4 or 5 Russian attempts to land something on there either died on the way down or died within half an hour of being there because of the aggressive nature of the atmosphere, and it crushed it.
And when you get
incredibly violent.
And when you get to the surface, the temperature is about 900 degrees too.
Yeah, 400 degrees C. The temperature. It's the hottest planet.
Right.
I think it's even okay. I think the sun side of Mercury might be warmer, but the average temperature of Venus is the highest in anything in the any planet in the solar system. It's 400 degrees. Melt lead.
Yes, it would. Mars has a diameter of 4,200 miles. Earth is about 8,000. So
quite every probe has programmed in it a little voice that says, "I'm melting."
You're breaking up, foolish.
It wasn't that funny. Don't worry about it. Carry on.
We know this.
melting.
Yeah, the internet sorted out, foolish.
Hello, Dress.
Breaking up. I mean, how can you? I mean, who was asking those questions? I mean, doesn't it worry you? You're making comments on things, and you didn't even know that Mars was smaller than the Earth. I mean, this is something I knew when I was 6.
When I was 6, I remember memorizing the planets to get an A on the test. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. And then, lo and behold, they take out Pluto, so now there's only 8 planets.
It hasn't changed size. Well, actually, we didn't. Well, I don't know. 50 years ago, we didn't know the size of Pluto. We only discovered it was more than one planetoid a decade or so ago, 2 decades ago.
Was it John Wick that took out Pluto?
Yes.
Shortly after Mickey Mouse.
I think Pluto claimed Pluto.
No, foolish. No, John Wick killed Pluto the dog, and now we don't. It's not a planet anymore.
With a pencil.
I mean, Pluto is not as big as there are some bigger planetary bodies inside the. I forgot what the stupid band is.
I saw Pluto's face on Pluto.
In the asteroid belt, there are bigger things than Pluto. The moon is bigger than Pluto, I think.
The Eris is the largest, isn't it?
Speaking of the asteroid belt, if Cavendish is really a thing, when the asteroids come back together and form a planet again?
Gravitational tidal forces is maybe something you want to look up.
Oh, I'm asking. Does anybody have any comments on that? I mean,
yes, I did. I made a comment. I said planetary gravitational tidal forces is probably what you want to look up.
Yeah,
that explains why the asteroid belt is still the asteroid belt.
So basically, there's no Cavendish happening there. There's no gravitational pull.
No, that's not what I said. I said what you want to do is look up planetary gravitational tidal forces and the asteroid belt, and it will give you an explanation.
Yeah, in other words, the other planets disrupt. If those things were just by themselves in space, if the asteroid belt was just by itself, there were no other planets, it probably would start aggregating into something more. But the presence of the other planets is preventing it from doing so.
So it's like at this perfect balance where it won't come back together. Is that what you're saying?
No. It's a disruptive, rather chaotic system, which is why we get stuff drawn in and thrown out. But what it doesn't allow it to do is to coalesce into a single mass and clear its orbital path.
Yeah, and for instance, we don't even know what the end state of the solar system will be. Whether things are going to, we believe that it's quite likely that, for instance, Jupiter and Saturn may end up crashing into one another. We also believe in the past that Saturn and Jupiter swap places. So this is a dynamic system. It just so happens, that's happening over billions of years, and this is the current view we've got at the moment. It could be significantly changed. And in fact, all the predictions, we don't know how the solar system is going to evolve over billions of years. It could, as I say, we could lose a lot of the planets, they could collide, and they're going to swap places. This is all, the modelling suggests any one of these options, and basically because it's a chaotic system, just like, the butterfly, the classic thing, butterfly causing a hurricane somewhere many hundreds of miles, thousands of miles away.
You said current view. What's the current view of how the moon got there?
Is a result of a collision between whatever it was, that a planet, some planetoid object hitting the Earth, and then causing all the material coming from the Earth, that collision going off into orbiting the Earth and then coalescing into the moon. And that's why it's
the Earth was bigger. It got hit by an asteroid, and that caused a chunk to fly into the moon, and then that formed a perfect sphere after so many years.
Well, they do tend to form perfect spheres. Gravity makes it form perfect spheres. That's inherent in what gravity does. It makes things form spheres.
Gravity must be pretty fucking strong then, don't you think, Rumpus?
It is if you have lots of material. As an individual little particle, like a little bit of sand, that doesn't apply a very strong source. But if you multiply a very small number by an enormous number, you end up with a moderately enormous number. And that's what happens with gravity.
Gravity doesn't make it.
How do all the small things come together in the first place?
Because they're the gravity is, yes. I mean, although there's a problem actually when they're very small, there was a problem in the aggregation of planets. They couldn't quite work out the theory of how, if you had a fine dust, for instance, where it doesn't really have enough to bring it together. But what they believe is that some earlier stages in these aggregation is there's some electrostatic effects that cause these things to bunch up in one way or another, and then once that gets to a size, I think, of a pebble or something, then the gravity starts to take over, and then that causes it to aggregate into planets. But there was a problem with the theory that the gravitational effects of fine dust wouldn't actually aggregate, but they believe they've solved
it. You see, that's one of the things about gravity is that they say that it's a uneven distribution of mass, right? But I mean, can they describe or talk at all about what caused the uneven distribution of mass? Because I would imagine from the start of the Big Bang, for example, that everything would just spread apart. Well, why would anything gather together?
Right. Well, that's what you're talking about. There is the quantum variation due to Heisenberg's uncertainty principle that caused variations in the inflation phase of the Big Bang. And we can see those patterns inside the cosmic microwave background radiation. You can see from the Planck satellite, which can see this history, what the universe was like 300,000 years after the Big Bang. We can see these non-uniform patterns that were caused by quantum effects, and then those irregularities gradually led to the formation of galaxies and things. And then the irregularity, and then you end up with once you've got something the size of a planet.
Isn't all that shit just total guesswork? I mean, you said quantum forces or whatever. I mean, what are you actually talking? What are they even talking about? Like,
you know what quantum effects are. You do know that your computer you're using now is based upon quantum physics principles, and that the whole basis of
explain it to me in simple terms. What does that mean?
Right. Well, things like the behavior of electrons, for instance, the transistors you've got inside your CPU, the field effect transistors, they have to do things like jump across potential boundaries, and they do so using quantum mechanical principles. So when these things were designed, the physics that would be used to generate the first transistor and then subsequently CPU large-scale integration chips was based around quantum mechanics. So you had to understand how these quantum mechanics worked and how things could jump across from place A to place B instantaneously is a quantum mechanical effect. And so there's a lot of physics, Schrodinger wave equations telling you how this will happen. And so using that, understanding that, you then so those principles are something real, and you experience effectively yourself in the fact that your computer works. Those things happened when the very small scale at the start of the universe were also very important effects, and that actually caused variations in the distribution of mass or particles at the very start of the universe. And those very small differences of only factors, I think, of 1 in 10,000 or something, because once you get a little accumulation, I mean, don't forget there's a lot of mass here. So once you get a tiny variation that's not uniform to begin with, then those things will clump together. Once you've got a great wad of mass the size of a galaxy that's slightly more condensed over here than over there, then obviously it's going to clump together, and then you're going to get it spinning round one another. So it's going to, due to angular preservation, angular momentum, it's going to sort of spin round one another, and then you have your galaxies being formed, and then from there, you get your planets formed, and off you go. So you have this initial variation.